Navy. A hearty welcome, sir. I also welcome everyone who has taken their time to be with us. Hopefully, we'll have a day of learning. First, we'll have the Captain Mohan Ram Endowment Award. I'll hand over to Shashwat Singh for that.
Good morning, Honorable Registrar, the Head of Department, Department of Technology, Officer in Charge, Naval Construction Wing, faculty members, guests, and dear students. It is my great privilege to announce the result of the Captain N.S. Mohan Ram Visis Seva Medal Retired Endowment Award. Captain N.S. Mohan Ram Visis Seva Medal was an alumni of IIT Kharagpur, where after topping the course, he joined the Indian Navy. Sir was part of the newly formed Corps of Naval Constructors and completed his training in warship design from the Royal Naval Engineering College, UK. Sir has had an illustrious naval career and was the one who inspired the vision of indigenization. The officer had the distinction of leading the team that designed the guided missile frigates INS Godavari, which was India's first indigenous warship. Sir was also involved in designing the Coast Guard vessel Vikram. For his glorious vision and exemplary leadership and service to the nation, Sir was awarded the Visis Seva Medal. To instill the same sense of professional competence and in-depth understanding of the concepts needed in shipbuilding, every year, a trainee from Naval Construction Wing Kochi is awarded the Captain N.S. Mohan Ram Visis Seva Medal Endowment Award for achieving the top position in his course in terms of academic performance. From the Naval Architecture Course 3-5, this award goes to Sub-Lieutenant Shailendra Singh. I request the Honorable Registrar, the Head of Department, and Officer in Charge Naval Construction Wing to please come forward and present the award to the deserving officer. Thank you, sir. Now I request Sub-Lieutenant Shailendra Singh to please come on dais and address the gathering.
Good morning, everyone present over here. Dr. Arun AU, Registrar CUSAT. Dr. Madhyagan Sir, Head of Department. Commander Deepak Sebastian, Officer in Charge, Naval Construction Wing. It's a great pride and honor for me to again come in Department of Ship Tech to achieve this Captain N.S. Mohan Ram Endowment Award. I thanks all my professors who have mentored me, who have guided me in this journey of 4 years, who have given me the best 4 years of my life. The knowledge that I have received here, it's tremendously a great knowledge of my entire career. And that's why I thank each and everyone for supporting me, for guiding me. The Department of Ship Tech, who has given me everything, and for uh, all the logistic support, all the mentorship, and everything. I thank Naval Construction Wing for making me capable of standing here in front of you. I thank everyone. I thank my juniors, course mates, and God Almighty. Thank you. Jai Hind, Shamno Varna.
Thank you, sir. Now I request the Honorable Registrar to please come forward and address the gathering.
Dr. Nidhyagan, Head of the Department of Ship Technology, Dr. Shivaprasad, Honorable Vice Chancellor of Technical University, Dr. Captain Deepak, dear colleagues, and my dear friends and cadets. It is happy to be here in the Captain N.S. Mohan Ram Endowment Award instituted by Department of Ship Technology for the best outgoing student of Naval Cadet. Department of Ship Technology is an inevitable part of Cochin University of Science and Technology. I had a long association with the naval cadets, especially while I was a student of Cochin University of Science and Technology, especially in staying in university hostel. I think Siberia and Sarawak was the two hostel normally allotted to naval cadets. I think they were staying that hostel. So while we are studying for our MSc course, I think we had a good association with the naval cadets. I think along with the naval cadets, I used to visit their naval base and all these places also. So I had a good memory with the association with the naval cadets. As far as our university is concerned, this department is one of the important department. And as far as the alumni of this department is concerned, they are present throughout the world. I think in majority of the places, especially where the ships are building or maintaining, I think the alumni of our department is present. As far as the naval cadets are concerned, I think the students of the alumni of our department is taking leading role in the construction as well as maintenance of naval ship as well as submarines of Indian defense system. I think in this scenario, I think the naval department, the Department of Technology is one of the important thing our university is concerned. Besides, the alumni of our this department is providing good CSR assistance to our department. I think Mudgone, Bombay, I think they are also provided a good CSR assistance to our university. Besides, Cochin Shipyard, they are also provided good financial assistance not only to the Department of Technology but also to the department DD Kaushal Kendra as well as Center for Neuroscience. They are also got their financial assistance from the ship, shipyard under their CSAR category. So when you're considering all these things, the ship technology is one of the important department. The department has to start more endowment award, not only for the cadets, but also for the other students. Then only the students will get inspiration from all this endowment award and they will do their best to come out with a colorful result and all these things. Once again, I congratulate, I think his name is Dr. Yeah, Shailendra Singh. He's got the NS Mohan Ram Endowment Award. I congratulate him for his getting the uh, Endowment Award. Once again, I thank the department for inviting me to this function. Thanking you. Thank you.
Thank you, Registrar. As a token of gratitude, we'll give a memento to the Registrar. I welcome our HOD, sir, to present the memento. That's the end of Captain Ram Mohan Endowment Award for today. Now we'll move on to the keynote address for the first keynote address today by Dr. D.D. Ebenazir on computational strategies for robust estimation of ship resistance. Dr. D.D. Ebenazir is the Associate Editor, Journal of Acoustical Society of America. He is the chairman of Hydrovibroacoustics Panel, Naval Research Board DRDO, and currently as the adjunct faculty of Department of Ship Technology, guiding PhD and MTech students in their projects. He is a retired scientist and director systems of the NPOL. I heartily welcome our beloved professor for the keynote address. Welcome, sir. Please.
Good morning, everyone. My target audience is here today, so I think I prepared appropriately. My target audience is those who are starting out on CFD or have done a couple of CFD jobs and think they've done it right. I hope that you will learn from what I'm going to talk about today. Okay, fine. So you can, as you can see from the title, it says computational strategies for the robust estimation of ship resistance. Yeah. And I don't know if you thought about these words, so I will explain what these words mean and what their significance is as we move along. What is it that we want to do? When I want to compute the resistance of a ship, that's a very basic statement. Would like to say something more detailed about that. What is it that I want to do? So I want to be able to generate a good quality mesh for any ship. There's a common comment about those who use packages that all the tutorials run very well for the tutorial job, and you try it for some other job, it doesn't run well. So if you can generate a method for making a mesh which will give you good quality results for any ship, that's very good. Okay. The second point is I need to have necessary and sufficient resolution and cell quality. This term necessary and sufficient you would have learned when you're finding the maximum or minimum of a function. Very important phrase in science. That means this is what I need. It is necessary. Without it, I cannot do a good job. When I say it is sufficient, I'm saying that I don't have to add any more requirements to this. So it's a very important phrase. So I'm have necessary and sufficient resolution. That means my mesh size is sufficiently small enough, and cell qualities, which was talked about yesterday. So the cell quality also has to be good. But all should lie in a certain range. If you try to make your resolution very high, then your computer cannot handle the job. If you make the cell quality very high, if you insist on it, maybe you cannot even generate such a mesh. So this necessary and sufficient is extremely important. The third point is rapid convergence of the resistance. If you don't make a good mesh and you run the job, you will find that the iteration is proceeding. You may have several million cells in your job, and the job will keep running and it will keep oscillating. A steady computation of resistance is the simplest one, but you will find that the iteration continues and the iteration does not converge to one solution for a very long time. Okay. So convergence does not always mean it will converge to the correct value. I can show you series expressions which will converge, but they will not converge to the correct value. So it's very important that it should converge and converge to the correct value. And the last point is that this should be useful for hull optimization studies. Today, if you go and ask shipbuilding people how they finalize their hull, they give you a vague answer. That's not okay from a science viewpoint. Maybe that's all that the industry can do now, but from a science viewpoint, that's not okay. I want to run hull optimization studies. I want to find the best hull given the constraints, which means I have to create variants of the hull with small changes, small differences, and find the best among them. So it's a very tough task. Okay. So there are some terms in the title. So I've repeated the title on this slide. You can see it says computational strategies for the robust estimation of ship resistance. What does robust mean in a scientific sense? A robust method to find the resistance of a ship includes a procedure to generate a mesh that remains effective and accurate even when there are small deliberate variations in the shape of the hull. I mentioned earlier that we're going to do hull optimization studies. I will make a small change in the shape of the hull and find the resistance again. And this procedure should work well even when I make such a small change. And it should give me answers which help me to distinguish one hull from the other, which enable me to rank hulls according to their total resistance. Okay. So as I mentioned earlier, there are many tutorials for different packages. You run them. That method works well for the tutorial package. You run your hull on it, it doesn't work. So we are interested in a method, a robust method, which will work for any ship that is of interest to me. The second keyword is robust estimation of ship estimates. Why are we saying estimation? Why are we not saying determination? Okay. In computational fluid dynamics, and equally true in experimental fluid dynamics, the resistance of a ship is estimated. It is not determined. Calculations and measurements have errors and associated uncertainties. If I ask you to find the length of this pen, you will give me an answer, some value plus minus a delta. You have to give me a plus minus delta. If you do not tell me what the plus minus delta is, I do not know how good the number that you're telling me. Maybe you'll tell me it's 15 centimeters. Maybe it is plus minus 1, or whether it is plus minus 0.01. I'd like to know that. So as part of the measurement or as part of the calculation, you have to tell me what the estimated uncertainty is. So we are only estimating ship resistance. We are not determining ship resistance. Very fundamental idea. Now, in some of your maths classes, you would have studied about Gaussian distribution, and we think that whatever we are doing will fall into this Gaussian distribution. You can see here that when I do many samples, I can find the mean of the sample, I can find the variance, I can find the standard deviation, I can talk about confidence level. So two people can do the same set of measurements or calculations. Both will come up with nearly the same mean value. But if the standard deviations are different, I will take the result which has a smaller standard deviation. So that is why this estimation of uncertainty is important. And you have to tell us, the user, you have to tell what your uncertainty is. Now, if you do a large number of computations, typically you cannot, but suppose you do that, or you do a large number of measurements, are done with only slightly different meshes. The ship is the same, and I'm going to find the resistance, estimate the resistance of the ship. There are a million possibilities for how you can generate the mesh. And if you run the computation with all these different possibilities, you will get slightly different answers. So if you plot all those answers on a graph, then you will get a Gaussian distribution. And there will be a mean value, whether it is your experiment or whether it is your calculation, there will be a mean value for that. So that mean value is of interest to us, and also the standard deviation. Now, in practice, you cannot do 100 experiments. Gaussian distributions work well if you have 1,000 or 1,000,000 samples. but you can't do 100 experiments. You cannot do 100 calculations also for any particular hull. So there are some smart ways of estimating what the uncertainty is. When you do an experiment, there are uncertainties due to your instruments, uncertainty due to the people who are doing the measurement, etc. When you're doing a calculation, there are uncertainties due to the grid. There are uncertainties due to the iteration method that is being used to solve the equations. We are often working with 20 million cells. 20 million cells means I've got 160 million unknowns. So my matrix size is 160 million into 160 million. Okay. Now this is we are doing this because of the computational facilities that we have. There are people with better computational facilities who run larger jobs. So the first thing you need to decide is what computational facility you have and how to smartly generate a mesh which will run with the computational facility that you have. Something that is very good for somebody else is not good for you, not necessarily good for you. Okay. Now, yesterday we were having a discussion about CFD, EFD, etc. Somehow, we are perhaps, I should say, born with the thinking that experiments are right. Okay. But I've seen experiments that are horribly wrong, way off from the results. The most recent shining example that I can think of is a few years ago, somebody reported that they found that some particles were traveling faster than the speed of light. Perhaps we were all in school and you didn't catch it, but it created a buzz for about 2 months. After 2 months, they said, no, we made mistakes in our experiments. It is not traveling faster than the speed of light. So we withdraw. They published it. And afterwards they wrote another paper saying, no, what we did was wrong. And this is the mistake that we made. And now it's, it is less than the speed of light. Okay. The point I'm making is, it is very easy to make mistakes while doing experiments. And I want to submit that most people make mistakes while doing experiments, and simply because they are not aware that they are making mistakes. They don't know what is the right way to do it. Okay. To get around this, what the world is doing is that we send the same sample to different labs. I was working in acoustics for 30 years. So we sent the same hydrophone to 7 international labs and ask all of them to measure the sensitivity of the hydrophone. And then we compare the results. So each person will give me a sensitivity, a plus minus uncertainty values. Then what we do internationally is we find the average of the 7 values. 7 top-notch people in the world, 7 top-notch institutions, and I find the average and I say, okay, that must be reasonable. Similar thing is being done in ship resistance. You send the same model to several top-notch towing tanks. You cannot ask the towing tank to make its own model, because when they make their own model, there are small differences in the model which will affect the results. So we do not ask them to make their own model. We send the same model. It takes time and effort, but send the same model to all the different towing tanks and then tell them to find the resistance. Then I find the average of those resistances. Okay. So that average is shown here by this line in the middle. It's a black dashed line, and that is my gold standard. There are so many other symbols on the graph, and each one represents a CFD result, a computational fluid dynamics result. And there are many people who don't have very great resources, so they use only a few million cells. And on the x-axis, you can see it's going from 0 to 36 million cells. Okay. And a lot of people are working with 4 million cells. And you can see that the errors in their computations can be quite small. And even somebody who's using close to 36 million cells is not getting a very small error. That is because the smart people who develop their own grid can do wonderful things with 2 million or 4 million cells, which the brute force people who are using 30 million cells cannot do. So just computational facilities are not enough to get you good results. That's one important point from this graph. So we took these international results and we plotted our own results on this same thing. You can see our results. All the circles are our own results, and we know what we should do to decrease the error, to get closer to the gold standard. How do you do that? You need more cells. You cannot have a serious limitation on the number of cells and still get close to your gold standard. So all the dots in there, each one is from our Chase lab done by Sruthi. And we have a pattern now, and we know that if you do this, you'll get better results. So we've generalized that, and that's what really I'm going to talk about today. Okay. Now, this is a typical mesh for ship aerodynamics. Any of you who have been on a ship or gone to a towing tank and watched the waves around the towing ship will know that this is what the wave pattern looks like. There are no significant waves upstream of the ship, and there's a Kelvin wake. So the top view in this figure is a plan view as seen from the top. And we mesh the Kelvin wake region finely, more finely than what we would do something that is far downstream. In the bottom figure, you have a profile view. And you can see that near the air-water interface, where the dark blue color is there, in that region, in this region, that is where the air-water interface is, we have a finer mesh. Because that is where critical things are happening. I'll talk more about that as we go along. But waves occur near the surface, and the effect of the waves decreases as I go further down below the ship, and therefore I need a fine mesh near the surface. So in my CFD, I have a constraint on the total number of cells that I can use. So I have to wisely, smartly allocate what the cell density will be in different regions. If I have a uniform cell density in the entire domain, that's a waste of resources. So deciding which region will get how many cells is a very important part. Okay. So next we're going to talk about critical regions for meshing. And I just told you that it is unwise to have a uniform mesh over the entire domain. And so we need to first identify what are the critical regions, and then we need to go ahead with meshing them more finely. What is a critical region? When the ship is moving in water, in calm water, far away from the ship, there is no disturbance. But there are two regions where there is significant disturbance. The first region, whatever those regions are, we need to identify, and then we need to have a high density mesh there. So the critical regions in the last line, as you can see, are the boundary layer region and the Kelvin wake. In the previous slides that I showed you, you already had a feel for the Kelvin wake, but the boundary layer region I will show you later. So in general, these are the two regions which need to be finely meshed, and I've got a decision to make how to allocate number of cells to different regions. Okay. So we'll talk a little more about these critical regions. The first is my boundary layer. As you can see from the graph, on the x-axis, I've got y, which is actually distance from the wall. And on the y-axis, I've got velocity in the flow direction. When the distance from the wall goes up on the x-axis, at some large distance from my wall, my u by u, which is the normalized velocity shown here on the x-axis, that approaches 1, and it will reach 1 after some time. But the critical region is the one that is close to the wall. You can see that very close to the wall, the slope is very high. And wherever the slope is high, wherever there are rapid changes in my velocity field and my pressure field, I need to mesh that finely. There are many curves there, and each one is for a particular Reynolds number. And as the Reynolds number increases, the slope increases, which means there's a smaller and smaller space which needs a high resolution mesh. Okay. That was a linear plot, and you cannot see the details there. Therefore, we have shown a log plot here, and same values on the x and y axis, except that now it is normalized. On the x-axis, I've got a log scale. You can tell that by looking at the numbers. You can see 10 power 0, 10 power 1, etc. There's a 10 power minus 1 also. And there are different regions. Now, the most important region that I need to mesh carefully is known as the subviscous layer. And the subviscous layer goes approximately to 5. And some people will say 10, but the subviscous layer, an analytical solution for the subviscous layer is this black line, and that approximation holds good when I'm very close to the wall. Then there's a log law region where in my log graph that appears as a straight line, and my numerical experiments, my towing tank experiments, all of them show me that that region is correct. So there are different regions in this, and the most important one is the subviscous region. Okay, this is the same figure but normalized in a different way, and I'm going to skip this. Okay. Now, analytically, people have worked on these problems, and we have regression analysis equations for this. These are not analytical solutions. These are simply curve fits, and this is an example of a curve fit which works very well for the velocity profile within the boundary layer region. Now we'll move on. Now we are going to take a look at the Kelvin wake. We said that is one of the critical regions. And here in this picture, we have shown the Kelvin wake at fruit number 3.3, and it is for a wiggly hull. The wiggly hull is an extremely simple hull. It can be, the surface of the hull can be described by using one equation, and it has been in use for decades. Okay. So if you do this analysis for a wiggly hull at fruit number 0.3, the wake will look like this. So you need some a priori knowledge or information about how the wake is going to look. And then the wake region you need to mesh. Now you can only make an educated guess about the Kelvin wake. You cannot say a priori that I know the region of the Kelvin wake. So what we do is, my first run is invariably a trial run. I guess where my Kelvin wake is going to be, and I run a job. And when I get the output from the job, I get a better estimate of where the Kelvin wake is, and what are the maximum and minimum values of wave elevation in that Kelvin wake. I use that in my next job. If you run only one job and you got only one result, okay, it's got limited value. Let me leave it like that. Now this is at fruit number 0.4, this figure, and you can see that it is significantly different from the previous case. This is actually taken from a book, and yeah, and if the wave pattern at high fruit number, you can see that the transverse waves are nearly absent. No Kelvin wave angle is clearly seen, and only the sharply diverging waves are clearly seen. The white patches that you see are all created by the propeller, and that is not part of the initial study where we are only computing the resistance. This is actually a photograph of a ship moving in water. Okay, so the point is, you need to understand what the Kelvin wake is going to look like, and the best way to do it is to first run one trial job and use that to get a understanding of what the Kelvin wake will look like, and then run it. Now, if you started learning how to do CFD by watching tutorials, etc., they tell you how to implement a mesh. We also learned CFD like that you watch videos, they'll tell you, oh, this is how you should make a mesh, and this is how you should create the domain, and this is how you should make the mesh. But the way that is done is, you first create the domain, and then you go from outside to inside. Okay. So this is, we are running OpenFOAM because it's free software, and mesh implementation comes from outside to inside. So I first make my domain and make large size cells inside the domain. Then I select some part, some refinement volumes inside the domain, and I choose and I refine them. These refinement volumes are typically those in the Kelvin-Wake region, boundary layer region, etc. But the whole point is you're trained to think from outside to inside about how to create the mesh. But that is not the way you design the mesh. When you have to design the mesh, you go from inside to outside. And this is fundamentally different. You start with layers and cells that are in contact with the ship and work your way outwards. Okay. So actually, before you start the meshing, you need to make some some assessments. One of them is how many million cells will run on my computer. If you have a laptop, something will happen. If you have a workstation, something will happen. If you have a high performance cluster, which which is being used by NIT people, you can afford something else. So as I said earlier, for us 20 million is a big number. It will take a few days for us to run the job, but when I run the job, I know at the end of it I will get a result. So I'm willing to run a 20 million job. If you're not sure, if you run a 20 million job that at the end you will get a converged result, you will hesitate to run it. But we have developed a method to make sure that I will get results after 3 days or 4 days. Okay. Sometimes industry is telling me, no, I cannot run 20 million job. I want 2 million job. Okay. So if you want 2 million, I will suggest one solution for you. If you can afford 20 million, I'll suggest another solution for you. If you can afford only 2 million, in the first line, I will say that you should use a K epsilon model. And if you can afford 20 million, we can use a K omega SST model. Okay. Now, first, having decided what model you are going to use, now you have to design the thickness of the wall adjacent layer. I will tell you some more details as we go along. This slide is showing you an outline of the thought process. So first I decide the thickness of the wall adjacent layer. After that, I design the lateral dimensions of the wall adjacent layer. So there are cells which are in contact with my ship, and that is what I am calling as wall adjacent layer. I start with the thickness and then go to the lateral dimensions. Then I'm going to have many such layers within the boundary layer, and I'm going to design the details of the other layers within the boundary layer. Okay. Finally, I will come to design the mesh in other regions outside my boundary layer. And some of them will lie in my Kelvin-Wake. But the whole point is, now I'm going from inside to outside. I started with the boundary layer, which is close to the ship, in contact with the ship. I'm going outwards. Then I will go to the Kelvin-Wake and I'll go to the outer regions. And finally, I will go to the domain. Okay. Now you can see here that when I'm designing the domain, we now design a domain that is proportional to the Kelvin wavelength. That means it depends on the Froude number of the problem. ITTC is surprisingly telling us to use a domain which depends on the length. But a ship going at different speeds, if you the cadets who stood on a ship and watched what's happening in the rear, you know that the wake depends, the length of the extent of the wake depends on the speed at which the ship is going. So to suggest that you should use a domain which depends only on the length of the ship is childish. Okay. So I've chosen my turbulence model. So for quick results, I will use a K epsilon model. For more nearly accurate results, I will use a K omega shear stress model. There are other models which one person in the audience asked about yesterday. None of them are practical for doing ship resistance calculations. Except for somebody who's doing research, nobody is using LES or any other method for doing ship resistance. Okay. Now we talk about model. When we talk about K epsilon K omega SST model. So I took a quote from a book which is by Bertram, Practical Ship Hydrodynamics. The word model is a euphemism. That means it really does not. It is not model. You're calling it model to make it sound good. It's really not a model. It's a word used is for something that is uncertain, and we have made postulates, we have made guesses, hypotheses about the nature of the flow within the boundary layer region. And we are using that to estimate what is happening in the boundary layer region. Now, finally, all said and done, only the flow in contact with the ship determines the resistance. Only the flow in contact with the ship determines the resistance. There are two kinds of forces acting on my ship. One is a shear stress, which is acting along the hull, and another is a normal force, which is acting perpendicular to the hull. Finally, to compute the resistance, I integrate these things over the surface of my ship. So if you got this wrong, your resistance is wrong. Now, fortunately, the resistance is an integral, so you can make small mistakes in the integrand and still get a reasonable estimate of the integral. So that is the basis on which we are living, we are surviving. Okay. So if you're going to use a K epsilon model, what exactly are you talking about? So yeah, I'll not go into the details of that. Okay. So now here's an equation is worth 1,000 words. This is an empirically determined wall function, and it is used in something which is known as a standard K epsilon model. The standard is a descriptive term, and in that, my flow near the boundary layer is approximated by these equations. So, and very close to the wall, I say U plus is equal to Y plus. Very close to, this is U plus, normalized velocity is equal to Y plus when my distance from the wall is extremely small. What is extremely small? Here, if you solve this equation, you will get what is extremely small. So, in my standard K epsilon model, for normalized distance maybe less than 10 or 11, I'm assuming that U plus is equal to Y plus. And a little bit away from that, I'm assuming that in the log law region, this equation is valid. And I use that. I'm not using computations within this region. There are no cells within this region. All my CFD work is done outside this. Within this, I'm using these models, and these models are based on flat plate flow, and they give me reasonable good results for flat plate flow. But in ships, there is adverse pressure gradient region in the aft of the ship, and these do not work well. But if you are restricted to having only 2 million cells, you are also restricted to this model. You cannot do much else. Okay. So, where should what should be the thickness of my wall adjacent layer? Very important question. What should be the thickness of my wall adjacent layer? So, in this log plot, that red dot shows the center of my wall adjacent cell. And that thick red line shows the boundary of my wall adjacent cell. Now, because this is a log plot, it looks as if the red dot is very close to the red line, but actually it's the center of the cell. So, we want to position the center of our wall adjacent cell such that in normalized units, it's about 200 from my wall, which is very far away, but that's what we do in a K epsilon model. Okay. So how can I estimate where I should put this? So for this, ITTC is telling me if I want my center of the cell to be at a particular value, then I should choose the physical thickness of my layer. I should choose the physical thickness of my layer by using this equation. Y is the physical thickness of the layer, and on the right hand side I have some things. And I want to put it at, let's say, 200, so I use this equation and I find out what my physical thickness should be. So this physical thickness is used throughout the ship, everywhere. Okay. And ITTC says, it uses this, it says simply scale the distance if you want some other layer. Simply scale doesn't work. We don't know any better at this point. Simply scale doesn't work. And so you have to be smart and decide how to scale it. So we have this, what we call as a target Y wall plus. I want to get a Y wall plus of a certain value. So I'm going to make a mesh which will give me that Y wall plus. Okay, so that is my target Y wall plus. My actual Y wall plus, I will find out after I run the job. And I will compare my actual Y wall plus with the target Y wall plus and see whether I have been able to achieve what I want. Now, when we talk about actual Y wall plus, if you've got okay, 1 million cells in your wall adjacent layer, you will get 1 million values. Each cell will have a different value of Y wall plus. But you started with one value for the target Y wall plus. Now you got 1 million values. So we talk about the statistics of the Y wall plus. We find the mean value, median value. We see how many of them will lie below some value, etc. So after that, you make a judgment, oh, whether this is okay, whether I can proceed. But the actual Y wall plus is typically a Gaussian distribution. Sometimes it's more complex than that. It's Gaussian distribution in some patches. Then there are a lot of outliers, complex. But my target Y wall plus, I started off with one value. So yesterday Razmia was talking about this. I'll use median values of Y wall plus and the percentage of cells with Y wall plus less than 5, etc. Such statistical analysis of what I've got. Okay. So with all that, I've got a mesh for my boundary layer region. This is what the mesh would look like. This is the aft end of a ship, and we decided what the thickness of the layer should be. Next thing, I have to choose an allowable aspect ratio for the hull print. We talk about footprint, hull print. I have to choose an allowable aspect ratio for the hull print of the wall adjacent cells. I'm going to choose a value R. Star CCM allows values of R which are close to 1000. OpenFOAM recommends 100. OpenFOAM may run with higher values, but it tells you that if your aspect ratio is very large, your results will not be accurate. Your job will run, you will get a result, but it will not be accurate. So try to keep the aspect ratio as small as you reasonably can. Once you know your A value and your aspect ratio value, then you can find the last line, the edge lengths of the hull print. Okay. So now we are in a position to progress. Here is a boundary layer mesh. You can see that the bottom line is my wall, and I've got a mesh above that, and I mesh that. Okay. Once my boundary layer is meshed, then I start meshing my Kelvin wake region. And within the Kelvin wake region, I have to think about two very important things. What is the likely maximum and minimum of the wave height? I don't know that a priori. I can make a guess. What is the likely maximum and minimum of the wave height? And the second one is, what is the shortest wavelength of interest? So the first one is in the Z direction. The second is in the XY direction. So I can need an estimate of this. So I'll start with an estimate, run my first job, and then find out what the actual values are. So this is a wave height on a hull. The fruit number is only 0.142, and you can see that there's a peak in the wave height. The minimum is not so deep. If you go a little bit away from the ship, this is what the wave elevation looks like. And if you go even further away from the ship, it looks like this. So now you have to decide what resolution you want for each of these cases. For example, here, I know my wave height, and I'm going to put 20 cells between the max and the minimum. If you don't put 20 cells between the max and the minimum, you cannot resolve that wave correctly. you will not be able to find this correctly. Now on the x-axis, we are looking at the x direction, and you can see two prominent peaks. If you don't put at least 40 cells between them, you will not get a good estimate. So you estimate what your Kelvin wavelength is going to be, you estimate what your wave height is going to be, and then you decide what should be the mesh in your Kelvin wave region. You do that estimate, and then you run your job. You create a mesh like this, and you cannot afford to have such high resolution throughout your domain. So as you go away from the ship, you reduce the resolution, you reduce the mesh density, and as in the outer regions, your mesh is not very fine. So these are the ITTC recommendations, and I mentioned that what it is earlier. Okay, if you do all this, we are suggesting that these are good methods, guaranteed to give you good results, and the result is good only as good as a method. So if you don't explain your method well to me and tell me the result, I'm not interested in your result. If you don't tell me what is the Reynolds number, what is the Y wall plus, what is the details of your mesh, but you claim great things about your result, we have no confidence in your results. So every time you report a CFD analysis, we want certain details. Now here are two examples that we have shown. Both are from KCS ship, and initially in our first several attempts to run CFD jobs on ships, we would run with 20 million jobs, and after 3 days it will diverge, it will do something. And after we learned how to do the mesh properly, every time we run a job, it will converge. And you can see that how we can tweak the job while it is running, and towards the end, you will see that the iterations are going on, but the iterations are flattened out. So I get a very good estimate of what my ship resistance is. So to conclude, mesh generation starts from the domain boundary. That's what the tutorials are teaching you. They start from the domain boundary and they move inward. Mesh design starts from the wall adjacent layer and moves outward to the domain boundary. A recipe for mesh design is being used. We have a standard procedure now. It has worked well for various ships, and it gives us rapid convergence of the results of the resistance in every case. And we plan to use this for hull optimization studies. So trial and error won't work if you're going to do hull optimization. And we are planning to use this next. Thank you very much. If you have any questions, I'll be pleased to answer them.
Sir, it was very nice and very simply explained. Sir, I have a small doubt that you are mentioning that this wall thickness of the
Yes.
cell thickness, the first cell thickness,
Yes.
or I don't know whether you are mentioning about width, it should be proportional to that Kelvin wavelength. Somewhere it was mentioning in the slides. So proportional means
No, in the boundary layer region.
Inside the boundary layer. I'm talking.
Inside the boundary layer, it depends primarily on the Reynolds number,
Yeah.
not on the Froude number.
Yeah.
Out in the Kelvin wake region, my dimensions depend on the Kelvin wake and the lambda, etc.
Yeah. So that means Kelvin wake, I don't know that Kelvin wake region will be where actually it is near boundary or?
Kelvin wake region is outside the boundary layer region.
Okay.
And what patterns you can see in the ship here, this is a Kelvin wake. This is a Kelvin wake.
Okay.
The triangular region is the Kelvin wake. That is where the disturbance of the surface occurs.
Okay.
See, wherever there is gray, water is mostly undisturbed.
Sir, where is can you just point that Kelvin wake?
This is the Kelvin wake region.
Oh, okay.
And the gray is mostly undisturbed water.
Yeah. That is
Very
the
little
invisit region.
Yeah.
Okay. Just my doubt was that it is how this Kelvin wake wavelength and the boundary layer or the thickness there,
they are
not at all related.
not related.
Okay.
This
Okay.
boundary layer depends on the Reynolds number. So you can see there are 4 lines here. Each one is for a different Reynolds number.
Yeah.
And as the Reynolds number increases, the steepness of the line increases.
Yeah. Yeah.
Therefore, my mesh has to become finer and
Finer
finer.
and finer.
Yeah,
In
that is
the-
why it is very difficult to model at full scale, where the Reynolds number is 1E9.
Yeah. Yeah. Yeah.
Model scale is 1E6, 1E7. That
Yeah. Yeah.
much easier.
Okay. Thank you, sir.
No, shallow water also, this is applicable. More complexities arise when I want to do it in shallow water. You have to do all this and something more. So shallow water is really very difficult. Not at all easy. You can run a CFD job and get a result, but it's not easy to show that it is correct. The problem with any kind of testing is that it is much harder to do a test than it is to run a CFD job. Which we don't have, we have medium level workstations, we can do this. If you ask somebody to do a test for this, so yesterday we were discussing, if given some amount of time and some amount of money, and you ask the CFD people to design a hull, and you ask the EFD people to design a hull, CFD will do a much better job. Limited time, limited money. Give it both EFD and CFD. CFD will do a better job.
That if we are having plenty of EFD results,
Plenty of
EFD results,
Okay.
experimental fluid dynamics results,
Okay.
and similarly that of the CFD results also.
Okay.
So in future, whether something like a machine learning or of this data will replace these two studies, EFD and CFD.
People are trying that because now with better computational facilities, such things are possible. But in order to use AI, I need a lot of physics-based data first. Okay, so I need typically people who are using AI for diagnosis, etc., are using 1 million samples. My son is doing that, but he's got 1 million samples to work with. For me to generate 1 million results will take a lot of time.
Thank you very much, sir. Talk. In this, we have, so you have explained really well about two regions, critical regions, boundary layer and Kelvin wake pattern. So boundary layer region, we very well have done a lot of studies on like the first layer thickness, wall Y plus, maintaining the wall Y plus and all. So in the Kelvin wake, in the second where the critical region, we are taking the Kelvin wake pattern. There, your free surface has to be meshed first. The free surface, then the regions.
Actually, it's a 3-dimensional mesh.
Yeah.
So my Z direction mesh is important to capture the wave amplitude.
Yeah.
And the XY direction mesh is important to capture the wavelength.
Yeah. Yes.
So
yes.
wave amplitude and wavelength.
So the free surface and
in that free surface region. That free surface region has all this stuff going on. So it's very complex.
Yes.
So yeah.
So in the initial study experimental results and all you presented in the initial slides, 4th and 5th slide.
Yeah.
There one black dot was there which referred to the.
Actually, there is a black dashed line, which is the average of all the experimental results.
The first one.
Yeah,
here,
black
wave
dashed
meshed.
yeah.
No, one more, that black wave meshed is that black line.
Yeah,
black dot.
Black dot is also our dot.
Yeah, yes.
It uses few more cells. All the bunch of black dots here used 15.6 million cells. Here we used 18.6 million cells.
All the circles are ours?
All the circles are ours, including that black dot.
Yeah. Okay, so in the Kelvin wake refinement, Kelvin region, what all specifically we should follow? Like for the boundary layer region, we say some valid points like that. Can you list out some very important things that has to? It's already given there.
Okay. So actually, if I want to replicate this wave elevation, there are two very simple things I can talk about. I need to find the value of this peak and this valley. Those numbers I need to get correctly. So that is in the Z direction. So I want to get the wave max and wave minimum correctly. I also want to get the wavelength correctly. This is in the XY plane. Wavelength is the distance from here to here. So I need high resolution in XY plane. I need high resolution in the Z direction.
That is a mesh strategy.
Yeah.
Thank you. Thank you, sir.
Okay, thank you.
Thank you, Ebenezer, sir, for that insightful talk on mesh design, turbulence modeling, and ship resistance estimation, and the discussion on CFD versus EFD. Now, as an appreciation, we would like to present a memento. I'd like to call Dr. Shiva Prasad S. to present the memento to Dr. D.D. Ebenezer. Please, sir, please come forward to present the memento. Thank you. Thank you, sir. Now we'll have a tea break and we'll be back by 11 a.m. Tea and refreshments are provided in the hallway. Please be back by 11 a.m. for the second keynote address, Decarbonizing Marine Transport, What, How, and When. Thank you. Welcome back, everyone. We'll proceed with the second keynote for today by a remarkable individual, industrialist, and entrepreneur, Mr. Sandit Tandashiri. Mr. Sandit Tandashiri is the founder and CEO of Nawad Solar and Electric Boats and Navgati Marine. He graduated from IIT Madras in Naval Architecture and holds an MBA from INSEAD. His notable achievements include designing and building Aditya, India's first solar ferry, which won multiple awards globally. I welcome Mr. Sandit Tandashiri for the keynote speak on decarbonizing marine transport. What, how, and when. Please, sir.
Morning, everyone. I think yesterday and today you might have been inundated with a lot of FEA, CFD, and various other things. I hope you grasp those and utilize in your future. But today I'm going to tell you why you need that so that you can link to finally decarbonization. That's my purpose. So here we are talking of, when we say CFD and other stuff, we are talking of how to reduce the energy need. That's one important thing. And the second thing is changing the energy source. So these are the two things you need when you do decarbonizing. So for most of you, I don't have to tell you why we need or why we are talking of climate change and what is the impact. So we are all clear. I don't have to educate you on that. And we all know that the major impact of climate change is CO2. It's about 75% is carbon dioxide. And that's the focus of today's session and decarbonization also. So from overall carbon emission perspective, transport, when we say transport means road, rail, water, and air, is about 17% of carbon emission. And what I am going to talk today of marine transport is about 2 to 3% of this. Now it's surprising and very important that marine transport carries 90% of the cargo, yet it has a lower emission, which is why the ships exist, right? Now, in this, we must remember that sun is more than sufficient for us to take the journey of decarbonization. Now, the question is, can you use energy from sun alone directly? The answer is obviously no, and which will come to that. But if you see the overall, sources, it could be directly sun from solar panel or indirectly through wind or hydro and various. So these are sufficient for our energy need. So if you want to get a feel of that, the alternate of storing the sun energy is a hydrogen, which also will come. Any such clean fuel like hydrogen, which we will talk about that. So combination of direct use like solar, wind, hydro, and some storage like hydrogen or some liquid fuel, clean fuel, is a solution. That's a broad perspective I want to tell first. But just to give up the feel of the energy, what you see as the black spots in each continent, right? If you have the solar panels to that size, that is sufficient to power the entire continent. So if you see India, there is a small area there on India, right? So if you see that area here, this is sufficient to cover the energy need of the entire country. All the energy need. So this gives an idea about the quantum of energy we are getting from the sun. Right? So if you have this in mind, you know that energy from sun is sufficient. Then the question is then storage and various other technologies. Now, because sun emits or provide you energy only on some part of the time, which is typically 9 to 5 in the daytime, you end up with a situation where the storage becomes crucial. So in many countries which started adopting solar in our grid, like for example, if you take Australia or Germany, who are the leaders, now the tendency is disincentivizing people not to feed into the grid. That is what is happening in those countries. Because beyond 30-40% energy source into the grid from sun, then the grid becomes unstable, which is also why we always hear the news why KSAB is discouraging solar installation at home indirectly, is because the more you feed into the grid, the more unstable the grid becomes. Right? So unless you have some storage, which is why many of those countries like Australia and Germany have moved to storage also, grid storage. So you need sun plus some storage. Today in India, the economics of storage is very low. Hence, we all like to just put a grid tie inverter at home, feed it to KSEB, and we hope KSEB gives us the same price as what we feed in or take. So this will change automatically. So there is a gross metering coming already. I don't know if you're aware. So there is a differential pricing. So the daytime energy will be cheaper. Evening will be the most expensive, like 6 to 10. So there will be a differential pricing coming. So eventually that will encourage people to go to storage. So all their energy consumption, like running your heavy energy uses, like say washing machine at home, you will shift to late night. This is already a practice in these countries I mentioned, but naturally we will also follow suit. So this is just trying to stabilize this curve. So what you see is what is called as a duck curve. So as you add more and more solar, it becomes worse as you go down. So that's what has happened, what you call as a duck curve here. Now, among the various transport, the easiest to electrify is rail. The reason is obvious, because while you are moving, you can connect to the grid. So rail is that special transport system where grid is connected while you are moving. So which means there is no sense in putting solar panel on rail, on a train. Although you would have seen, I think a couple of years back, Ministry of Power had put some solar panels on a train, electric train, on a normal train. It doesn't make sense, because it is logical to put electric train and you put a central storage somewhere in cheapest place like Rajasthan. You make a big, large central solar plant, feed to the grid, what we call as a wheeling. So you feed the power there and you can take anywhere in India. So if you do that, that is better than putting solar panel on the train. So anything that is connected when the energy is being used doesn't make sense to put the system or solar on the system itself. So that's what trains are. So ideally, we should shift to electric trains, which we are already doing, and make the energy source to green, which could be solar plants installed in various parts with some kind of a storage. Now, the second easier is road. Why I say second easier is there is a technology available where these cars or trucks can be charged while the vehicle is moving. There is technology available, but it's not yet commercial. Eventually it will come. So there are some road sectors already in place, short demonstration, where while you are driving the car, it gets charged by surface without contact, non-contact charging. It's more of like how induction charging works. But this, like how you place a phone on a surface and gets charged, right? Some similar technology, not exactly similar, but same approach, that you don't need a direct contact, but by induction. So this will come. Today, cars are still not economical. Electric cars, I'm saying, I use an electric car, but I'm still saying electric cars is still not economical unless you are running very long, unless you're running 200 kilometers in a day, things like that. So asset utilization then becomes a key thing. So why I'm saying this is, it is not just technology alone which drives change. You need to have the economics also. So in case you thought that economics was not important in your technical education, I want you to change your mind that economics is one of the most important subjects you are studying today. And that is what will drive any technology change. So while as an engineer, I will keep thinking that engineering and technology is the most important. But in reality, world runs on economics. So you need to get the economics right. This is my fundamental premise, and that's what I have seen in practice when I try to do any technology adoption in this area where I am focusing. the marine and aviation is very difficult to decarbonize. I'm saying on the larger scale. Now, we will talk where it can be, and that is what is the crucial part we should focus on. So this element of technology economics going hand in hand is something we must remember, and that is a key to anything what you do in your career or in your attempt at any of entrepreneurship, which I hope some of you will do. Now, what has happened over the last few years? Why are we talking more of electric cars and solar plants, etc.? This is what has happened over the years in solar plant prices, which has significantly dropped in the last few years. It started with about $1,000 per kilowatt. It's like very low now. It's 0.2, 0.3 range. This is only possible because some person, it's not just one person, multiple people who have taken a bet, a risk in installing a larger plant of solar at some point. And then because there was a scale, the price could be lower. And this was kept on iterating. So when we started our journey in 2009, when we built our first boat, which I will show you also, at that time, the solar panel plant was more or less like 3 times where we are today. So this is also a reason why that first project for us was not economical also, which I will show you. But this is something that has happened fundamentally, and this may also reduce further. But we are already at a place where solar panel pricing has very, very attractive. It's like 2 to 3 rupees per kilowatt hour is the energy cost from large solar installation. So you know that KCB, we pay 5 to 7 rupees if you are paying an electricity bill of 500 rupees per month, maybe slightly more if you are closer to 2000. But the cost of solar energy on a large installation is 2 to 3 rupees. That's how low it has become. Of course, hydro is even cheaper because for a different reason, because it's a one time and it just lasts forever. But solar, this has come very, very attractive. But we are not having large scale adoption because of the other reason I told, which is that grid stabilization. The second thing is the battery. So storage, what is happening today? Again, this lithium prices have again significantly dropped. Today, so when we say electric cars are still not economical, what I meant is without the subsidy provided by the government in terms of FAME scheme and other things. So if you remove that subsidy, it is uneconomical suddenly. But today, now, if you see if you try to buy lithium cells from China, for example, you may get at about $100 per kilowatt hour. But if you are buying in megawatt hour, you may get at half the price. So this is what usually the car companies buy. So this is also driving the economics to a large extent. Now those 5 areas, for some strange reason, presentation is cut, but the point is there is this 5 sources of energy: the grid, the solar, wind, hydrogen, and the diesel or whatever fossil fuels. These are typically anyway 5 sources of energy we can have in any vessel, right? So, and in terms of, when I talk today, these 3 areas I will cover, which is small boats, medium size, and large. And these technology choices are different in these 3. So the example I told about that first boat, 2009, when we experimented, this was then to demonstrate that solar boats can be equally fast as a normal boat. So it's more than a decade old. But the point was, at this time, the economics didn't work because solar panels were 3 times as expensive as today. The lithium price was also almost 2.5 times more. So this was a good demonstrator project, but not economic. And that is also the reason why tourism projects didn't take off at that time. Even the fishing, which we just did a retrofit project, these are lessons you learn when you try to experiment, right? Fundamentally, you can have theoretical knowledge, like Ebenezer said about theoretically estimating CFD. But in entrepreneurship, theoretical knowledge is almost meaningless, because unlike physics, prediction on a success of market is nearly zero. So you have to venture and then see whether you will work based on the feedback you get from the market. So that's driven by purely economics. So when we then set out which area might be economically viable, so you need that asset utilization. So when I told you the example of car and told you that these cars will work when you run 200 kilometers daily, the same logic applied to a boat. So the boat, when you do a solar boat, it can't be that you make a solar boat and you run it for 1 hour. Then you will never break even the cost difference. So you need to have something running for 10, 12 hours. So naturally, it was public transport at that time. And that is what we then shifted to, which is what I think what she referred to as Aditya was that public transport is the first project, which was really the first one we could make it economical. So apart from the other benefits like air pollution, water, noise, vibration, smell of fuel, these are great things. But fundamentally, whether we are able to solve the problem of the client in high operating cost, that's the fundamental problem. And this is the one, even when you try, even today when I try to sell a solar boat, nobody cares that the boat is green, the boat is not causing pollution, etc. Do you make money? That is the only thing that will matter. The rest all is bonus. So fundamentally, you have to make sure that because the boats are slightly expensive, 20, 30%, can they make money in the next 3 to 5 years? That's the only. So when you set a similar problem, I just telling the pathway only to give you a feel that the first part, what I talked about design, which CFD and other things are, can you reduce the energy need? Right. So one element is by changing the materials, reducing the weight. So this is what we tried. So a 35-ton boat can be 17-ton from steel, wood to composite elements. So this is one element. Second element is what I think Abnesar sir would have covered on CFD and other things. So can you reduce the drag, right, by optimizing the underwater shape? So these things, so from a combining weight as well as this, you get a net effect of 45 kilowatt to 15 kilowatt. So this is the purely design. This has nothing to do with solar electric. So this works in a diesel boat as well. What you have done today till this step means you are reducing the diesel consumption by 1/3. So this is it. This is fundamentally needed when you go to solar electric, but not necessary when you are doing diesel, which is why most of the boats in India or many of us similar developing nation where the boat building is still decentralized and done by small players, there is no serious effort in design. So if any of there are all the faculty members here who do consulting for various boatyard here, and they know that none of these small boatyards will want to optimize a hull form by using CFD. Only larger projects, there is this challenge. Although it makes logical sense, even if you can say 1%, 2%, 5% fuel, for the next 20 year, 30 year, you are saving fuel. The cost of CFD is so low. So it's a no-brainer, yet people don't do. That's just what I want to place there. But on a solar boat, this is necessary. And so the other element is shifting the energy source from diesel to electric. So that's like battery. So that obviously, when you take a small diesel engine, the cost of mechanical energy, what you get. So if you say 1 kilowatt or mechanical energy or the torque you get on the shaft, right? Torque omega, what you get as a power, that is about 30 to 35 rupees in a diesel engine. Whereas on an electric motor with a grid cost of 7 rupees, this becomes almost close to 10 rupees. So just by shifting a diesel engine to motor, your cost of mechanical energy, which is just purely abstract mechanical energy, is 1/3. Right? So that's the benefit why electric cars have lower OPEX than a diesel or petrol car. But the second element, what we try to do, or what we did in Aditya, is make the boat bigger than what you actually need for 75 passengers, so that you can have a larger solar plant, so that 70% of the energy is from sun. Therefore, the 10 rupee can become 3 rupees, right? So that 35 become 3. So 1/10 reduction if you make the boat bigger and add solar panel. So this shift itself is contributing to 1/10, and the previous design is 1/3. So it's a 1/30 times drop in operating expense if you do these combinations. That's what many applications you will have this benefit. Then, of course, you need to have very highly reliable, redundant lithium batteries, which need marine certification. This is normal safety standards. When you do go shift to a new technology, you should give a solution which is better and cheaper. There's no point in giving something which is better and expensive or not so good and cheaper. So if you want to drastically change a system, you need to give something which is better and cheaper. Then only this will be adopted. And having a safer system is a key to many of this shift. So this is just, so Aditya is now, next month is a 9-year operation, 9 years. So it's about 30 lakh passengers and it's about almost 3 crore rupees in fuel saving. So this is a very clearly a model which is being replicated. So there are about now, by end of March, there will be about 16 similar ferries operational in just water transport department itself. So I will, can you just help me? Yeah, so similar to Aditya, there are a few other public transport projects which have a same logic of asset utilization. But what has happened in the last few years, because the lithium battery as well as solar panel prices have dropped, the economics of tourism projects, which was not working 10 years back, is now working. So now there are again few more tourism boats which are already plying in various parts of India. But in total 40 boats in 11 states, it is already there. So fishing is another interesting area where these economics is slightly challenging, but because government is already subsidizing the current fishermen in terms of boat, engine, and even the fuel, if you translate that, this can work at a larger scale. So this is still in the, I would say, discovering the economics. It's not yet economical, but there are some structuring the finance, this may work. Ro-Ros. So any place where these ferry boats work, it makes sense to have Ro-Ro. For example, you must think of a wide area like Vaikam Tavanakode is an example, or any place in Ganga River, where the distance is more than 3 to 5 kilometers. The cost of a bridge is about 500 to 1,000 crore. So it makes sense. You can't have bridge every 20, 30 kilometers. You may have it every few hundred kilometers. So if you cross Varanasi, the next bridge is few hundred kilometers away, across along the Ganga River. So similarly in Kerala also, in Vaikam, there is a bridge in Tanirmukam side and the new one which is coming 3-5 kilometers away. So still it makes sense to have some means of transport. So this will exist. This will be a solution. So we are also trying to get this solar electric. It works on, so most of these applications, solar plus battery works. And then, yeah. So faster vessels. So the one which we are doing on the left is the one we are doing for the Navy, which is a fast electric boat. It's at 12 knots. When I say fast, it is comparable to the previous one. So it's about 12 to 15 knots, 30 passenger boat, which they want. But in case of patrolling, which is on the right side, it's more like a hybrid. So the chase mode is diesel, whereas the patrol mode is electric. So something like that. So these are, again, new applications I'm saying. So there are many things which are happening. The one which we think it makes sense on these faster vessels, but shorter distance. This technology, hydrofoil technology, is very old. It's a 75-year-old technology. There are diesel versions running already in Hong Kong, Netherlands, etc. And there are smaller electric versions running all across Europe already. Candela is a very, very famous brand for this. But again, it's a 25 crore boat for a 30 packs. I'm just telling Candela's number, but that will not meet the economics in India. So unless this boat of 30 packs becomes about 10 crore, the whole thing will not work. And that is exactly what we are trying to do. So maybe by end of next year, we'll have a demonstration of a smaller version, about 10 meter, to test the technology of hydrofoil, which is, the key is, can this work on a 1 to 2 meter wave? That is what is the key here. So it can't be working only on a still water. So you need to have that 1 to 2 meter, especially on a sea mouth, can you do? So we need to test in Cochin water to make sure that this is a good solution for short distance or slightly longer distance, but very fast. This is, when I say fast, it's like 30 knots, speed. Can you? So typically when you do hydrofoil, the energy need is like 1/4 than a planing hull. So that's the key advantage of hydrofoil. And that is, but the challenge is the handling the waves. And that is what we are seeing. So this is a project which we are trying to do and see whether this works, both technology and economics. Of course, already there are these projects happening in ASV, USV, so many things are happening. I'm just telling you a spread where the technology is already in play, and amphibious, some of our experiments. Green Tuck, this is a very interesting project where the government policy itself is pushing towards this direction. This is a first policy where there is a mandate for the green as a solution. So there are about potentially 200 of them coming should be coming in India in the next 5 to 6 years. Cochin Shipyard is already building one, Chogle and Mandovi. There are 3 projects already announced. But this technology need just battery tech. There is no new thing needed here. Already technology is there. The economics is slightly challenging, but because of the scale of the battery, it may achieve that economics is what we believe. But the government is giving subsidies, so this will work. So anybody who is working in this space, this is an area which will be really big in the coming years. Then barges, inland barges, as well as coastal vessels. This is already a World Bank project. We have completed the design of this vessel. It's a 1,000-tonner, which is pure electric with some wind assistance and an ability to swap as a container battery. So the plan is to have it National Waterway 1 across, then Bangladesh and go all the way to Assam. So we hope this goes to construction stage. Now the design is completed. It's a World Bank funded. So it's a phase 2 is hopefully in the next couple of years, this might be interesting. But the challenge when we talk of the bigger vessels, what we say as a decarb. So I talked about the design as a means of reducing energy need, which is all the various technologies on the top side. You may not read this, but the point is the whole of these available on the larger ships, because we do this performance analytics for the large ships. We help them assess the benefit. But we feel that any of the large ships, first thing is reduction of energy on the top side. And on the lower side is shifting the energy. This will be eventually going to some liquid fuel like hydrogen. Nobody knows what is the right kind of fuel. We are every ship owner, because one person cannot drive the change. Whereas in boats, for example, say a person like anybody, like let's say example, I can say, oh, I want to shift the boats in Kerala towards an LFP battery technology. This is possible because you can influence the change by demonstrating. Whereas in the large ships, one person cannot do that. So you need a lot of ecosystem play. And that is why if you ask any ship owner, what is the future energy in 20 years? Nobody has this answer. But I think there will be a combination of hydrogen with some better way of storing energy of hydrogen. Hydrogen today, in terms of liquid, is still occupies 3 times more space than a diesel of equivalent energy. So that will still need to change. Might be a better way of storing hydrogen. And that is what will happen in the future. It's what I anticipate. So that we can have a green ship, which is ultimately, it's still a 10-year away. But since you are going to the industry in the next 1-2 years, this might be something which will impact you in the future. So eventually things will go to green ship maybe after 10 years. But if you choose a direction where you may have an impact, you may have a contribution, that might be a sensible thing to do. And as far as we are concerned, for us, it is going this path. So we have about 77 boats of electric boats operating in total 11 states in India, 4 outside countries like Canada, Israel, Maldives, and Seychelles. And we hope to make a bigger impact in the future in this pathway, making faster ships as well as bigger ships, so that we can achieve what we intend to do, our vision of cleaner and quieter oceans. Thank you. Do you have time for questions, or is there a... so.
Any questions?
Questions ഒന്നുമില്ലെങ്കിൽ അതിൻ്റെ അർത്ഥം ഒന്നല്ലെങ്കിൽ ഒന്നും മനസ്സിലായിട്ടില്ല, അല്ലെങ്കിൽ എല്ലാം മനസ്സിലായി, ഒന്നും അറിയേണ്ട
topic,
ആവശ്യമില്ല.
right? Your father or your parent want to purchase a car, they'll go for electric car or diesel car or petrol car. So like that, being naval architects, definitely in future you may think about having a yard or small boat or something. You can ask some questions, some imaginary questions also. So he is a successful entrepreneur who is working in Kerala, which is having lot of red tapeism. So I should appreciate him. You can ask some questions.
Sir, why you are not offering hydrofoil descent Navy?
Why are we not offering? In fact, the IDEX project I showed you, the one we are giving for Navy. So version 1 is a normal hull, as a high-speed hull with 12 to 15 knots. The version 2, we are trying to pitch a hydrofoil version. So which we want to do once we show the demonstrator on a smaller boat, so that we know we have a control on the technology. Because once you go to the Navy, you need to have a bit more robustness in your technology, because Navy needs reliability. Although even IDEX is a joint development, even then we need to have a clarity that this technology works for what. So this is the way we try to do. So we are confident of the technology, then we'll obviously go to Navy. So Deepak is also here. He may help us influence these things.
Any other questions?
Yeah, this.
Just curious because I do not know the technology behind the battery power. So this is something like we are talking about shifting to a different source of energy like battery. But how clean is the development of battery technology? The reason why I'm asking this question is, this thing comes from a secondary source. I heard about this research done by Mercedes-Benz while they were doing shifting to electric cars, and the amount or the pollution that they create in developing their battery technology was far more than what you would expect from fossil fuel. So how much of thought or how much of what do you say? I mean,
Whether battery and solar is green as what I claim. Is that what you're finally the point?
well, solar energy is clean. I agree. I mean, no doubt about
No,
it. But
end-to-end carbon emission. That's what you're saying. Life cycle emission.
Yeah.
Yeah. So,
Yeah.
okay. So in any technology, even if somebody comes and tells you solar, as you said, solar is clean, what we imply is cleaner. We never say solar or battery is zero carbon. There's no technology today which is zero carbon. The key is, can we reduce the carbon emission? That is the key thing. So in the two things I will talk of. One is the solar panel itself as well as the battery. Both have the same criticism that whether it is really clean, because there is energy required to manufacture solar panels. There is energy required to manufacture batteries. Now, when we do this, we should also remember there is a cost and to manufacture 1 liter of diesel as well. So we tend to compare the tank to wake. What we say is there is, let's say, there is a well, tank and wake. So well is where the source of fuel is. Tank is on your vessel and the wake is what you produce on the vessel. So typically when the emissions, the number I talked is all about the tank to wake. So which means in the vessel or in the car. But there is this well to tank emission, right? So what we need to extract crude oil transport to a refinery to convert to petrol, and then petrol to reach your fuel pump, and the pump to get to your car. There is this chain also. So when we do this comparison of life cycle emission, which is covering all this, a solar panel to produce 1 kilowatt of solar panel or 1 kilowatt panel, the amount of emission required to produce it is equivalent to 1 year of production. So which means 1 kilowatt of panel, for example, can produce about 4 kilowatt energy in a day. And that 4 kilowatt, if you multiply by, let's say 300 days, is 1200 kilowatt energy, what it produces in a year. So that 1200 kilowatt hour energy is what is required, equivalent carbon emission, for making 1 kilowatt of solar panel. But you should remember this, solar panels are designed for 30 years. So that next 29 years, it gives you the positive side. In lithium battery, it's slightly higher. It's not 1 year. It's almost 2.5 years. So 1 kilowatt hour of lithium energy battery require almost 2.5 years equivalent of carbon emission. But then it lasts for 7 to 10 years. So that is what I meant by there is this net positive benefit when you shift from a diesel. So 1 liter of diesel needs almost half the energy for production, this refining. Like for example, Saudi Arabia, the oil you get, if you dig just by a spade, you may get oil. So the cost of production is less than $1 in Saudi Arabia. Whereas you go to offshore like Norway, for example, that's very high. It's $20, $30. So that is the cost of energy. So 20 to 30% of your energy is your energy cost. So the simple answer to what he broadly meant is that when we shift to solar and battery, there is pollution, there is no doubt, but it's far less than your current system of using still diesel. So nobody is claiming solar and battery is zero. It is reduction in where we are today. And the numbers I gave you is 1 to 3 year instead of the 20 or 10-year life cycle. I hope. Yeah. Thanks. Yes.
Sir, I have a doubt myself. You mentioned in one of your slides that electric and solar powered vessels are more efficient when it comes to smaller vessels. And when you move on to larger, more vessels which you work in, like global merchant transport, is it even relevant to pursue like electric and solar research for such vessels? Or should we move on to find other sources like nuclear or any other?
Yeah, so nuclear is definitely an option. It's a debate whether nuclear is really green. There are few people who think nuclear is not green. There are few who thinks it is green. I am more on the right side, but that's a personal opinion. But nuclear is definitely a source of energy. But if you forget nuclear, any other source of energy, it is a good thing to shift to electric as a system of energy in the vessel. Like, for example, all the cruise ships today, without having any battery or anything, they are already electric propelled ships, which means the motor is what drives the propeller. What drives the propeller is what I'm asking. So motor is what drives the propeller. But the source of that energy is today diesel engine in the cruise ships today. So shifting to electric as a system on the boat, on the vessel, will happen mostly. The second thing is, can the source be entirely some clean instead of diesel or heavy fuel, which is there in the large ships? In my view, eventually the cleaner fuel will come in place. So LNG is an interim fuel. So most of the new projects are LNG, but there are already projects on e-methanol, e-ammonia, and hydrogen in that space, which is a cleaner one, or even green bio, correct? So these are all the method of creating that energy is green. And hence that energy, even if you produce a CO2, it doesn't increase. Like when you say green hydrogen or green methanol or ammonia, or even bio, although biogas methane is still producing carbon dioxide, but it is extracting and then releasing. So there is no net increase is the idea of that. That shift will happen until we find the right clean fuel like hydrogen. I'm not saying hydrogen is the one, but hydrogen doesn't have any carbon emission. So hydrogen is ideal that way, but it still have the limitation for the large ships, what you refer to. Hence, I told you that we still don't know what is that energy on the large ship, but it will be electric for sure as a system, and some green fuel which provides that electricity on the ship through a fuel cell or equivalent. This is more or less agreed by most people, but what is that energy is not agreed. So it makes sense for you to still work on that area of electric vessels. But even the large ships I told you is 10 years away. But the medium-sized coastal and all will go electric in the next few years.
Any other questions?
Yeah.
You had described a boat. I remember it was yellow in color. You said it was hybrid. So, but if your company's goal is to go, well, reduce carbon emissions and, well, as your motto states, oceans electrified. So why would you go to hybrid?
So it's a very logical question. If you presume that my claim is to go to zero emission immediately.
No, not zero emissions, but to reduce carbon emissions.
Yeah. So when you do hybrid, it is reduced. So what are you doing today? Those vessel, which I told you, a petrol vessel, like Navy has the FC series, FIC, fast interceptor craft. There are 80 vessels which do patrolling. So these are 15-meter boats which have two water jets of, I think, 750 kilowatt power diesel engines. What do they do normally? They run this 95% of the time in patrolling mode, which is 6-8 knots, yet using these big engines and water jet. So that model is, or mode is where the highest fuel consumption is. In the rare scenario where they need to chase is when they really need the diesel engine. This is the premise. So what are we doing? Either I can tell two options I have. I can say, okay, this vessel can be greener. I'm using the word ER, relative. Greener, if I shift that petrol mode to electric by introducing a parallel hybrid, so that in that mode, that 95% of the time, you don't have an emission. And the chase mode will still be diesel. This is option one I have. So it's a hybrid vessel. Option two is I say, no, I will wait till the technology is ready for this vessel to be completely green, some hydrogen or equivalent fuel. So I wait for 5 years. I have two options. Which do you think I should take?
For now, one.
One. This is what is hybrid. And this is the reason why hybrid exists. Certain applications cannot be 100% green today with the current economics. It's an economic decision. It's not a technology play. It is because of economics. Hence, we go to the interim step of hybrid, which is still greener than the first.
Okay. Yeah. Thank you, sir.
Thank you. Okay.
You mentioned about lithium battery. What about our water metro here? Is it a lithium battery, or can we do some research on the battery type so that it can be more economical and cleaner?
Okay, so water metro is also lithium. So lithium could be the most popular on marine are LFP, lithium iron phosphates, or lithium titanium, LTO. So water metro is using LTO, and most of our vessels we are using LTO, LFP, except the RoRo we are using LTO. Water metro, my criticism of the choice of technology, which water metro did is, you can see the outcome. The boat is then 8 crore. It's one boat is 8 crore. Today, that same boat is about 15 crore because you know the West Bengal tender was 15 crore. Same boat, 100 passenger, 150. My criticism in choosing a technology is if you don't care of economics, you can choose L2. I have no issue. But if you think that can you break even that 8 crore boat by fuel saving, practically you will never do. But certain transport systems where we don't care about economics, they don't care means, unfortunately, they didn't care, but logically they should. There, the fact that water metro runs about 50 kilometers in a day at 8 knots, that's the speed they do. In that operation, it would have made sense to go to an LFP, bigger battery. The boat would have cost about 4 or 5 crores with that kind of range, right, at 8 knots. If the same question is water metro at 12 knots, then my answer is different. If they say I'm going to do 100 kilometer in a day at 12 knots, then LTO is a better technology. It's more economical technology. So that choice is not a broad LFP versus LTO. When that shift, when LTO becomes economical for 100 passenger is closer to 12 knots, 100 kilometer range in a day. So range and speed defines that. So range per day, and the speed. So Water Metro, in my view, and I have published this also, I've given to them also, in my view, has taken a wrong choice of LTO, given that they are going to run at 8 knots and 50 kilometers an hour. Whereas if they are doing, like in Mumbai, Mumbai needs faster boats. Mumbai, if you're doing at 12, 15 knots, 100 kilometers in a day, LTO is the right choice. So depends. Here it was a wrong choice, but yeah. Okay. All right. Thank you very much.
Thank you, Sandit sir, for that insightful talk on marine transport decarbonization and the economic aspect. Hopefully, we'll see our oceans electrified. As a token of appreciation, we would like to present a memento to Dr. Ebenezer to Mr. Sandit Tandasheri. Please come forward and present the memento. Now, we'll move on to the first technical session for today, numerical structural analysis. The session is chaired by Dr. D.D. Ebenezer and co-chaired by Dr. Fawaz TK. Dr. D.D. Ebenezer holds BTech in Naval Architecture from Indian Institute of Technology, Madras, MS in Ocean Engineering from University of Rhode Island, USA, PhD in Ocean Engineering from University of Rhode Island, USA. He is the chairman of the Hydro-Vibroacoustics Panel, Naval Research Board, DRDO, the present associate editor, Journal of Acoustical Society of America, present adjunct faculty, Department of Ship Technology, CUSAT. His areas of interest include stability of ships, marine propulsion, sonar, underwater electroacoustics, analysis and design of structures, and computational fluid dynamics. Please, sir, assume as the chair for the session. The session is co-chaired by Dr. Fawaz TK, former assistant professor of the department and currently working as the associate professor IMU Kolkata. He holds a BTech in mechanical engineering from GEC Thrissur in 2022, an MTech in refrigeration and cryogenic engineering from TKM College of Engineering, Kollam, with second rank under University of Kerala in 2004. He obtained his PhD in mechanical engineering from NIT Calicut in 2018. He has more than 15 publications in reputed journals and international conferences. Please assume as the co-chair. We'll begin the session shortly. Thank you.
It's almost noon. Good afternoon, everyone. We have 6 papers in this session, and we know you'll all like lunch on time, but you'll have wait a little bit today. You'll have lunch at 1:30 so that the speakers get 15 minutes to talk. And I presume everybody is here. I've seen many of the presenters here. So first presentation is by Kiran.
Kiran AK, from Naval Physical Oceanography Laboratory, NPOL, and his title of the paper is Finite Element Structural Analysis of a Ship-Borne Sensor Array Structure. Please, Kiran.
Good afternoon, all. I'm Kiran, Senior Research Fellow, Naval Physical and Oceanographic Laboratory, Cochin. So I'm here presenting my work in finite element structural analysis of a shipborne sensor array structure. So the co-authors include Dr. Ronnie Francis and Vivek AK, scientist. So in the recent years, shipborne sensor arrays have become the integral tools in acoustic research, providing invaluable real-time data for applications such as seafloor mapping, underwater noise monitoring, navigation, and communication, and environmental studies. So these sensors are used in a wide range of disciplines, from marine biology to oceanography, and the performance of these systems heavily depends on the strength and integrity of the structure that supports them. So this work emphasizes on FEA of sensor array structure, focusing on static structural, transient structural, and modal analysis. So the major objective of this work includes estimate the deflection and the stress values due to self-weight of the structure and also the sensor array elements, and to estimate the natural frequencies of the structure and to understand the response of array structure to the shock loads as per the shock standards. So out to the methodology. So the methodology includes the pre-processing, starting from the pre-processing. So it starts with the geometric modeling. So the modeling for this geometry has been done in SolidWorks, and it is meshed by the ANSYS workbench. And the material property includes the material used here is titanium grade 5, and to the boundary conditions, and to the numerical computation, and to the post-processing, where the contour plot and the realization of the computed data has been done, and to the documentation part. So to the mechanical properties. So here I have used the titanium grade 5 as a material. So due to its high strength to weight ratio and also the corrosion resistance. And the material is having a density of 4,430 kilogram per meter cube and having the minimum yield strength of 828 MPa and the minimum ultimate strength of 895 megapascal and Poisson's ratio of 0.31 and Young's modulus of 114 gigapascal. So over to the loads and boundary conditions. So we can see that the right side figure is showing that the structure image. So the element has been used as shell 181, which is a 4-node element and having 6 degrees of freedom at each node. And the number of elements includes 9,71,597 and the number of nodes are 10,70,699. So here we start the static structural analysis results. So the standard static structural analysis has been done for the self-weight analysis. For there we can see that in the previous figure. There is a sphere-like elements are there. So that is the sensors. The sensor holding positions are there. And the sensors are put as the point masses. in the structure. And back. Okay, back in front. So here we can see that the maximum deflection of 0.12 mm is observed as the point. We can see the joining area of the structure, and the maximum 1 meter stress of 17.75 megapascal was observed. And the material we chosen was the titanium grade 5, and we can confirm that the structure is safe within the yield strength. So over to the free vibration analysis. So this analysis we have carried out for finding out the natural frequencies of the structure. And the first frequency mode is a critical one. So for ships, there might be having a particular frequency, platform frequency. So if the frequency is matching with the natural frequency of our structure, then resonance may happen. So the first frequency, we can see that the 50, which is above or away from the platform frequency of the vessel that we designed for. Then over to the transient structural. So in this analysis, shock load analysis has been performed. So a half sine pulse is considered for this analysis, and 35G has been applied on the lateral axis for a time period of 35 millisecond, and 15G in horizontal axis, that is X and Z direction, for 15 millisecond. So over to the results. So in X direction, in longitudinal direction, we can see that the structure has been displaced to a 3.5 mm along the x-axis at 12 millisecond. And the von Mises stress we have observed was the 382.2 MPa at 12 millisecond. And also here we can confirm that the yield strength is having 828 MPa, and the observed value is 382.2 MPa, and we are getting a factor of safety of 2. And out to the Y direction, in the lateral direction, there we applied 35G in lateral axis for 35 millisecond. So here we observed the maximum of 3.5 mm along the y-axis at 13 millisecond, and maximum von Mises stress of 339.19 megapascal at 14.8 millisecond. And here also the yield strength is 828, and the structure is safe with the factor of safety of 2. And out to the third direction is the Z direction in the longitudinal. And here 15G has been applied for a 15 millisecond. The structure was displaced to 3.2 mm along this Z-axis at 11.6 millisecond. And also von Mises stress of 449.64 MPa at 11.6 millisecond has been observed. So here also we are confirming that the structure is safe with a factor of safety of 1.2, 1.8. So to the conclusions. So self-weight analysis has been confirmed that the structure is safe, and also the frequency of vibrations are far away from the platform frequency of the ship, and there will not be any occurrence, any resonance happening. And also in the shock analysis, the structure was well safe within the yield strength of the material we have chosen, the titanium grade 5. The reference. Thank you.
Any questions from the audience?
Somebody please ask. You showed several displacement plots.
Yes, sir.
And all of them were positive.
Yes.
And there were some regions where it was 0. Can you show one of your displacement plots? Maybe slide 13. Any of your displacement plots? That's hold. Top
Okay.
plot.
Yes, sir.
What happens to the displacement in between? But in the bottom plot, you are showing stress.
Sir, the first one is the transient variation of deflection.
Okay.
So deflection, and the next one is for the von Mises stress.
Okay.
Deflection variation.
So I cannot read your X-min, but I suppose your X-min is close to 0.
Okay. So it is starting with from 0.
So why is your deflection not going to the negative side at all?
So actually, it is plotting with half sine pulse.
Yeah. Okay. But you applied one pulse to it.
Yes.
And it is ringing for some time.
Okay.
But I think you cut out the negative parts.
Yes, it has been modeled in 2 steps are there. So the second half we are deactivating in
The shock load that you applied doesn't have any negative part. Why? The modern shock loads have got a negative part, I think. The old ones did not have it. The very old ones did not have it.
Here we are considering the positive part, sir.
Okay. So the negative part is causing damage in some cases.
Okay.
And your what are your comments on your factor of safety? Is it too high or it's okay?
For shock analysis part, we are expecting actually 1 to 2. Okay.
What provides damping in your system?
Generally, we are providing the shock mounts.
Is that included in your analysis?
No. Shock mounts. For this particular structure, we are not including that shock mounts. For the particular ones.
Okay. Last question. Why are you using 4 noded elements? Linear elements?
Yes, sir.
I thought people stopped using that decades ago.
2D elements are used.
Okay. 2D, but not linear. Thank you.
Thanks.
So I will go to the paper number 2, paper ID 122. The presenting author is Tasneem KS, and the title of the paper is Lifting Analysis of Grand Assembly Hull Block Using Finite Element Method. Please.
Good afternoon all. I'm Tasneem KS. I'm here to present on the topic lifting analysis of grand assembly hull blocks. First of all, I'm sincerely thankful to Cochin Shipyard Limited for providing an opportunity and resources for this study. These are my overview of my presentation. Coming to introduction, the ship hull are fabricated through the process of sub-assembly and unit assembly. Once the unit assembly blocks are completed, which is transported to dry dock or berthing area for the final erection. So the grand assembly process begins with the precise positioning and alignment achieved using a heavy lifting equipments like gantry greens. So for the lifting procedure, we chooses the lifting points. So selection of these lifting points are very crucial for the lifting procedure and which depends upon the center of gravity of the block. And so my objective of this study is to assess the structural behavior of these blocks under lifting condition using finite element method under the different boundary condition and compare their effect on the structure. So for that, I'm using 3D Experience Simulia, a simulation platform offered by Dissolve System. This is the geometry of the model I have chosen for the study. The table shows the parameters of the block. Coming to the mesh configuration, the figure shows the mesh domain, and in order to capture the stress distribution, accurately capture the stress distribution, the paddies are meshed refinedly. And the table shows the mesh details. And the analysis methods, these are the methods I've chosen for my study, which is my objective also. So first condition is a pin boundary method. The block is a lifted condition. All the pad A's are pinned, which is vertically preventing its movement. And one pad A is fixed against all motion. In sling boundary method, the slings are modeled as a beam element and which is connected to the pad A, which is the lifting points using a rigid element, and other end is fixed against all motion. And the third one is the grounded boundary. Grounded boundary, which is the pre-lifting scenario where the vertical translation is a constraint in all the bottom portion and the sling tensions are applied on the pad A points. In balanced boundary method, the center of gravity of the block is fixed against all motion and the sling tensions are applied to the pad A. In all these four conditions, the self-weight is applied. So this is how I apply boundary conditions on my block. The first one is the pin boundary and the sling, pin boundary, sling boundary. Grounded and balanced method. So coming to result and discussion, the first one is the pin boundary method. The peak stress of 77 megapascal is experiencing on the primary members where the pads are welded. When the block is a lifted condition, the peak stresses are experiencing on the member. In sling boundary, the sling tensions are transferred to the block through the pad A. So the stress is 144 megapascal is experiencing on the pad A region, pad A and the around region. In grounded method, the sling tensions are applied on the pad A. So the stresses of 153 megapascal is experiencing on the pad A region. And the balanced boundary, since the center of gravity of the blocks will not be in the structural member, it is connected to the adjacent structural member by using a rigid connection. So about a 76 megapascal is experiencing on the member, on the structural member, and 152 megapascal is experiencing on the pad A region. So all these four boundary conditions, the stresses are in allowable limit as per the acceptance criteria, which are shown in the table. And for accepting criteria for the block members, the design factor is taken from the DNB lifting offshore rules. So by comparing all the von Mises stresses or compare the von Mises stresses or the boundary condition, the pin boundary where the low stresses near the pad A region, this method is only providing reasonable results if the slings are in vertical condition. In sling boundary condition, the slings are providing an aligned position, so which is accurately the rigging configurations in all the shipyards. And in grounded, which is the pre-lifting scenario, which means what the simulations experiencing, what the stress is experiencing on the block when it is lifted from the ground. And balanced method, this method is produced for accurately determine what's the global deflections of the block while it is lifting. So I concluded that the sling boundary method is a practical approach for estimating lifting reactions and verifying the field condition. And balanced method is preferred for the global lifting analysis to check the global deflections of the block. And pin and grounded methods for checking the preliminary assessment for the local components like the pad A, the members where the pad A's are connected, etc. These are my references. Thank you.
So thank you, Tasneem. Have done in very you saved the time much, and it was a very fluent way you presented it. And my small doubt is that you are using a numerical method, finite element method, and then we are talking about different boundary conditions.
Yes.
And what are your basic governing equations? Which governing equations you are solving? Can you just, I didn't see any slide, that is why I'm just asking to clarify.
In finite element method, we're using the stiffness matrix. F is equal to K into D, the stiffness matrix equation. From the displacement, we get the strain, and the strain, we get the stress, and we get the forces experienced on the block.
Okay. Audience, any questions? No questions? Sir.
Tell us something more about your conclusions. You got, yeah. On what basis you make these conclusions?
In the pin boundary method, which is will produce a reasonable results if the sling are in vertical condition, which means a spreader beam lifting. In shipyards, the spreader beam lifting is using only for the very large blocks. In grounded method, we need to know what will be the stresses on the block when it is lifted from the ground, which is the pre-lifting scenario. And the fourth one is the balanced method. In balanced method, we're fixing the center of gravity. So we need to know what were the deflections acting on the block. So in actual method, I think it's not possible to fix in the center of gravity of the block. So by comparing all these four methods, the sling method is more, which is very similar to the actual rigging condition by using this sling point. That's why I'm concluded that the sling point is more.
How much is your allowable stress and how did you get that value?
Allowable stress in acceptance criteria.
Yeah, were you listening to the previous presentation or no? Maybe not. Okay, doesn't matter. How did you get this number?
151 mega.
Yeah, allowable stress. Yeah, 273 megapascal for pad I. Why are these allowable limits different?
For pad I, we consider, and for the block, we consider the design factor.
Okay.
Design factor as per the lifting operation, DNV rule.
And in all these cases, was it less than the allowable value?
Yes, which is in the allowable limit.
Okay. Okay. Thank you.
Thank you.
So next, paper ID 123. The presenting author is Krishna Devaraj, and the title of the paper is Design and Analysis of Crane Foundation on a Cargo Vessel Using Finite Element Method.
Looks like the speakers are in a hurry to have lunch. We are okay, we can wait.
Good afternoon all. Myself Krishna Devraj. I am here to present on the topic Design and Analysis of Crane Foundation on a Cargo Vessel Using Finite Element Method. So this is the overview of the presentation. And coming to the introduction, cranes are essential for the loading and unloading operations on vessels, but they impose significant loads on the vessel's hull. So it is important to transfer these loads to the vessel's hull through the foundation. Crane foundations are critical structural components that support the crane and transfer the loads to the vessel's hull. So this is a figure showing. This is a figure showing the crane foundation and an adjacent structure. The crane foundations are subjected to complex load combinations from lifting operations, ship motions, and environmental factors such as wind and waves. When the foundation is well designed, the stresses and displacement in the foundations are within the allowed limits. So, research gap. So, most existing studies include global loads in the local foundation analysis, but the extent to which these loads influence the local stress distribution and the overall response is not well understood. So this study will evaluate the significance of global load effects by assessing how global loads impact the local response of the crane foundation. So these are my objectives. To study the structural response of a deck crane foundation subjected to various operational and environmental loading conditions, and to compare the analysis of the crane foundation with and without considering the global hull loads to understand their influence on local response. So coming to the methodology, the numerical analysis will be performed using 3D Experience Simulia, an advanced 3D design and simulation platform by Dassault Systems, which utilizes the finite element method for structural evaluation. So for my study, I have modeled an inland box barge model using 3D Experience Simulia software. So this is a 3D model of the open inland box barge with 2 cargo holds I have modeled. This is section view and an isometric view. So the barge has a length of 60.6 meter, breadth of 16 meter, and a depth of 4.4 meter. S4 shell elements were used for the meshing, and each element is a 4-noded linear quadrilateral with mesh size of 200 mm. The material used is steel grade A, and it has a yield strength of 235 megapascal. And also, I have modeled the inland box barge with the crane foundation. The crane foundation is located on the main deck between the cargo holds, and the foundation has a radius of 11.5 meter and a thickness of 20 mm, and its flange plate has a thickness of 30 mm. The crane I have selected for my study has a lifting capacity of 50 tons. So this is a model of the inland box barge with the crane foundation, which is located on the main deck. So coming to the global analysis, I am following the Indian Register of Shipping rules. Boundary condition as per IRS guidelines. The cargo hold FP model uses boundary conditions with rigid links, point constraints, and end beams, where the longitudinal end nodes are tied to an independent point on the neutral axis on the center line. That is shown here. And the boundary conditions are shown in this table. So at the aft and fore end, the translation in Y, Z, and the rotation about X are fixed at the independent point. And additionally, at the aft end, the intersection of the center line and inner bottom point is fixed in the X translation. Next is the design loads. So the design loads that needs to be considered for the global analysis include the structural weight. That is the weight of the hull structure considered, and it is considered as a part of static load. And the next one is the internal pressure. Internal pressures include static, dry, and liquid cargo, ballast, and other liquid pressures, setting pressure on relief valve, and the dynamic pressure of dry and liquid cargo, ballast, and other liquid pressures due to accelerations. External pressures include the static sea pressure, dynamic wave pressure, and green sea pressure. The global analysis will include a still water loading and a wave loading. So still water loading are static loadings on the vessel, which consist of the light ship weight, cargo loadings, fuel and ballast tank loading, as well as buoyancy forces. So an idealized weight distribution is adopted to generate the required still water bending moment. This is a figure showing a typical weight and buoyancy distribution in ships. As a preliminary study, I have done a static balance check on my vessel to check the load equilibrium. So the load calculations are shown here. The displacement of the vessel is 2,766.81 tons, and the structural weight, which is obtained from the software, is 427.6 tons, and the remaining part, that's the cargo weight and outfit weight, is 2,339.21 tons, and the hydrostatic pressure is applied from waterline up to the keel. This is the boundary conditions and loads applied on the model. The cargo and outfit weights were applied as a uniformly distributed load on the tank top, and the hydrostatic pressure was applied on the side shells and bottom shells, and the model weight is also applied. And this is the boundary condition applied at the aft end of the model as per IRS guidelines. So these are the results I have obtained from the still water balancing. The total vertical reaction force at the supports obtained was 8.43 tons, and the displacement of the vessel is 2,766.81 tons. So the total reaction force obtained is 0.3% of the displacement of the vessel. As per IRS guidelines, this support reaction should not exceed 1% of the displacement of the ship. So from this, we can conclude that the initial still water balancing of the vessel meets the required standards. So this is the reaction force diagram I have obtained from my analysis. So coming to my future works, after this, I will do a wave balancing by applying hydrostatic loads on the vessel and balancing the model on a chosen wave, and then do the global bending analysis in waves. And after that, the analysis of the crane foundation for different operating conditions with and without considering the global loads, and then assessing the effect of the global bending on in the local foundation analysis. And also, I will do a nonlinear buckling check for the ship structures using pulse. Coming to my conclusions. So this study focuses on analyzing the structural response of a deck crane foundation on a cargo vessel using finite element analysis. The geometric modeling of the inland box barge with the crane foundation was completed. Boundary conditions and the loads for the barge model were defined based on the IRS guidelines. The still water balancing was successfully completed to ensure the load equilibrium of the vessel. And the future works will include analyzing the crane foundation under all operational load cases, balancing the vessel for the chosen wave condition, performing global bending and buckling analysis, and incorporating the operational and global loads to propose the design improvements for enhanced structural performance and safety of the crane foundation. So the study was carried out as a part of MTech project in the Department of Ship Technology under the guidance of Cochin Shipyard Limited. These are my references, and thank you.
Any questions from the audience? Can I go to a slide which shows that crane being fixed to the ship hull?
So, costume?
Yeah, the crane being shifted. That foundation picture, FEM model.
This one?
Yeah. So how can you justify the point contact between the crane foundation and the wall? Do you have any plan to install, a model, the structure much more stable?
Yes, actually, in this paper, I haven't mentioned about my crane foundation analysis. Actually, I have started doing that, and from the crane foundation analysis results, I think I need to improve my structure more.
And you are using Abacus software.
Yes, 3D Experience Simulia is part of ABAC.
Which is the mother company, whether the
Dassault system.
and 3D Simulia is Abacus comes under 3D Simulia. What's
I
your
think it's a more advanced version of Abacus.
no? Then the other aspect is that your model is showing gray color. Just a silly question, but still, why can't you show a color picture for this model?
It's because of the error in my software.
Okay. Yeah. Okay, thank you.
Can you please explain about how did you obtain the vertical reaction force?
So, should I explain this loads and boundary conditions?
The next slide.
Okay. So this is the total vertical reaction force I have obtained from the software. So here in this reaction force contour, I'm showing the maximum reaction force at the supports. Since I'm rigid linking the up and fore end, I should take the sum of the vertical reaction force at that aft end point. I need the reaction force at the independent point. This is showing the reaction force for the whole model, not for the not at the independent point. So since I'm rigid linking, I will take the sum of the reaction forces at this point.
Basically, it is the sum of all the forces.
Yes, and it was obtained from the software.
Okay.
Okay, thank you.
So next paper is paper ID 124. Sinitha Paul. The title of the paper is Finite Element Analysis of Corrugated Panels Used for Bulkheads in Ships. Please.
My name is Sanita. I'm here to present my topic on finite element analysis of corrugated panels used for bulkheads in ships. And these are my co-authors. Coming on to introduction, a corrugated bulkhead is made from uniformly thick metal plate formed into grooves and ridges, thereby eliminating the need of welded stiffeners. So compared to the traditional stiffened bulkheads, it requires less welding, reduces overall weight, and ensures even load transfer. The relevance to the industry or the researchers, there's limited comparative research on the structural effectiveness of different swaged or corrugated geometries, in particularly in context to replacing the traditional stiffened panels in ship structures. So this project addresses that gap by evaluating multiple swage or corrugation geometries against the traditional stiffened panel. Coming on to the objective is to assess the structural performance of swaged or corrugated bulkhead panels under operational loading conditions. And the methodology is to follow finite element analysis using 3D experience similia. Coming on to the benchmarking analysis results against experimental results of corrugated panels. For this study, the numerical results were benchmarked against the numerical as well as experimental results of a report named Swage Panel Analysis Verification by National Steel and Shipbuilding Company, NASCO. For this study, NASCO uses distinctly two loading arrangements, that is shear load arrangement and compressive load arrangement. Figure 4 and 5 shows and each loading arrangement has two panels, that is a stiffened panel and a swaged panel. So figure 4 and 5 shows a shear load arrangement for the stiffened panel and the swaged panel respectively. The two panels are joined by steel square tubes in order to simulate the stiffness above and below the bulkhead and ship structure. The table shows the loading and the boundary conditions. The two outer square tubes were fixed at one end. The length of the outer tubes were constrained against out-of-plane rotation, and the load 300 kips were applied to the center tube. This information was taken from NASCO report. Figure 6 and 7 shows the compressive load arrangement for the stiffened as well as swaged panel. The loading and the boundary conditions are given in the table. The lower plate is fixed in translation. The upper plate is constrained out of plane translation. And the load 150 kips was applied along the upper plate, along the top of the upper plate. This information as well is taken from NASCO. Coming on to the design concept, the suction modulus of the swage panel was calculated as 38.3 centimeter cube about the x-axis using a software named 3D Beam. The stiffened panel was designed to match the swage panel. That is the key factor for comparison. And the section modulus of the stiffened panel was taken as 38 centimeter cube about x-axis as well as using the software 3D Beam. And the computed section modulus differed only about 1% for both the panels. These are the geometric models which were modeled using 3D experience similia. And the boundary conditions from the NASCO test report was applied to these models for the compressor as well as the shear loading arrangement for both the type of panels. Coming to the mesh convergence study for shear load arrangement, for both the type panels, stiffened as well as swage panel, the element type used was surface chord mesh. For stiffened panel, the result converged to 1.49 mm and the optimum mesh size was taken as 15 mm. And for the swage panel, the result converged to 1.714 mm and the optimum mesh size taken as 35 mm. Now coming on to the compressive load arrangement, for the stiffened panel, the result converged to 2.12 mm and the optimum mesh size was taken as 25 mm. And for the swage panel, the result converged to 2.82 mm and the optimum mesh size taken as 35 mm. The mesh convergence test plots are being shown. Coming on to the results of the FE analysis for both the stress contour plot for shear load arrangement of both stiffened and swage panel is being shown. They have obtained identical maximum bond Mises stress of about 271 MPa, which was below the material yield strength of 355 MPa. This is the stress contour plot for the compressive load arrangement of both the stiffened as well as swaged panel. They have obtained a maximum bond Mises stress of about 190 MPa, which was below the material yield strength of 355 MPa. This is a comparison of the FE results. So NASCO experimental test results obtained stress values at multiple locations using rosette strain gauges. So the R1, R2, R3 you see in the x-axis shown the rosette strain gauge numbers. So for I've compared my FEA data with the reported FEA data and the experimental data from NASCO. So the while comparing my FEA data with the NASCO's FEA data, I found out there was a difference of around 10% at all the strain gauge locations. Whereas when I compared my FEA data with the experimental data from NASCO, there was a huge variation. This was mainly because of the geometric imperfections shown in the experimental test setup panels, as well as the slight variances in the load application. FEA models assumes an idealized specimen, so it does not take into account any imperfections. This was the main reason given by the NASCO report as well. Coming to the comparison of stiffness, stiffness was compared for the compression as well as shear load arrangement for both stiffened and swage panel. So for what was observed in the compression load arrangement when we observe for stiffness is that the stiffened panel is about 20% more stiffer than the swage panel, and the NASCO showing a deviation of about 9% from the NASCO test results. When we look at the shear loading arrangement, the stiffened panel is about 13.84% stiffer than the swage panel, showing a deviation of about 3.16% from the NASCO test results. Now, looking at the comparison of weight as well as fabrication man-hours required for swage panel and equivalent stiffened panel, is that the stiffened configuration demanded approximately 40% more fabrication time, but the reduction, but in swage configuration, there was a reduction of 13 to 16% weight savings. The values are shown in the tabular format. So from this we can conclude that for shear loading, the stiffened panel was about 13.9% stiffer than the swage panel. For compression loading, the stiffened panel was about 20% stiffer than the swage panel. Both the profiles developed almost identical von Mises stress, and the swage panel although being slightly less stiff than the stiffened configuration, they require about 40% less fabrication time under both loading conditions, and they have 13 to 16% weight savings. They offer substantial advantages in terms of fabrication simplicity, reduced welding, and improved construction efficiency. So we could conclude that the swage panel can be considered as the more advantageous option. future works, I would like to extend the analysis to a wider range of vessel-specific swaged and stiffened bulkhead panels to evaluate their structural performance, to perform nonlinear buckling analysis on both the swaged and equivalent stiffened bulkheads, to conduct a fire integrity check for both bulkhead configurations as A0 rated bulkheads, and to assess the overall structural efficiency of swaged bulkheads as potential replacement for the conventional traditional stiffened panels in ship structures. Acknowledgement. The study was taken as part of my MTech project in the Department of Ship Technology under the guidance of Cochin Shipyard Limited. I would like to acknowledge Department of Ship Technology and Cochin Shipyard Limited for the resources and the guidance provided for this study. These are my references. Thank you.
Thank you, Sunita. In your grid or mesh independence studies, yeah. So here you are telling that the optimum mesh size is taken is 25 mm. So how it is, from that graph, it is showing on the x-axis number of elements, right?
Yeah.
So how it is correlated? I am not getting that point.
I have first done it for the mesh size, and then I have from the corresponding mesh size, I've taken the number of elements. So the graph only I plotted against number of elements, but like the mesh size corresponding number of elements is that.
Suppose this is 25 mm. What will be which point you are taking as the optimum number of elements?
Near 6020.
Yeah, in that it is spanning from 1020 to 6020, right?
Yeah.
So in that, where would be your optimum elements will be lying?
Near 6020.
6,000.
Yeah.
Last point. What about the previous graph was there? Yeah, here in this case, where will be your optimum?
Well, 120,000.
Now, why need to go to that 1,20,000 as optimum one? Because after that 40 or that 40,000 or 50,000, there is no change in the reflection, right? So why to go for 1,20,000 or
Go
1,10,000?
for the previous one. I could go for the previous one.
Yeah, where will be the optimum? Where would be the optimum in this case?
50,000 for this one.
Where?
50.
Oh,
Yeah, 50,000.
50,000. Okay. Any questions from the audience?
Yeah, Sunita, you have mentioned about, basically focused on the strength aspect, because you have said that introducing a corrugated panel will give you the ship becomes lighter in weight and all those advantages. So are you planning to do anything on the buckling strength analysis, like some lateral pressure can be induced onto when you consider a stiffened panel and a corrugated panel? So which one would perform better in such a case? When like stiffeners, you can arrange it in different angles, like 45-degree or the corrugated panels, like you're using trapezoidal pattern, right? So in that case, your lateral pressure, when it comes onto, there is a maximum deflection on the panel. So are you planning to do that? Can you throw some light on the buckling?
Yes, ma'am. I'm planning to do the buckling.
Which is it in the...
Yeah, next.
Okay, so where is it maximum that you had shown some plots before where you have the maximum deflection values, where you are giving shear, isn't it? Shear load arrangement. Yeah. So in this case, when you have a lateral pressure coming up, where might be the buckling, some initial analysis have you done with respect to buckling?
Ma'am, I haven't done for this, but for another
Okay, so that is a valid one that has to be, like your collapse pattern or something has to be analyzed in a second stage of that. Okay, thank you.
You mentioned some boundary conditions, said that you have taken those boundary conditions because somebody else is using it. Did you think about those boundary conditions and whether they are reasonable?
They provided me with identical one.
Okay. You showed one case where the difference was 200%.
Yes, that was for the experimental results.
Okay.
That was with respect to the experiment.
Okay, so this is due to geometric imperfections in the stiffened panel.
Yeah.
So you're thinking, what is wrong? Your FEM is wrong or the experiment is wrong?
Like they had reported itself that the experimental test results had, like their FEA results, when they compared it with the experimental results, they found this huge variation as well.
Okay, so we that one will not focus on. What's the next highest difference? Something is there at 90%. Something else is there at 75%. What's happening there?
That's the same reason as the geometry, like at different locations.
So geometric imperfections will always be there when I make a structure.
Yeah.
So how do I design then? Because I cannot tell them you make it geometrically perfect.
Mhm.
Then how do I account for this in design?
I think while doing FEA, we should account those imperfections in the FEA results.
Okay,
That
thank you.
would-
Yeah, thanks.
Thank you, Sunita. Next paper is paper ID 126, Jasna PH. And the title of the paper is Dynamic Response of Composite Sandwich Wraps for Marine Diesel Engine Vibration Isolation. Please.
Good afternoon, all. Today I'll be presenting my paper titled Dynamic Response of Composite Sandwich Wrap for Marine Diesel Engine Vibration Isolation, co-authored by Dr. Rajesh P. Nair and Dr. Sunir Hassan. So these are the contents of the presentation. We know that reducing vibration and noise is essential for the design and operation of marine vessels and underwater vehicles. The major sources of this vibration are from propulsion systems, onboard machinery, and hydrodynamic forces. Onboard machinery produces two types of vibration. One is the airborne path, and the other one is a structure-borne path. Now, this excessive vibration and noise will cause harmful effect to the structural integrity of the system. It diminishes the crew and passenger comfort, and also it also transfer the vibration as underwater radiated noise, which will expose the vessel's location to hostile forces, as well as it affects the marine ecosystem. So these are the conventional vibration isolation systems which we are using. We have used single stage isolation system, two-stage isolation system, and the recent one is the floating raft vibration isolation system. So here in floating raft vibration isolation system, we have a common raft to which multiple machineries will be fitted, and the isolators will be provided on the top and the bottom. So this is effective in isolating the noise and vibration. Now, one of the limitation or the existing conventional raft is made up of steel, which has excessive weight, and it will reduce the structural efficiency. So we are going for a sandwich raft system. Now, why sandwich structures? Because they combine low weight and high stiffness, and you can always tune the structures to the need you want. That is, you can adjust the raft height, the panel thickness, the rib spacing. All this can be adjusted, and all this has an effect on the dynamic response of the structure. Now, the recent studies are going on carbon fiber reinforced polymer sandwich raft system, which has higher damping and lower mass, and also it can maintain the load capacity. So here, our main objective is to identify the composite material. Here we are using three types of composite material. One is the carbon fiber reinforced polymer, then the glass fiber reinforced polymer, and the third one is the basalt fiber reinforced polymer, to see which has the optimal vibration isolation characteristics
This will serve as a foundation for developing an advanced vibration isolation system. So we are going for the finite element simulation, which will study the dynamic behavior of the structures under vibratory loads. And first step of any dynamic analysis is the model analysis, wherein we identify the natural frequency and mode shape. So this will give you how the structure deforms at certain frequencies. So next step is harmonic analysis, which will give you the steady state response under a sinusoidal input force. And here we apply a unit harmonic force over a defined frequency range. Now, the main parameter which quantifies this isolation is transmissibility, which is given by this equation. Now here, when the transmissibility is lesser than 0, we have effective isolation. If it is greater than 0, we have amplification, and the peak regions will give you the natural or the resonant frequencies. Now, to get a more realistic or real-world application, we are using the input forces from the marine diesel engines. The dynamic forces from a marine diesel engines will be used. Now, the main forces of marine diesel engine is classified into two. First one is the vertical inertia force that is occurring because of the reciprocating motion of the piston. And the second one is the piston slab rolling moment that is because of the lateral motion of the piston. So these two forces will be applied as the input for this analysis. So this is a finite element modeling. We are using a sandwich. The finite element modeling is done in Abacus software. And we are using a sandwich graph with square cores with the dimensions that is given here. Now this dimension is taken from the literature for the particular marine diesel engine specifications, which will be shown in the later slide. So we are using a faceplate thickness of 20 mm and core size of 300 by 300 and cell wall thickness of 20 mm is used, and 3 core heights were chosen, 250, 350 and 450. That is not to check the core height influence, it's just to see that whether we are getting the same result for all the 3 cases. So we are using the element type, the brick element, 8-knotted brick element is used in the finite element analysis. Now, these are the material properties that have been taken. The steel, CFRP, GFRP, and BFRP properties are given in the table shown. And we have the composite layup sequence as 0, 90, minus 45, 45, that is given in symmetry with a ply thickness of 0.25 mm. Now, for the boundary condition, we are giving pin support for both the ends. And for the harmonic analysis, 2 types of loading conditions were taken. One is for the center loading and the other one is at a side loading, that is 640 to 810 mm position. Now the frequency range taken was from 1 to 2500 Hertz. And the for post excitation condition, we are giving a reference point. So this is a case for the forced excitation. That is here gives the first graph is the force, the inertial force from the marine diesel engine, and the second graph is the piston slab moment that is obtained for a particular diesel engine, which has the specification that is given in the table above. So this is obtained from the literature. And this force is applied at a reference point that is marked in the red circle. Both the forces and the moment is given at the reference point, which is actually the center of gravity of the engine. Now, a mesh convergence study was done, and we have taken a suitable mesh size of 50 mm. Now, for the validation of the model, we have taken a literature. That literature had a different material use. That is, CFRP was taken for the faceplate, and aluminum core was taken for the square configuration with a dimension of 1 meter by 1 meter by 4 mm. So here this gives the graph of the literature and the study which I have conducted, which shows that their error percentage is comparable. So we can use this modeling technique for our analysis also. So coming to the result and discussion, we have done all this. Model analysis was conducted harmonic and harmonic under forced excitation, and we have obtained the transmissibility curves and the acceleration response curve. So coming on to the result of model analysis, we could see that steel has a higher natural frequency when compared to the other materials like CFRP, GFRP, and BFRP. So this is a graph showing the same. So next slide. So the highest natural frequency was obtained for steel. Then comes CFRP, then GFRP and BFRP. So BFRP is more flexible and it is better suited for low frequency damping. Now, as the core height increases, the natural frequency is also increasing because the overall stiffness is getting increased. Now coming on to the harmonic analysis, so these are the graphs that is obtained for center loading condition, and the 4 response points are taken at the 4 corners of the sandwich shaft at the bottom. Now the blue graph indicates for the steel. So we can see that there are multiple resonance peaks that is obtained for a steel structure, and the decay of vibration is also very slow for a steel structure. Whereas if you take a BFRP, which is denoted in yellow color, we can see that there is a faster decay of vibration for BFRP, and the resonance peak is also reduced for BFRP. So this was the case for center loading, and this was the same case for side loading. So same characteristics was also found here. So again, the comparison, we saw that steel has multiple resonance peak and there is a slow decay, which shows there is a poor vibration isolation. CFRP and GFRP had a moderate peaks and faster decay, whereas BFRP has the lowest peak and fastest decay, which indicates that it has a better vibration isolation performance. Now coming to forced excitation, the engine loads was given, and here none of the materials are isolating. We can see the transmissibility versus frequency curve, in which steel had the highest transmissibility, and lowest transmissibility was for BFRP, which indicates that when compared to steel, BFRP is better isolating the frequency. So this was seen in the case of 3 cases were chosen. That was similar in the case of case 2 as well as in case 3. So steel had the highest transmissibility and BFRP had the lowest transmissibility, CFRP and GFRP in the middle range. So this is the result from the harmonic analysis under force. No material is less than 0 transmissibility, which indicates that isolation is not taking place in any of the material. But we can say that higher transmissibility is for steel, and BFRP and GFRP had a lower transmissibility, and it is better effective in reducing the isolation. Okay, this was the acceleration response curve. So it was contradictory to the other isolation curve because steel had the lesser acceleration, which is very well known because it has higher stiffness. So steel had a lower acceleration when compared to the other materials. BFRP had a moderate level of acceleration. The blue color is for steel and the orange color is for BFRP. So same scenario was seen in all the 3 cases. So coming to the forced excitation, as I said before, GFRP had the highest acceleration response, whereas steel had the lowest acceleration. That is because of its mass inertial damping is there in steel. So this is just a comparison. So from all this result, we were able to see that, next please. BFRP is the most effective material for vibration isolation, but further improvements are needed, like core optimization, adding damping layers, or what I'm going to do, that is integration of locally resonant structures to improve the vibration isolation of this sandwich trusses. These are the references. Thank you.
Thank you, Jasna. Any question from the audience?
You said something about 250, 350, 450.
Core height.
And what is your conclusion from that study?
The same, in case of natural frequency, as the core height increases, the natural frequency is also increasing.
Okay. Now, from different analysis, you have concluded that different materials are the best. But at the end, you're saying BFRP.
No. BFRP is the best. Only the acceleration response for BFRP, it is little bit higher than steel. But that can be reduced.
Can you show that slide?
That table can.
No, hold on to this. Actually, yeah, you have a few slides for forced excitation.
Yeah.
Okay, what are the and what are you showing in each of these cases? This is acceleration
Acceleration obtained.
for case 3.
Yeah. For case 3, that is 350 mm.
Okay. And this one shows that CFRP has got the highest acceleration, is it?
No. Highest acceleration is for BFRP, the orange one.
Okay. So is that good or bad?
It is bad actually,
Hmm.
but we can reduce the acceleration. But when you compare, our main aim is for isolation. So isolation property is better for BFRP.
Can you show that slide?
Previous. See, this is for the post excitation. So here we have transmissibility less for BFRP material. It's not getting isolated, but it's less for BFRP, and lesser transmissibility is better for vibration.
In this graph, there are no resonances. Why is that?
That's because it's actually not getting isolated. It's not a straight line.
Hmm.
It's because of the scale, it's looking like a straight.
And you said that the force is applied at the middle or center.
A center of gravity of the engine.
But in this picture, it's on the center of gravity of the
Engine.
engine. Okay. Oh, which is off center as far as your isolator is concerned.
Yeah.
It's not at the center. So that's why you've got 4 results.
Four
Be- be-
responses at the 4 corners.
Because you're looking at 4 corners. Okay. Thank you.
Okay, nice, Desna. Okay. Next, paper number 152. The presenting author is Anushree Warrior. The title of the paper is Added Mass and Dampering of a Floating Vertical Cylinder Using Open Source BEM Solver NEMO.
Good afternoon. I am here to present my findings on the topic added mass and damping of a floating vertical cylinder using open source BEM solver NEMO. As we move on to the introduction, actually my research is focused on the area of floating windshore platforms. So the global push for renewable energy has accelerated the development of complex floating offshore structures. To understand the behavior of a floating structure, we have to consider the effect of the structure with respect to waves. So to predict that, we have to accurately predict the hydrodynamic coefficient. So that is the importance of my study here. So as an overview of my methodology, I'll be dealing with the governing theory, then the numerical setup, and the validation. I have validated my research with the paper written by Jung in 1981. This is the governing equation of motion. Here, mass and stiffness and damping matrix is there. And this is the software I'm using. NEMO is an open source boundary element software. The modules are showing the right side: preprocessor, hydroscal, solver, and post-processor. First, we will give the input data in the preprocessor. Then hydrodynamic stiffness will be given by the hydroscal. Then we can get the results from solver and post-processor. Before moving to the results, we can see what is the governing theory behind this. Added mass is a virtual mass when we accelerate a body in fluid. This is a finite depth case. So it is acts as additional inertia added to the body structural mass. The force is in phase with the acceleration of the body, and it significantly affects the natural period of the floating structure as it increases the resonant frequency. As added mass increases, resonant frequency decreases and the resonant period increases. Radiation damping is not caused by viscosity or friction, but the generation of waves. As the body oscillates, it creates waves that propagate outwards to the far field. These create an energy loss, and it is proportional to the velocity and in phase with the velocity. This is the same as explained before. We can see the impact on resonance in the fourth point. Added mass directly dictates the natural frequency as omega 3 is equal to C33 by m plus A33. Here C33 is the damping matrix and A33 is the added mass matrix. Here we are considering it as in heave, so the terms 3-3. About my numerical model setup, I have modeled the half cylinder in NEMO. For that, I have used GMesh for meshing. And considering the symmetry of the cylinder, I have modeled the half cylinder mesh. And I have used 1000 quadrilateral panels. And the ratio to water depth ratio holds an important place in this. Actually, to compare with the Young's paper, this ratio is considered. Actually, I have modeled a cylinder with a radius of 5 meter and the draft 7.5 meter, and the clearance to the seabed is considered as 0.25. Ratio is considered 0.25. That means 2.5 is the clearance. The water depth is considered as 10 meter. Here, I have done the mesh sensitivity study. I have considered a medium mesh, then a coarse mesh and fine mesh. Then as the results, we can see the convergence as the difference to the coarse mesh is less than 0.6%, and the difference to the fine mesh is less than 4.4%. And the radiation damping, higher sensitivity near the free surface at high frequencies, and maximum deviation of 4% between the medium and fine meshes. So we concluded that the medium mesh is fine for the analysis as it takes very less time compared to the fine mesh. This is the validation strategy I have used. I have compared to the analytical solution provided by Jung. These are the results. And the heave added mass results, we can see at lower frequencies, we can see a higher added mass, and it reaches a dip, then reaches a constant value at higher frequencies. This is because of the finite depth of the water. Like it acts as a boundary. So at higher frequencies, the surface will behave like freezed. So there is no creation of additional waves from that. So the mass is trapped in between the layers. So the added mass reaches a constant at that value. And at lower frequencies, the longer waves have a tendency to move out. So it will move horizontally. So that's why the added mass is increasing. Like we have to exert more force to push the object in finite depth, like shallow water. And this is the results of heave radiation damping. Here also we can see that in lower frequencies, the heave radiation damping is high. As we move on to the higher frequencies, it reaches almost zero. At a Ka value of 1.5, it reaches almost zero. This is also because of that only. Here we can say that NEMO can be used for the further analysis. We have to integrate the hydrodynamic coefficient from NEMO to OpenFirst, and we have to do mooring in Ockerplex. That is my work plan. So we can see by the results, it is accurate and it is future ready. And here is my future work. I would really do this application to deep water regimes and will find the RAO. To find the RAO, we need the hydrodynamic coefficient. So the first step is completed from here. And most of the floating structures, semi-submersibles, spas, etc., are made up of cylindrical. shapes. So analysis of cylinder holds the, and we have to optimize the geometry. Then hybrid hydrodynamic modeling, the viscous force also has to be considered by Morrison's equation that I have to further look upon. Then I have to do the fully coupled time domain analysis, taking the consideration into wind, what is acting on the wind turbine. These are my references. And I thank ADF scheme for the financial support. Thank you.
We're using a new technique called boundary element method. I mean, it's an old numerical method, but still people are not that much familiar with boundary element method. So here you are basically considering the effects of added mass. You have shown the picture of that that cylinder. Can you go to that slide? When the cylinder is being. Yeah, here, why you are taking half cylinder?
Because of the symmetry, we can take the half cylinder. I actually checked with the full cylinder also. It is giving same result itself.
No, I'm saying why can't you take quarter cylinder? Quarter cylinder.
I didn't consider that, sir.
Because considering the loading and geometry, we can take quarter cylinder. And also if the loading and the geometry are symmetrical with respect to vertical axis, then you can even consider axis symmetric model.
Actually, in NEMO, there are many modules in that. So whatever we are giving the input, right? We have inserting it as dat file. So we are saying that it is the half symmetry like that. So it will double the mesh and calculate the parameters.
Try with the quarter model.
Yeah.
And it's not NEMO result, your result, right? You mentioned your results as NEMO result. You can mention it as present study or current research or like that. Not NEMO result.
Results from
Yeah.
Yes. Sir.
That's all. Any questions from the audience?
Hello, I'm Sharatraj. So you had incorporated that validation. I just told that model is validated only. Any graph or like quantifications?
Yeah.
I mean that have you included that?
Yes.
Okay.
Here, the blue line is the NEMO result and the red line is yeah. Results from NEMO and red line is from the paper. So from the frequency less than K of 0.5, there is a slight deviation. Then after that, it is almost converging as the results.
Okay, that dip, you said there is a dip, right?
Yeah.
So why that dip is happening like that?
Actually, it is governed by a Kremlin-Kreylik's method. Actually, it is very deep to understand. It says that when the added mass is integral of damping. So at lower frequencies, damping reaches a higher value, and so our lower frequencies, the damping reaches a higher value, and as frequency goes to the higher frequency range, it reduces. So that integration is giving that dip. The Jung itself told that the dip is necessary for the analysis.
Is something there with the numerical procedure that dip getting my point? Is there anything related with the numerical procedure or something like that that solving of that matrix
I'm not
that is
sure.
happen? Okay.
I think it is basically analytical.
Okay. Then what about the boundary conditions you used for this particular analysis?
Boundary conditions. I've used the water depth of 10 meter. Then
No, you have to specify the wall condition, right? Like no slip condition or something like that. I'm not exactly aware of this anymore and all those things. Just clearing my doubts. How you I mean, define the wall, how you define the liquid section, etc., region, that liquid region, the wall region, etc.
Actually, the mesh is getting inputted. So what we will say, the water surface, it is taken by the Nemo itself. We will say that a wave of constant wave of 1 meter is coming to the surface, and it is according to the shape of the object. If you are giving the mesh, it is taking the shape, then giving the parameters.
What kind of parameters?
Like we are getting the added mass and damping from that only, like from the shape of the structure and from the mesh.
Thank you.
Solving the 6 degrees of freedom equation, or like you have calculated the heave added mass. So it's a 1 degree of freedom case. So in any scenario, is it solving the 6 degree of freedom scenario equation, or is it solving the 1 degree of freedom equation?
Actually, I tried with both, sir. I tried to solve with finding all the 6 degrees of freedom and to find the heave added mass. Actually, it gives the same results itself. Like if you are asking for the
Have you tried any coupled analysis, like say for example heave pitch coupled motions? Have you tried?
I haven't considered the coupling effect. Like I took only the sway effect, surge effect by as it is, but didn't try to couple that.
Did you check the added mass matrix and verified whether the other rest of the elements are all zero except the heave in this kind of a thing?
Actually, in the paper, sir, the ratios are different for different kind of motion. So if for this cylinder only heave motion was available, that's why I validated with that. If we want to validate the other motions also, we have to define another cylinder with the different ratio.
No, my point was like when you are analyzing the heave motion, and if you after the analysis, if you verify the added mass or damping matrix, is it the only that mode of motion? You have 36 elements in the matrix, so is it only one element in that matrix non-zero and the rest of the elements are
No, every elements are there. Not zero. I like not zero. Every other elements are also there. I took the heave because of verification study has the heave component. That's why I took the heave for the specific study. Actually, I think it is because of the larger waves. At lower frequency, the waves will be very much larger to the fluid domain. So I think it is the Nemo characteristics that does not allow that to.
For time. How do you account for this? How do you model at different frequencies?
Different frequencies. I gave a time step like that you were asking. The frequencies I gave from 0.5 to, this is non-dimensionless frequency in the graph. I given in the software 0.5 to 4.2 frequencies, radian per second.
Okay. So so it's the solution is in the frequency domain, not in time domain.
No, frequency domain. Nemo is a complete frequency domain solver.
Whether the analytical model assumes high frequency?
Yes.
The reason for good or reasonably good agreement at high frequency, maybe because something is being done in the analytical model, which is valid only at high frequency.
Not like that. At lower frequencies also, I think we can see an agreement, but not that level.
In this figure, for example, at zero frequency, do you get agreement?
No, actually, it reaches to infinity. It didn't reaches a constant value of 3.2. Or here we can say that same trend increases to infinity only.
Okay. What's on the y-axis? Non-dimensional?
non-dimensional frequency and non-dimensional added mass. Non-dimensional added mass is the bias. Added mass was,
Added mass is going to infinity.
yeah.
So I suspect that something is there in the analytical model which is valid only at high frequencies.
Yes. Yes.
Okay.
No. I mean,
Okay, thank you.
yes. Actually, there are very less journal in numerical, analytical
No,
aspect.
yeah, okay. Somebody else may have solved this numerically. There was one girl who did something like this for her MTech project. Anaga. Okay, thanks.
That's the end of technical presentations for this session. Now we will give away the certificates for the participants, and I call upon Dr. Ebenezer to give away the participation certificates. Please, sir. Paper ID 121, Kiran AK. Paper ID 121, Kiran AK. Paper ID 122, Tasneem KS. Paper ID 123, Krishna Devaraj. Paper ID 124, Sinita Paul. Paper ID 125, Jesna PH. Paper ID 152, Anushree Warrior. Now, I invite Commander Deepak Sebastian, Indian Navy, to present the certificate to the chair of the session. Please, sir. We have arranged a lunch upstairs. Please feel free to enjoy the lunch, and we'll be back by 2 p.m. Thank you.
Sir, can you hear us? Sir, you are mute right now.
Okay, unmute. Okay. I'm audible now?
Can you hear us now, sir?
I'm able to hear you. Could you hear me? Could you hear me? Could you see my slides? I'm audible or not?
Yes, sir. Yes, sir.
Okay. So I think it's fine. My slide is also visible now. Full slide you are able to see? Yeah. Slide is visible?
Yes, sir. Your slide is visible.
So what time will start?
We can start by 2 o'clock.
2 o'clock. Okay, let me wait. Okay,
Let us talk to Rajesh, sir.
I'll mute and I'll wait. Shall I wait in the lobby itself? Or
Sure,
shall
sir.
you?
Thank you. Thank you.
Okay, thank you. Then I will 2 o'clock I'll join. Okay.
We'll contact you when we have to start.
Yes, I will be ready. Okay. So shall I mute and or shall let it be like this?
Yeah, you can mute.
Shall I log out? Shall I
You
log
can
out?
mute and turn your video off if you want.
Okay.
Yeah, we'll contact you, sir.
Yes. Thank you.
Thank you.
Thank you.
Welcome back, everyone, to our session. We'll be starting now.
Hello, sir. This is Rajesh, convener for iCANOE. Welcome to iCANOE. Sir, are you ready for the keynote
Yeah,
speech?
yeah. Yes, you can. Yeah.
We'll wait for another 5 minutes, sir.
Yes. No, okay. No problem.
And after that, we have a session that's about materials and corrosion. So, Madhir sir said you can attend there as chair online.
Yes.
Yeah. So, Madhyan sir will join a little late because he's having another duty. So
Fine.
the co-chair will be Manoj sir from here itself.
Yeah. So, how much time this is supposed to deliver a lecture?
Sir, it's for you it's half an hour.
Okay.
For technical papers, it's 15 minutes.
Fine. Yes.
And sir, do you need the PDF file? We have the conference proceedings. That if
Yeah, you can send now.
Yeah, in your WhatsApp, I will send you now.
Yes.
The conference.
Yes. PDF you can send by WhatsApp. Yes.
Yeah.
Just I'm here. You when ready.
Sir, now almost people are coming. Just
Yes,
one more minute, sir.
Yes.
Welcome back, everyone, once again. Now it's my privilege to invite Professor Dr. S. Muthukumaran, Professor and Head of the Department of Metallurgical and Materials Engineering at NIT Tiruchirappalli. Dr. Muthukumaran is a renowned researcher and innovator known for his impactful contributions in welding, material science, and sustainable energy. His inventions, such as the free energy Muthu's magic bag for the water body cleaning and the low-cost Pure boat rescue systems, demonstrate his commitment and developing practical, social, responsible technologies. With more than 60 research publications and several patents, he continues to inspire students and researchers and industry alike. Please join me in welcoming Dr. S. Muthukumaran to deliver his keynote address. Sir, please.
Yeah. I am audible.
Yes, sir, you are audible.
So just 1 minute. Let me share my slide. Yeah. So let me share the slides. Okay. Slide is visible?
So can you make it full screen?
Full screen. I'll make it full screen. I think it's fine.
Yeah, it's visible, sir.
So, very good afternoon to one and all. And I'm thankful to Professor Madhyagan for inviting me. I plan to meet personally. I may attend personally a physical mode, but due to some unavoidable circumstances, I cancelled my trip. So I'm thankful for the organizers for inviting me and giving this wonderful forum to share my knowledge. And I like to know the background of the participants, whether they are in fabrication or a diversified field student. I hope it is a mixed audience with practicing engineers and students. I hope I'm right.
Yes, sir. Actually, it's a mixed audience in the sense that
Okay.
we
Okay.
have around 5 to 6 people from outside department. And
Okay.
there's a PhD scholar, MTech students, and BTech
Fine.
students.
Thank you. Thank you for updates. And I'll make this more interesting so that handling after lunch is very challenging. And so I should keep everybody awake. It's a very big responsibility. But anyhow, I'll try to do my level best. And I hope you are all aware of frictionless welding. And it's a new process, relatively new process. 91 it was invented. And these are the areas we are going to cover during today's presentation, possibly for 30 minutes. And yeah, so this is very important nowadays. Now we are talking about carbon tax. Now zero carbon, and carbon emission is a very big challenge, and it's a we need to cut the cost. That is a carbon tax is suppose we consume more energy, then we need to pay more carbon tax. So because of this global warming, so it is causing climate change, this is a very important topic. And interestingly, shipbuilding is based on welding. Welding is a main process used in shipbuilding, and we know that welding is more more energy intensive process. Energy we can consume more amount of energy. Welding processes. But interestingly, the frictionless welding process consumes only 2.5% of energy consumed by laser welding. So very energy efficient process. So this process having very high potential in shipbuilding application, and we need to consume less amount of energy to reduce our carbon tax. So this process is getting popular nowadays in many developing countries. And slowly, I am sure that in our country also it will pick up because the carbon tax is going to be very high. So more energy we consume in fabrication, now we bound to pay more carbon tax. So this is one of the segment where we can reduce our carbon tax and improve our performance. So I visited Cochin shipyard and other shipyards, and now in our country it had to get pick up. But I'm sure that in coming days, technology would find more applications, and slowly we need to start using this technology. At least 5%, then 10%. Then at least it can go. We can think up to 60 to 70% very easily. So this is the background for my presentation, and before that, I would like to give very interesting point about welding. So many students also here. So I am audible. My voice is okay.
Yes, sir. Yes, sir. We can
Yeah.
hear.
So if I am not audible, kindly inform me so that I can correct I'll let me check my audio system. So here we need welding is a bonding, welding is a permanent join, no? Joining of two metal, similar and dissimilar metals, that permanent join that we know. The welding can be classified as solid state welding process and fusion welding process. Fusion welding process in the sense the metal is melted and common molten pool is generated and it is solidifies. And in case of solid state welding processes, there is no melting of metal take place. So broadly, welding can be classified as solid state welding processes and a fusion welding process. All our processes, that arc welding processes are all coming under fusion welding processes. The parent metals is melted locally where we need to join. There it is melted locally and solidifies. Common molten pool is generated and it solidifies. Nucleation and grain growth take place and solidifies. So a permanent joint is formed. Metallurgical bond is formed between two metal plates. So all our arc welding processes are fusion welding processes. So we need high energy to melt the metal locally and create the molten pool. And also we can process like GMAW or metal arc welding. Somewhere we are also adding some filler metal so that we are preparing groove and we are using the filler metal to fill and thereby we are getting the joint, because otherwise we cannot get a full penetration. Suppose I would like to weld to a 10 centimeter thick plate, means it should have complete penetration. So then only we can get the full strength. So strength, to not achieve the strength, complete penetration, we need to prepare edge preparation. If we do edge preparation, we need a filler metal. That's what we are using, filler metal. So consumable electrodes are used in case of submerged arc welding, manual metal arc welding. And in case of TIG welding and plasma arc welding, we are using non-consumable electrodes. So this is the background for the welding processes. And in case of solid state welding process, there is no fillers is used. The example for solid state welding process are friction welding, friction stir welding, ultrasonic welding, explosive welding, and diffusion welding. We never use any filler material. So the fairing surface is cleaned and it is used to be solid state welding. So solid state
Sir,
welding process.
your slides are not moving.
Yeah, it's not. Yeah, just I'm giving introduction. You are able to see forces between atom.
Yes, sir. Yes.
Yeah, because I would like to spend 1 minute on this slide because students, it will give you a strong foundation for the students. So here, I hope everybody are all are engineering background. So we studied in our material science, physics, even in school level, the crystal structure, FCC, BCC, and we studied about the crystal structures and packing factor. So all this we studied. But what makes them to arrange in regular fashion? What makes them? Because that is, if you are able to understand, then you can understand solid state welding process. Just because so many students are here, I like to give a brief introduction about the basic principle in joint formation. So, could anybody answer what makes the atom to arrange in regular fashion, that is lattice, in case of crystalline material? Any answer? So we know that FCC, BCC, it is a regular arrangement of atom in regular fashion. What makes them to arrange in regular fashion? Anybody could answer? Because unless somebody tell us we won't stand in queue or we won't stand in proper way. Otherwise, mixed group means random. People would be random. Some force is needed. So atom also to arrange in regular lattice, something should be there. Some reason should be there. Anybody could give some idea about this? How the atoms are arranged in regular fashion in lattice in crystalline material. What makes them to arrange in regular fashion? Any student side? Any answer? Make an attempt so that I can, yeah, it would be more interactive. Yeah.
Sir, to reduce the energy, sir.
Yeah, reduce the energy, that is fine. But what makes them to arrange in regular fashion? Because we studied a lot about crystal structures. We did a lot of calculation in our physics, packing factor, etc., etc. All are metals, no? All are this is crystal materials. Crystal materials. The atoms are arranged in regular fashion.
Sir,
What makes them to arrange in regular fashion? Because this is very, very basic, but still I hope it is worth spending some time so that student would go with a good knowledge.
sir, for that specific packing fraction, there's the minimum energy for which they get arranged in that is.
Yeah. So yeah, I'll give you are attempting. I'm very happy that your answer is partially correct. But let me give the very interesting concept so that you can understand better. See, suppose in the slide you can see atom 1 and atom 2. Two atoms are there. So when these atoms are in infinite distance, there is no force is acting at all. Okay. So we never get angry with people who are living in America who are unknown to us. There is there is no bond between us. So normally we used to get angry with whom? Our best friends, our sister or brother, who is our neighbor, who is close to us. So we used to we are more attached with the people, those who are close to us. We used to get angry. That is, we used to fight with the people who are close to us. So your country, you can also take country also. We never used to fight with countries which are far away. We used to fight with our neighbors. That is natural. So what happened? Atoms, when you bring atoms within some distance, d, then these electrons are getting attracted by the protons in atom 2. Atom 1 electrons are attracted by the proton of the atom 2. And similarly, the electrons of atom 2 are attracted by the protons in the atom 1 because the opposite charge attracts. So one force of attraction is coming to picture. And this new protons in atom 1 is repelled by proton in atom 2. So a force of repulsion is coming to picture. This electron in the atom 1 is getting repelled by the atoms in the electrons in the atom 2. So another repulsive force is to come to picture. So there is a force, attraction as repulsive force is coming to picture. Is it clear? There are force of attraction and force of repulsion coming to come into picture. And you can see here, left side, you can see I am plotting the repulsive force and attractive force, dotted lines, repulsive force and attractive force. And there is another line, solid line, that is nothing but net force. So I can see that at R naught, the repulsive force is balanced by attraction force. You can see the R naught. At particular R naught, total force is 0. So the force of attraction is balanced by the force of repulsion. So this is nothing but interatomic distance, equilibrium distance. So this is causing the atom to arrange in regular fashion in the lattice. That's why we are getting crystal structure. Is it clear? So the force of attraction is balanced by force of repulsion. So that makes the atom to arrange in regular fashion in the lattice. That's why we are getting different crystal structures. Is it clear, students? Is it
Yes,
clear? I hope this is very basic, but it's very, very important. Students, it's clear or not?
sir.
Any doubt in this?
Yes, sir, it's clear. You can
Yeah,
continue.
okay. So what happened when you melt the metal, crystalline material, that is steel or titanium or aluminum, so these forces also will change. When the metal melts, the atom can move freely. There is no bond between atom. So in case of fusion welding processes, molten pool is generated, it solidifies. When it solidifies, the forces are established. So then we have interatomic distance, equilibrium distance, then we are getting a bond. So these forces depends upon temperature. At melting temperature, atoms can move freely and occupy the shape of the container. But in case of solid state welding processes, we are not melting the metal, we are bringing the atoms within interatomic spacing. If you are able to bring the atom within interatomic spacing, then bond will get formed. That is the physics behind solid state welding processes. Okay, but it's not easy to bring atom within interatomic base distance. We need a force to bring them in within interatomic distance. That's why any solid state welding processes, any solid state welding process you consider, a force component would be there. Whether friction welding, explosive welding, ultrasonic welding, any solid state welding process you take, a force component would be there, because then only we can bring the atom within interatomic spacing. But in case of fusion welding process, common motor pool is generated, so the forces are no force is there, so then it solidifies and we are able to get a bond, metallurgical bond. In case of solid state welding process, there some oxides, some impurities should be there, those things should be removed, and the atom should be brought within the interatomic spacing, then bond will get formed. So this is the basic principle behind joint formation in welding processes. So I'll just these are all the solid state welding process. Friction welding is a solid state welding process, and these are other solid state welding processes. And all these processes, force component would be there. Without force component, there is no solid state welding process. So friction welding was invented in 1950s, and it is just the condition is at least one workpiece should be have the property of axisymmetry. So one is stationary, another is rotated, and force is offered, and due to the heat, friction heat, due to friction heat, the metal is reaching plastic condition. You can see red hot, and the force is applied, and then the rotation is stopped, and still the force is applied, and the bond is formed between the two rods. So here the atoms brought within interatomic spacing. A permanent bond got formed. So there is no melting at all. So this is a typical example for the solid state welding process. So there is no filler, no shielding gas, and we have many advantages. The main problem with this process is huge amount of force is needed. Okay, and then so here friction heat is used to make the metal plastic condition, and we are offering a huge axial force of order of 7 kilonewton, 10 kilonewton. So all the impurities coming out as flash, a virgin metal is coming in contact, and as I said, this is within interatomic distance. So a permanent metallurgical bond is formed. So this process was invented in 1950s, and friction stir welding was invented in the year 1992, and it was invented by W.M. Thomas and his team in the Welding Institute, UK. So one of my student is working there, and as a scientist, he did my PG in welding in our NIT Tiruchirappalli, and he invited me. I also visited the welding research, the institute UK, and it was wonderful place. And all the type of welding process they are doing R&D, particularly emerging areas. They are doing a lot of activity in the advanced welding processes. And so this process, even today, a lot of R&D is going on in the Welding Institute. So this process is having a lot of advantages, and this process can be it is widely used in aluminum. Most of the applications are aluminum and magnesium. See, next to steel, aluminum is most used metal. And the aluminum welding by this process is very, very easy, because welding of aluminum by arc welding process is very challenging, because oxide formation, aluminum oxides are 3 times the melting temperature of aluminum. Al2O3, that is aluminum oxide, is very stable. It is having the melting temperature of 3 times the melting temperature of aluminum. So it's very challenging to weld by arc welding process, but it's very easy to weld by friction stir welding. So even today steels are used, steel, titanium, magnesium, people are using extensively. And 1 to 75 mm thick plate can be welded in single pass. That is the beauty of this process. Okay, so the thick plate without any shielding gas, this process can be used. So this is going to be one of the, this is going to, in coming days, this would be used extensively in particular shipbuilding industry. And this is the principle behind the process. We have the tool, pin, it is made by high strength material, and the plates are assembled on the machine table, and the tool is rotated and moved. So when it move from along the joint line, a bond is formed between the two parent metals. So this is a solid state welding process, and the drawback with the friction welding is it is used for rods. That is one of oxysymmetry parts. But here plates can be welded. Plates can be welded. Even 75 mm thick plate can be welded. Aluminum plates can be welded without filler metal, without shielding gas, without any arc. It is purely solid state. We can weld 75 mm thick aluminum plates by this process. And this is a more energy efficient process and having good potential applications. So this is I'll share. Okay. So a lot of advantages with these processes, but the problem is for welding of steel, it is challenging to design the tool. That is a major limitation for this. And so here metal flow phenomenon, if you see the cut section, we have different zones, and we can have stir zone where the metal move physically with the stirrer, that is a pin, and there is a thermomechanically affected zone, and HA is a heat affected zone, parent metal. These are the zones available in the typical friction welded plates. Stir zone means the metal physically move along with the pin. So that is stir zone. Just adjacent to stir zone, there is a thermomechanically affected zone. That is nothing but due to movement of the metal, the orientation of grains are getting disturbed. Suppose if you see the river, if some rock in the middle of the river, it is getting rolled along with the river flow, water flow, and moves. That is like stress zone. Along the bank of the river, the rock, they won't move, but the orientation will get changed because of the water flow. That is like thermomechanical. So in river, we can get mechanically affected zone. But here, temperature effect also there. So it is thermomechanically affected zone. In HAZ, there is no mechanical effect, only temperature effect. So heat affected zone. So it is only heat effect is there. There is no mechanical. There is no effect due to the movement of grains. So HAZ and base metal. In case of other welding processes, the TMAZ will not be there because there is no movement of metal. So only we used to get, in case of fusion welding, we have fusion zone, HAZ and base metal. Base metal, there is no change in the microstructure. HAZ, there is change in the microstructure due to the heat. In case of fusion welding, in fusion zone, yeah, the metal melts and resolidify. So that is this is what happening in fusion welding. In this case, we have thermomechanically affected zone. Yeah. So this is the typical friction welding process. Two plates are assembled, and tool is having a pin and shoulder, rotated and moved. So rotation speed of the order of some 600 to 2000 RPM, and the traverse speed that the tool moves with the speed of say some for 50 to 500 mm per minute. So very fast rate it moves, and the joint is getting formed. There is single pass. Now in case of arc welding processes, we used to go for multi-pass welding. We thick plate, we used to go even 20 pass, 25 passes. But in this case, we can get a bond in single run. If the thickness is very high, we can go with a pin length such that it is 3/4 of the distance of the plate. So we can weld from both sides. So we can get two passes. We can achieve even 100 mm thick plate complete penetration. So without any filler, without shielding gas, without edge preparation, like V edge, U edge like that, just we need to clean and ensure that it is free from oxides, scales, etc. So then we need to assemble the backing plate. Bottom is backing plate, and we need to weld. So this is the background of frictionless welding process. And this is having a lot of applications in aerospace. Wherever aluminum welding is involved, it's having application. And the steel also getting popular nowadays. And you can see shipbuilding is having wonderful, many potential applications. Already, this process is used widely in shipbuilding. Automobile. So particularly dissimilar welding, this process is having a lot of advantage compared to arc welding processes, because here the problem with intermetallic formations are very less because metal is not melted. Metallurgical issues are less this process. So in shipbuilding, because this particular conference is focusing on shipbuilding, and so let me spend some time on shipbuilding application of this process. So panel, wherever thick plate is involved, we can weld aluminum welding, and panel for deck and wall construction, bulkheads, honeycomb panels and corrosion resistant panels, for formed hulls. So all these are the potential application for frictionless welding, and already used extensively in many countries, and tailored welded blanks. So these are the battery casings. These are some of the applications of this building. And yeah, this particular shape welding, this boat is made by a frictionless welding process. And yeah, I'll show a video clip. Yeah, I hope it will load. Video is playing.
Yes, sir.
Video
Yes,
is playing.
yes, we can watch it, sir.
Is visible? Video is playing or not?
Visible, sir. Visible.
Yeah. Okay. Thank you.
Sir, are we supposed to hear any audio?
Yeah, video you are able to see?
We can watch it, but we cannot hear anything.
Oh, sound is not there.
Yes. No
I
sound.
see. But video is okay, no?
Yes, video is okay.
Okay, no problem. More, it's only the music only. Don't worry. No problem. Yeah, I hope it was got some idea. So shipbuilding heavy machines are available, and tools are available to weld different thicknesses. And there are tools especially for lap joint. There are tools for butt joint, and so this is a brief introduction about frictionless welding process. And yeah, these are the structures, hull and superstructures. Because, when I visited Cochin Shipyard, yeah, I saw that a lot of ship fabrication, they use superstructure as aluminum and hull as steel. So there is need to weld steel with aluminum. So a lot of R&D is going on. I am also working in this area, welding of all steel with aluminum. So that just 2 slides I'll show you. Recently, patent also got granted. So I'll discuss at the end of the presentation. Okay, so these are the parts made by friction welding in shipbuilding application. So this is a tool. Tool typically has pin and shoulder. Pin is called stirrer, and the shoulder rubs and generate heat. So my work focus on I started the research in 2003 in frictionless welding, and when I started the work, the process, the metal flow phenomena was not known. Very few, only two papers were available, and I studied this phenomena, how the joint forms, what is the physics behind. Then it was accepted in journals, and so I given the theory that joint formation principle I given, and it was well appreciated. My paper was the first paper from Indian side in friction stir welding. Then I started my work, and now I'm happy to share 13 students completed successfully in friction stir process. Not only friction-based process, I can tell. So we gained a good experience in this process. Different tools are available for different applications. Yeah, so for thicker plate, we can go for 2 passes. So by that, we can weld without filler, without shielding gas. And there are special tools available for butt joint, lap joints, and both butt and lap joint. Many tool designs are available. This is very interesting slide. So this is the definitely, as I started my lecture with the carbon tax, this is going to be a very big problem, and only 2.5% of energy needed for laser welding. This this is energy efficient process. So wherever possible, wherever feasible, we should explore and employ this process so that we can drastically decrease our EB bill, as well as we can reduce the carbon tax. And there is no hazards, pollution by this process. So definitely this is going to get momentum in coming years. So no loss of alloying elements, excellent metallurgical property, fine microstructure, absence of cracks. So conventional welding, we used to get cracked because of the cooling, but here the metal is not melted, so there is no question of hard cracking. So many advantages we have this process. Okay, many advantages we have this process. And yeah, no shielding gas required, no surface cleaning, eliminate grinding waste, and all the we have many main drawback with this process is the process, the main drawback is a lot of forces are involved. We need to offer force, and our machine should be able to withstand the force. So machines, if we want to weld a thick plate, we should have machine with more capacity to offer force and take the force. So they're very expensive, very expensive. So in case of arc welding, a simple we can purchase a good power source, no inverter power source. Say 25,000-30,000 we can purchase. We can do any shipbuilding, can use anywhere, we can use thick plate, anywhere we can use. More flexible. Wherever we need joint, we can take this power source, inverter power source, and we can do welding. That is the main advantage with the arc welding processes. But here we should fix the component in the machine table, and the tool forces are involved, and very complex structure we may not be able to weld, and lot of forces are involved. So the investment is high, machine cost is very high, but the consumables are literally less. So there is no need for shielding gas and filler material. It is a lot of 100%. This cannot replace arc welding processes. Definitely, we can increase from 10%, 20 to 30, like that. We can keep increasing so that we can get lot of advantages. That's what research. So we need to increase the application of this process in shipbuilding or any fabric. Then that is what research, we can get a good saving in cost, as well as carbon tax we can avoid. So this is the background of this presentation. This is spot welding. This process also can be used for spot welding. And here, in this case, aluminum welding of aluminum by spot resistance welding is very challenging. And but this process very simple to weld aluminum by this process, because aluminum is having excellent conductivity, heat conductivity, as well as the the electrical conductivity. So resistance welding is very challenging. Even today, our automobile, the body in white, that is nothing but an automobile body is fabricated by steel. We know that aluminum is having better strength to weight ratio. But even today, steel is used as a fabricate body in white. That is whatever auto body in white. The reason is The steel sheets are easy to weld by resistance welding. Roughly 5,000 welds are there in each automobile, and 5,000 weld by we need to have a more production rate. If you visit Hyundai, every 2 minutes one vehicle will come rolled out. So the production rate is very high. So this can be done only by robotic spot welding machine. So steel is the material used for auto body. Aluminum is best material, but because of the ease of fabrication, steel is used even today in auto fabrication. But very higher end cars, they are going for aluminum bodies, so that we can get better mileage. And the steel, even today, most of the auto body in white is fabricated by steel only because easy to weld by resistance welding. But this is one of the alternate process. We can weld the aluminum by the spot welding. Nissan, they started using this in some of the parts in the auto fabrication, aluminum plates, they started using the spot welding. So these are the, and if so frictions welding, same machine, we can go for other applications like defect elimination. In casting, if defect is there, we can eliminate defect, homogenization, superplasticity, surface composite, metal matrix composite, surfacing, bulk nanomaterial, rapid manufacturing. All these type of works we can carry out in by same machine. So this friction processing is different. Friction surfacing is different process. Here the mechatrod is consumed. It rotates and moves. That mechatrod is getting coated on the surface. For example, 1 series aluminum alloy is having better corrosion resistance over the 5 series aluminum alloy. So we can coat 1 series aluminum alloy on the 5 series aluminum alloy by this method, friction surfacing, so that we can get a high strength by 5 series aluminum alloy substrate and corrosion resistant by 1 series aluminum alloy. So this is completely different from friction welding. This is friction surfacing. So here consumable mechatrod is used, and it is rotated and moved with the axial force. So it is getting coated on the surface. And these are the configuration we can weld by our friction welding process. Different, but mostly we are going for butt joints. Most of our application is butt joint. So this is the machine which I developed in 2002, and even today it is working. That time I was working in Birla Institute of Technology. So this is the facility available in National Institute of Technology, Tiruchirappalli. So this is 10 years back we purchased this machine. Even today it is extensively used. And before 10 years it was 75 lakhs. And this is a 4-axis friction welding machine. And we did a good amount of research projects, and ISRO and UK project based on this machine. And metal flow I'll skip because this is the scope is I think I will not discuss more about metal flow. This is R&D part that I will skip. And I will talk about another 5 minutes about tube to tube. Okay, this is a typical microstructure of friction welded plates. And we can see some onion ring patterns. And this I will skip. Metal flow phenomena. Yeah, this while doing friction welding, I got one new idea. That is nothing but tube to tube plate welding process. So lot of heat exchanges we need dissimilar metal welding. So I got idea and I filed patent 2006, 2008 patent was granted. And in this, a hole is made, tube is inserted, and similar to friction welding tool, we designed a tool, and the tool rotates and it is lowered. What happens, you can see the plate is getting plastic condition, and the more plastic metal try to come and contact with pass through the hole and fill the gap, and it fills the gap, and bond is formed between tube and tube plate, and the tool while rotation it is removed. So by this we can weld a dissimilar tube with two plates. So already this is used in many application automobile, and this patent was filed 2006 and granted the year 2008. And I'll show some of the things. So yeah, this is the welded, copper is welded with aluminum. So this is the process. Yeah, the tube, when plastic metal reaches plastic condition, it flows and occupies the gap and a bond is found between tube and tube plate because both the condition force is available at the point interface and temperature is available. So solid state bond found between tube and plate. This is what bond. So this is the cut section of the tube to tube plate process. This is different from friction welding process because here there is no stirring of metal. So you can see the interface, the line interface. This is a typical friction welded bond interface. So there is no stir zone. It is if you cut and see the friction welded plate, it would be like this. So I remove that is my pattern I mentioned friction welding of tube to tube plate using external tool. There is no word stir because there is no stir. The purpose of pin is to act as an anvil. So there is no stir of metal is taking place. It is completely different from friction welding process. The bond interface is a typical friction welded interface. There is no stir zone. So friction welding process. This is a modified friction welding process. We can tell this is in between friction welding and friction welding. So the tool structure and all like friction welding, but bond interface and properties are like it is a friction welding. But here the advantage over the friction welding is here both the plate as well as tube and tube plate are stationary. So that is advantage. So more than 5 student scholars, they completed PhD under my guidance and they explored different combinations. And more than 25 people completed their MTech project in this particular process. So we studied extensively this process and it is well accepted internationally and many people abroad have started PhD in this particular area. So this is steel also we explored. One student, he did a tube-to-tube welding of steel. And yeah, it is having a lot of potential application. And with we used to keep some titanium and stainless steel. We faced a lot of problem. We kept interlayer and we could achieve excellent strength. So that is what these are some of the patents granted in field of friction welding process. And this is what the recent process. Recently, I started working bimetallic plates. Another time, I hope I have another 10 minutes. And we'll have a 5 minutes for discussion.
5 minutes.
Pardon?
Can you summarize within 5
Yeah, I'll
minutes?
summarize. Then I'll take 1 or 2 minutes. I'll summarize. Then we'll have more discussion part so that student can ask doubts. Participants, they can ask their doubts about this process. I can clarify. Okay, another one. Let me conclude then. Okay. Okay. So here, steel need to be welded with aluminum. So that is a major requirement in shipbuilding. And right now, it is made by Triclad. It is a brand. It is a trademark. It is a trademark. It is a popular company supplying the by a trimetallic plate. That is a Triclad. Steel, 1 series aluminum alloy. Top, it is 5 series aluminum alloy. So you can see the in field, in case of shipbuilding, steel can be welded with steel with arc welding process, and aluminum with aluminum can be welded by arc welding process. So this is the typical triclad. But the problem is, you can see the phase diagram. There, if the temperature exceed 200, we will get intermetallic. So in field application, this triclad is done by explosive welding. Explosive welding, and the 2 plates explosive welded and made into strips. 3 plates. First, steel with 1 series aluminum alloy is welded. Then on this 5 series aluminum alloy is welded. Another time. Then they made as a strip. So this strip is supplied for fabrication. In field application, in fabrication of strip, we can use this triclad. We can weld steel with steel by arc welding process, aluminum with the arc welding process. This is called transition joints. Transition joints. So, but the problem is, while welding with arc welding, the bond interface should not exceed the temperature of 200 or 400. Where the bond between a steel and aluminum in triclad, that should be restricted not to exceed 200 or 250 or so. So if it exceeds, intermetallic formation would be there. So it will drastically decrease the strength of the joint. So this is very big challenging. This is what I am working, and I developed a better process for this, and it is a plastic process I given. And this, I used a cooling tunnel. This is friction-based process, and we are exploring this process in shipbuilding. So I think this is having a lot of applications. Yeah, and I hope we two scholars are engaged in testing and characterization. I hope shortly this will find application in shipbuilding. With this, let me conclude, and now it is open for discussion. I'll stop my let me stop my PPT. Yeah, I request the audience to ask the doubts so that I'm happy to share my experience.
Thank you very much, sir. So for your valuable talk about application of friction steel welding and fabrication process in ship. So from audience side, if you have any questions, you can ask now.
Hello, sir. It's Amal from Cochin Shipyard. Am I audible?
Yeah, little bit louder. Yeah, you are audible little bit louder, please.
I am Amal from Cochin Shipyard.
Yeah, good.
Okay. So you are dealing with this friction stir welding, and I'm curious to know about its usability in thin plates. Like I'm talking in the range of 4 mm, 5 mm thick steel plates, and its deformation and clamping forces, so that the plates are not distorted.
Yes. So you are asking application of friction welding in steel, welding of steel plates, all right? Steel plates.
Yes.
Yeah, steel plates. So I got one project that is Naval Research Board, welding of steel by friction welding, successfully completed, and that with available machine we could weld steel plates. But the welding of steel is very challenging because the tool will get worn out. For that, we should have a PCBN tool. The tool is very expensive, 2 lakhs. If but that also very brittle also. That tool is very difficult to handle, but it is challenging. But welding of aluminum is very, very easy by this process. Ordinary medium carbon steel, you can just machine it and you can use as a tool. But if you want to weld steel, the tool is very expensive. PCB and material we should go, or tungsten based alloy we should go. I used only tungsten alloy or a tungsten based alloy for my work. But tool worn out is tool after three or four welds, the tool is to get worn out. It's a very big challenge. And yeah, you are correct. Welding of steel is very challenging. But PCB and tool, people started using and in field application and shipbuilding application and many oil pipeline application. They started using PCB and tool for the fabrication using friction welding.
Okay. Then it's okay. In the case of aluminum also, I want to know about how you are going to clamp it, because friction stir welding requires very high forces, right? And if you are giving that much clamping forces, there are chances that the plates might distort during welding.
Yes, you are correct. If it is a configuration is like a panel, no problem. But complex structures, it is really challenging to weld complex structures. And moreover, the tool also should, that's why 5-axis, the one video I showed, no, that is CNC machine. So if you are able to clamp, yes, that can, but it is complex. It is somewhat challenging. But that's why I'm saying easily we can identify 10% of our welding in Cochin shipyard application where aluminum, for example, where easily we can use because longitudinal welds, panels. Then we can go for challenging parts. That's what research. That we should go. First, we should start with 5% replacement, then 15%, 20, 25. So that's what research, and we should put some effort. And already we started some work with Cochin Shipyard in implementing. We have a strategy to implement this process. Yeah. Thank you.
Yes, sir. One more last question.
Sir, I am Charles from Cochin Shipyard.
Yes,
Sir, in aluminum structure, majority of the welding, that is almost 80% of the welding is fillet weld, and only 10% to 20% is the butt weld. And in that part 10 to 20%, there are formed plates are also there. So what will be, how you will, is it economically viable to use these machines in shipbuilding?
Yeah, thank you very much. Actually, there is one term, I'll explain you. Yeah, Maruti Alto. Let us take a Maruti Alto vehicle. It was, I think 90s it was released, something 90s it was released. Today also it is a successful model. Some around, say, around they're selling every year, some around 50,000 or more than that. Maruti Alto, I'm just telling. I'm example I'm telling. So, it looks almost same. But if you open the Maruti Alto, old Maruti Alto and new Maruti Alto, you can find lot of new vehicles, you will find lot of plastic components. Older vehicles, metallic component, completely everything was metal, but now many plastic they started using. Why I am telling this example, by going by plastic, our manufacturing process will change. If suppose I use plastic component, single blow molding, I can make the product. I can assemble. But in case of, if I want to make by same, suppose I have a fluid one tank, suppose oil tank. If I want to make the oil tank, by metal, I need to do cutting, welding, trimming. But in case of plastic, single blow molding, I can make the total part. So it cut by cost. So that's why they are able to reduce the cost. See, salary and all, if you compare 1990 and now, it's almost a 50 times increase, 50 times. But the product, those days, the Maruti Alto was some 3 lakhs. Now it is like 6 lakhs, some like that. For example, I'm telling only the cost only 2 times. But everything increased 50 times, 40 times, 30 times. But still they are able to control because they are going for advanced manufacturing processes and so that materials. So in case of shipbuilding, yes, I completely accept. Design stage itself, we should modify something. Some modification, some planning can be done to accommodate friction shielding process. The design stage itself, this should be taken to take care to use friction welding. And another thing is, the very big problem is there is a big challenge in welding of steel with aluminum by triclad. That is presently there is a very big challenge. That is bimetallic. That is triclad is used, but intermetallic form is a big problem. And the welding should be done in very slow process so that the triclad bond interface is not subject to high temperature. This is a bottleneck in fabrication because it consumes more time. So if advanced process, a fixed welding process used, and we can go for higher production rate. So it also cut the cost because triclads are very expensive, but this is relatively 1/10 of the cost. So we can get a very better saving, and we can achieve faster production rate. Both the advantage we have. I'm 100%, I'm correct. I accept with you. We cannot replace 100% all the fabrication. At least we can replace 5 to 10%, and we can do R&D and try to increase the percentage of application so that we can future the carbon tax is going to be a very big headache for the fabrication industries, that we can reduce the maximum extent.
Sir, thank you very much. Sir, we'll start the session. So is it okay?
Any more question? I'm happy to share because I gained some experience, and if any questions, kindly happy to share. And one more point I like to highlight in national technology, we PhD part time is available, full time is available. For student, yes, the 35,000 stipend is given for full time PhD student per month, and PG is offered in welding engineering. So if anybody is interested, they will come. Shipbuilding people also can apply. And any UG degree in mechanical production, mechanic sciences, you are eligible for MTech. And 100% placement, we have a tracking record of 100% placement. Many of students are working in R&D, Boeing R&D, and many good company in industries. So students, if somebody is interested, yes, you can join. Placement is almost 100% consistently. And regarding the part-time, those who are working in the Cochin shipyard and all, with BTech, with 10 years of experience, directly they can join PhD. Recently also one general manager, Mr. Meganathan, joined PhD under my guidance. And with BTech, 10 years of experience in R&D lab, government R&D lab or PSUs, they can directly join PhD. Very good opportunities are available and a lot of flexibilities are given for part-time PhD to carry out the work in their place and also to attend coursework. Lot of concession, lot of we did lot of provision for making the process easier for the practicing engineer to complete PhD. And this is just I thought of sharing. Yeah, thank you. Thank you for the given opportunity. Thank you very much.
Thank you, sir. Actually, sir, we need a little more help from you to chair the next session.
Yes, yes, I will be available. Yes, yes. Kindly.
So, with you, Dr. Manoj, sir, thank you very much, sir. Actually, we are showing you, I mean, we want to give you a certificate and memento. So, certificate we will show you in online.
Yeah, thank you. Thank you. Thank you very much. Thank you. Thank you.
Okay. Thank you all. And sir, we'll start the next session for all students. Next session is about materials and corrosion. So I'll hand over the mic to Manoj sir. Manoj sir, please come. Yeah, next session we have 5 speakers in materials and corrosion, starting with Deepak Sebastian sir. Muthukumaran sir, shall we start the next session? Is it okay?
Please start. I am available here. Yes, yes. Kindly, you coordinate. I am attending. Yeah, yeah.
So, good afternoon and welcome to the third session of this international conference on advances in naval and ocean engineering. This session is on materials and corrosion, and the first speaker that we have is Commander Deepak Sebastian, paper ID number 132. So, may I invite?
Good afternoon, one and all. Thank you for giving me this opportunity. My topic is estimating ship repair time using multiple linear regression analysis, co-authored along with Professor Dr. K. Shivaprasad. So, coming to the relevance of the topic. So, the stages in the life cycle of a marine asset or a marine structure would be broadly into 4 categories, that is design, construction, operation, and disposal. Now, what I am focusing on is the operation part. Now, if you look at operation, one is the ship is being operated or the structure is being operated. That is, the ship is in service. And then the other part is the maintenance of the structure or the asset. So the maintenance can be while the ship is being operated. So while the ship is being operated, you can have people maintaining the ship. But there is something called as breakdown maintenance. That means the ship is not being operated. So the ship is taken out of service and it has to be put into repair. So that time is, I'm calling it as the ship repair time. So in the topic, I would borrow the words of Dr. Ebenezer, that the word is not determining, but estimating the ship repair time, because it's with an allowance. It's not exactly determining what is the ship repair time. So what is the relevance? So when a ship is not in operation, each day of non-operation or downtime costs millions of dollars. So ship repair time or the ship downtime plays a huge role in the economic operations or the economic viability of sustaining the ship or for the ship owner. So reduction in the repair time is vital, and towards reducing the repair time, we have to identify what are the factors contributing to the repair time. So once you have identified the factors which are contributing to the repair time, then the total repair time can be estimated, and we can make efforts to reduce the repair time. So here there are two things that I want to bring out, that the aim is, I'll come to that. So the first objective is to carry out a multiple linear regression analysis to arrive at a regression equation. Using that regression equation, I can predict, or we would like to predict, what will be the ship repair time. Now, this is a challenge for many shipyards, that when any ship owner approaches the shipyard asking for how much time will you take to repair my ship, then the shipyard has to predict that, okay, I will take so much time, because for the ship owner, that much time the ship is going to be down, and that much time the revenue will not be generated. For how does the shipyard predict that? Now, the shipyard uses past data to predict that. But for any ship, the amount of or the quantum of repair work can vary from ship to ship. So if a shipyard has got a regression equation by which they can evaluate or estimate the ship repair time almost accurately, then it will give them a realistic day or a time that they can give to the ship owner. Now, what happens generally is that the shipyard estimates, let's say, 1 month or 2 months for the repair time, and it turns out to be 3 months. It's a big loss for the ship owner that 1 extra month is gone. So estimating, one thing is that, and the second part is trying to find out which are the factors which contribute to the, maximum contribute to the ship repair time. Is it welding? Is it cutting? So that we can focus on reducing the time spent on those activities or reducing the quantum of work on those activities. So I've just shown a small image on linear regression and multiple linear regression. So for those familiar or not familiar with it, you may have to read up on that. But the idea is that if you look at the lower one, the multiple linear regression, there is a Y. The Y stands for the ship repair time, and the multiple predictors are the factors contributing to the ship repair time. So Y will become the dependent variable, and the other factors become the independent variable. That means ship repair time is dependent on all the different types of factors or work quantum. So the process that was followed is identify and quantify the factors, analyze the correlation, eliminate redundant or irrelevant factors, and then derive a multiple linear regression equation. The process of data collection, I'm not going into the details. So the next step is to identify and quantify the factors. So this you might be familiar with. One is the ship repair time is the dependent variable, which is dependent on, I am taken age, the displacement of the vessel, the hull washing. Our hull washing is, the first image on top is the hull washing. Once a ship comes into the dry dock, there is an underwater marine fouling which is there, which needs to be cleaned. So only once the cleaning is done can the repair activities on the underwater hull commence. So hull washing is one major activity. Then there is tank cleaning. For cargo vessels, most of them have got tanks or holds. So if it is, in my case, I've taken tankers mostly. So tankers have got cargo tanks which need to be cleaned. So tank cleaning becomes a major activity. Cutting, welding, then painting, piping, and insulation. These are the factors that I have considered for this study. That's about 9 factors. So you can see how I have quantified them. Age is in years, or the units are displayed against each of those 9 factors. There are many more factors which can be considered, but for this study, that only this has been considered. The data collection was a tedious part, because anybody from the shipyard here would know that the data regarding the quantum of work which was done is only available in the invoice or the bill that is given to the ship owner. But quantifying that for all these heads is quite difficult. But then, using the invoices, and shipyards do not generally share the invoices easily. So very old data could be, obtained, and which was released easily. So this is the repair quantum data that was collected. Now to analyze the correlation. Correlation means what is the relationship between age of the ship and the ship repair time. So like that, for example, if you see this linear plot, you can see on the x-axis is the age and the y-axis is the ship repair time. So in this case, the numbers are very less. For about 10 to 11 ships is what I've got the data, but I decided to go ahead with it in any case. So you analyze the data and then correlation between, does age have a positive correlation or does it affect the ship repair time or not? Like that, for all the 9 factors, this kind of a correlation evaluation was done. And the analysis is, first is the trend line. Trend line gives, what is the simple regression equation. If you have noticed in Excel, it gives you an equation for that trend line. The covariance indicates the direction. Direction is whether if age increases, does ship repair time increase, or is it inversely proportional? And the correlation coefficient determines the strength. That means if the age increases by 1 year, how much proportionately does the ship repair time increase? What is the strength of the relationship? So as a thumb rule, if absolute value of R, that is the correlation coefficient, is greater than 2 by root n, in this case, n is the number of samples we have got, then we have got a value of 0.6325. You can see in the table that age is the only factor which is above that. But we are going ahead with the calculation or consideration of all factors because I'll come to later why we are getting such low values here. The second part is something called as coefficient of determination, that is denoted by R square. R square means how well this regression equation fits the data. So if R square is greater than 0.6, then it can be considered a good fit for this kind of data. And it is observed again that in the second table that the highest value for R square is for age, but even that doesn't meet the basic criteria. So we proceed to the next step, something called as checking collinearity. Collinearity means two of the independent variables, that is, let's say, cutting and welding, or let's say underwater hull surface preparation and painting. Now both have the same area, so they might be interrelated. So you will try to find the relationship between each of the independent variables and see that if they both are having high correlation, then they will you need to eliminate one of them. So like that, I found out that cutting is again having high relationship with welding. So I've eliminated cutting. Now derivation of the regression equation. So the regression equation is, if you can see the first top line, y is equal to b0 plus b1 x1 plus b2 x2 plus so on and so forth till bk xk, where y is the predicted value. That means y stands for the ship repair time. x1, x2 is the value of the independent variable, like say, for example, age or displacement, etc. And b0, b1 are all the coefficients of the independent variables. Now, in this case, you can see that I've substituted it. SRT is equal to B0 plus B1 into A. A stands for age, plus B2 into D, which stands for displacement. The highlighted ones, which is C and PP, are piping and cutting, which are found to be the redundant variables. I've eliminated that, and using multivariable linear regression analysis, we have arrived at the coefficients that is at the bottom, that is B0, B1 to BK. So the results indicate, to validate or to check the results, in this regression equation, I input all the values which I've got for the 10 sample ships. And then you can see at the bottom that the 10 ships, the percentage error, except for serial number 5, 8, and 3, except for 3 ships, the error value is less than 10%, which in this case, I've assumed is a fair enough, probably a 70% accurate estimation of the ship repair time using a regression equation. So I can, to a certain level of accuracy, can estimate the ship repair time is the output that was received from this, and we could identify that age does play a high role in this. But the results are a little bit erratic and not entirely to my satisfaction, and that I would attribute to the small data set, number one. And errors could be due to the data which has been laboriously extracted from the invoices, etc. And it may also be noted that the applicability of this is only to a particular type of ship, in this case tankers, and only to the shipyard that I've obtained the data from. This is some 3D plots that were done taking 3 parameters. I will skip that. The way ahead I would propose, or which I intend to do, I have got more data on more ships. So a larger data set is expected to give a more accurate analysis and a more accurate prediction. And aim is to get a universal, an equation which can give universal applicability to any shipyard, to any type of ship. Is that a possibility? And whether we can generate a code which can be used by shipyards to ascertain or predict or estimate the ship repair time. So these are the references. In fact, only 2 or 3 authors I have found who have been able to work on this particular aspect. The data, previous papers on this are very limited. So I intend to study further on this. That's all. Thank you.
Yeah, thank you for the presentation. Now it is open for discussion. And yeah, this is a very, very important topic, because in case of aircraft, they used to remove the turbo engine in the hangar, and they used to replace the turbo engine. And the turbo engine alone taken, turbine alone taken to the service station and repaired. The aircraft will keep running because they used to fit the another engine. But here, the shipbuilding completely, it is where the ship, complete cost is, the idea, it's not functional. So it is completely, if do 1 month repair means 1 month it is in the unusable. So definitely this very wonderful work. So having a lot of potential. And yeah, any question from audience?
Good afternoon, sir. My question is, sir, when shipyard undergo a project, be it construction project or a repair project, then a critical path method is a pathway which is used to analyze each and every step which is related to that particular construction or repair. The exact time, not exact earliest completion time, latest completion time, and all are calculated on the basis of previous data that is shipyard has undergone. So if according to that, we also calculate the total time completion of the project using the critical path method, which is standardized used everywhere in every shipyard. It is. So what is the need of even calculating ship repair time when which is also not containing all the quantifiable factors which are responsible which could occur during the process. So when a critical path method is followed to find the similar solution of total project time, which is also on the base of a practical experience.
Okay, thanks. To my understanding, a critical path method is a refit management tool. That means once you start the refit or the repair, then how do you plan or sequence your activities so that you can complete it in the target time?
Yes.
So it's an effective management tool for implementing the repair. This is prior to that stage, wherein you are in a negotiation with a particular ship owner, that how much, one of the parameters that you need to give to the ship owner is how much time will you take to finish the work. So the ship owner has to give the data as to what is the expected amount of work that is going to come. You have to predict how much time you will take to do it, because accordingly the ship owner has to plan for his operation, that he will, let's say you tell him that the ship will be down for 3 months. Then he, on the 4th month onwards, he will already tie up and take projects and assignments for shipping, cargo, etc. So if you don't meet that timeline, then he will miss that revenue. So once you commit 3 months, then the PERT or the CPM will help you to complete that activity within 3 months. But before you reach the commencement of the refit, you should be able to give a realistic value to the person that, yes, I will be able to complete in 3 months. How do you arrive at that value? That is the question.
In that method, for every step, we are having a earliest completion time. And a critical path is there, which is the overall time required for completion of an activity. That first calculation of time is also done using the earliest completion time of each activity.
Yeah, so that is about the sequencing.
Yes, sir.
So here the idea is to generate an equation which can give you, for giving you a, what you call a quote, saying that what will be my predicted time to complete the task. That is the objective of this particular thing. Thereafter, the sequencing is what I think you are talking about, as to which sequence, which activities will go in parallel and which activities will go sequentially. Whether you will do the hull washing first, thereafter you will follow the surface preparation, thereafter you will do the surface, but parallelly you can do some activities.
Yes,
So
sir.
that I think will be covered in the CPA.
Yes. Thank you.
Thank you very much. And definitely this has a lot of scope. Even machine learning, you can think machine learning, but we need more amount of data. And you can also think about applying machine learning in this project. And thank you, Nina. Thank you. And yeah. Shall we call the next speaker? Thank you for wonderful work. And next is numerical study on effect of internal forces on subsea pipe in pipelines by Dr. Venkatraman. Yeah.
So the topic is numerical study on vibration optimization with stabilization of subsea pipeline. So basically, so this is the overview. First, I'll talk about the introduction part of it. First, the pipe system consists of, this is a generic term, 2 watts. Actually, I have 2 pipes. One is the outer pipe and another one is an inner pipe. Inner pipe is the pipe in which the fluid is flowing. Basically, this is used in the oil explorations in the offshore system. In the offshore, we will be exploring that oil, and that oil is flowing into that inner pipe. And the outer pipe is the one which is giving the stability as well as the vibration. So the pipe system is followed in many industries, right? And the PIP system is mostly used in the subsea pipeline for transporting the oil and gases and for the transport of the water also. And the PIP systems provide the greater resistance to the higher temperature because that outer pipe is being insulating that inner pipe so that the variation in the temperature to the inner fluid which is flowing is being reduced so that it is having the higher resistance to the temperature variation. So the basic elements in PIP systems are the flow lines. First, the flow line and the carrier. Carrier is called as the outer pipe. The thermal insulation, this is the part in between this outer to the inner panels, and then the centralizers. See, the centralizers are the one which are placed at some distance apart in between them along the axial distance in between the outer pipe to that inner pipe. Right. The various types of the insulation material that I'll show that. This is the PIP pipeline. The outer pipe, you could see that, and the in between that red part is that insulation, and you have that a ring shape, that is one is the centralizers, and inner pipe, and the last one you can use the bulkhead of it. It is attached to that one. So this is the cross sections of the pipe. See, the carrier pipe is the one is in the yellow line, and above that you have the anti-corrosion coating will be there usually, and in between that you can see that rings, and then the blue is called as the centralizers. And you have a thermal insulations in between as a blue, you can be able to see. And the innermost part one is nothing but your flow line. You can see the real picture of that PIP, which is there in this. So the components of it, you can see that these are all the components and really how it will look like. Basically, the same thing which I have explained to you. So just to go through that. Okay. The same. This is the subsea oil exploration, just a schematic diagram, how it is being done, and all with all the components, as well as how it is really look like in this bottom. We could able to see that. So this is basically the subsea pipeline is at the bottom, right? It is at the bottom, it is being at the, you can have, there are 4 scenarios depending upon the support or the foundation of this subsea pipeline. The pipeline cross-section is given, and the bottom one is the seabed. The seabed, it is structurally, if I want to speak, the seabed can be at the bare rock that is very hard, so that the contact is very minimum or either barely at a point or few. Second one is the hard rock. The first one is the pipe subjected to the abrasion as well as the damage to external coating, so that the hard pipe, right, bare rock, if it is supported by that. Second one is the hot soil. The hot soil is having some contact. The contact area between the pipe as well as the seabed is moved. The pipes is subjected to the lateral migration in that case, right? So there is a, due to the currents as well as this, but this is, you have the, because of the smaller amount of the contact between the water column, that is the pipe as well as the seabed. The third scenario will be that medium soil. The medium soil is the best resistance. This is the best one when compared to the all the 4, where you have better resistance to the lateral migration, as well as you have more the contact area when compared to the remaining previous 2. The fourth one is the soft soil. You have the soft soil when you have the pipe in pipe which is placed on top of it. It is almost or fully sink into it, so that you are, it is hindering that many of the operations are like the inspection as well as the maintenance, and it is sometimes it is very difficult to see where the pipeline is. Correct. So, previous. Yeah. First, there are many literatures for the vibration as well as the stabilization of the subsea pipeline. First, this is the main paper in which, based on which the work is being done and using the pipeline systems for the subsea pipeline vibration control. Because the vibration control is one of the most important property, right, in the under the subsea pipeline systems. This is the one, and second, about the dynamics on the bottom stability analysis of the, this is about the stability analysis of the piping systems using the finite element analysis method. As the third is about the wave force coefficient. This is what I'm going to use it in many places. The wave force coefficient, I got it from this paper, horizontal submerged rectangular cylinders. Okay. So what I'm going to investigate is a PIP system consisting of 2 major pipelines. One acts as a flow line and another acts as a carrier line. The major problem in this system is to stability as well as the vibration of this, because of the presence of the 2 pipes that are different in dimensions, and the one inside the other, in which the wave turned to move the pipeline from its actual positioning. The vibration of the PIP system is controlled using the dampers, and by providing them between the 2 pipes, the stability of the PIP system is increased. But here what I'm going to study is, this study is basically divided into 2 parts. The first part only I'm going to present here, this is the linear part of it. And the stability of the system, I'm going to increase it by increasing the mass as well as the lining. So there is a concrete coating which is going to be given with a various thickness around the pipeline, and in the study of this, we are going to see in this also. So this is the objective as well as the scope, which I have already explained. So this is the diagram, basically the structural diagram. We are going to talk about the loads as well as the pipe, the cross section. You can see this is the submerged weight of the pipe is the WS. I hope you know that the difference between the actual weight as well as the submerged weight, and you have the lifting force is an FL and the contact force is the FC. And the bottom one is the subsea bed, and you have a soil resistance of FS. And the horizontal force, you can have the wave as well as the current, which is having the 2 part FD as well as the FM. And if you have any coating above which it is the concrete weight coating which has been given, and that has been given there. So this is the total loading case of it, based on which I'm going to explore, and I'm going to do the analysis using the finite element analysis software. ANSYS, I'm going to do it. Actually, this project is being done in the ANSYS by using the Python at the back end. So we will be integrating that ANSYS with the Python. And then we'll be mostly the coding, everything is being in the Python, and then it will be calling the answers, and then it will come back and get the results, so that later I can able to do all the optimization part of it using the Python itself, because it is having a free flexible tool, so that we could able to integrate any software to it easily. Right. So first one is the calculations of this load, how it has been done. So the soil spring calculations, the soil spring, this is basically taken from the literature. The lateral, there are 3 stiffness, because it is at the bed you have. So there you have lateral stiffness, vertical stiffness, as well as the axial stiffness, KL, KV as well as KE. Initially, you could see that the KL as well as the KA. KL as well as the KA will be the same. But the KL and KV will be the same immediate contacts and varies along the cross section. This is the one. This is just nothing but a spring. Right? You can assume that a cylindrical part of it, which is attached with the spring all around with the variable spring stiffness. The spring stiffness is varying. That spring is with respect to the axial distance as well as the angular distance with this. That spring stiffness has to be calculated because that is the one which has been attached at each and every node of it. And then because of that, the vibration frequencies are entirely different. Right? So that exactly we need to calculate the KL and KB. But Ka is the axial stiffness that is in the along the axial direction that remains the same. That is the assumptions what we are making. That is the same which is in the available in the literature review. There are 24 elements along this because this being a vibration analysis. Okay, we are not going to take the millions of it, but the vibrations analysis. The total cross section of it is being divided by into 24, and each quadrant you are having 6 elements. And along the length we have numbers of thousands of elements we are having it. So 6 for each quadrant, and each and every element is being attached with the spring of variable stiffness all along the 3 directions. So these are all the properties of the PIP systems. The material properties. We have the flow pipe, thermal insulation, centralizers, carrier pipe, as well as the concrete layer. These are the 5 components we have. For these 5 components, what are the material used, what is the density, Young's modulus, as well as the Poisson's ratio, what we are going to use it. I have tabled it. This is the common properties, most probably. And the PIP system, this is the dimensions, what we are making it. The outer diameter, basically, it has been taken from that first paper. That one, the same amount of the, usually it has been taken. The 320 is the outer diameter and the thermal insulation. Centralizer is at the distance of 500 mm and then the carrier pipe 540. And the inner diameter and thickness is given and length is given for each and every. And the concrete layer thickness, actually there is no layer for the concrete for increasing the mass only. Because to increase the mass, I can able to apply some thickness. This is a coating which I could able to give it at a 50 to 200 mm thickness. I can able to vary so that this 4 multiplied by this 6 times, I'm going to do that simulation of it. What is the element I'm going to use? Is in the answers is the shell 181 element, which is very well known for a shell element for the PIP, and solid 65 element for the concrete layer. And the cell 181 elements, I can able to model this into a number of layers. Basically, we will be using it for a single layer with the 4-noded quadrant. But what I did is we can able to give number of layers one over the other so that the added mass can able to directly put on the shell element itself, and then we can able to do the analysis on it. And these are all the load calculations, basic diagram. Just I'll go through quickly. The first one, MA, that is what most important one, where is the effective mass, because it is submerged one, where MP is the structural and physical mass provided by the outer pipe. And MA is the added mass. What is the mass I'm going to add into it? And MB is the buoyant mass. So where my ME will be nothing but MP plus MA minus MB. Right, and MA, the equations and all you have, but there is a coefficient here for that MA, the added mass is the CM. This is one of the most important parameter in this. And for the CM is basically defined based on the third paper. It is CM is varied depending upon the number of trials the people have done the experiment. This coefficient CM varies. It is the function of d by d, where d is the seabed depth from the pipeline to the d is the diameter of the pipe. It may be varying from infinite when the CM is equal to 1 and d by d is equal to 0 for the CM will be equal to 2.29. In between, you have the correlation between these two, and we can able to take that CM value and we can able to calculate that mass. And for this, these are all the calculations which have been given. How this each and every mass could be calculated, and this mass for that each and every distributed mass we could able to calculate it for each and every pipe, and these are the properties which I have to give it into that answers so that we can able to do the exact analysis, simulate that thing exactly. So the next one is the theoretical part of it. See, this is nothing but the TMD. The people who know about that dynamics, the TMD, the tuned mass damper. The same concept only here you have it. You have that First one is the main system. Second one is the TMD system where the mouse is being added. The diagrammatic is being given. How it is being correlated, the basic equations, the coupled equation. Right? There are two x's as well as the xt. How it has been coupled. For that, this is nothing but the mx double dot plus ex dot plus kx is equal to that forcing function, the inertial force function only. But it is given in that. But this can be optimized for my structural frequency as well as the structural dynamic. The calculations are not being shown, and that final optimized tuning frequency, what I could able to get it from this, we can able to see that an optimum stiffness value, what we can able to get it in terms of the mass, and this we could able to get it. These two are the one which we are going to input for that TMD system. And this is a model for which MT, MS, as well as the mu, comma, optimum, what is the value which I have calculated, and for which I am going to give that as an input. Right. Okay, so based on that, the analysis steps and all, I'm just skipping it because it is a lengthy process. We are going to do it in the answers. 181 shell element, I'm going to take it, I'm going to connect it to the abacus, and then I'll be giving all this input. And what is that effect? First one, we will study that effect of it. First one is the CM. As I told you that MA is the force. It is basically depends on their CM value. CM value is depends on the depth of the pipe, which we don't know. But in the same bed, the bottom, how much depth we have it, we don't know. So that the effect of the CM is being given. We can able to see that the frequency first to 3 and 4th mode of the frequency, that depends on the CM value that is being given. I have taken the CM value 3, 1, 1.13 and 2.29. And for which how the natural frequencies are being varying, we could able to see, and how much the number with respect to the theoretical value we have derived, and we could able to have that percentage of the error is almost 1 to 2% almost the same. Next. And this is for each and every mode. How does it vary? First one, I have shown it for the first mode frequency. This is up to the 6th mode, and how does it run? I'll just go to that. This is for the displacement as well as the stress response for that, and how the mode displacement as well as the stress responses are varying for each and every CM value. So this is about the CM. Second one is the effective position of the damper. The damper can be positioned at any X direction or Y direction or on the both X and Y direction. So if I put it in that, you could be able to see the displacement of the mode shapes for that damper X as well as XY. We can see that the displacement is drastically reducing. And there is a very small difference between that XX, XY as well as the XY direction damper positioning. And this is the mode with respect to the damper positioning, and just showing for all. And the last one. This is the effect of concrete layer thickness. As I told you, I'm going to provide the concrete layer from 50 to 200 mm and varying with respect to every 25 mm thickness.
You've already exceeded 15 minutes.
We could able to complete it. And behavior of the optimized PIP system. This is what the last optimized value from all the three. I'm going to put it here, and then the concrete layer thickness, frequency versus the displacement analysis is being done, and the maximum value is being shown. And the validation is also being done, and then the error percentage is almost 2% only we have for it. The conclusions and all, we have shown the same, whatever I have shown it in that graph only. For the different CM values, how does it vary? And the maximum CM value is for 2.19, we have the maximum. As well as for the 1, how does it, the frequency, I'm getting it as the less only, which has been explained here. As well as for the concrete layer thickness of 75 mm, I'm getting that frequency as the maximum. And optimized for the XX as well as XY direction dampers. With the concrete layer of 75, the frequency is being reduced. And the stability part of it is still yet to be done because it's a small work one only. That nonlinear part as well as the stability needs to be done to the next part.
So any questions from the audience?
Yeah, hello, sir. I'm Sharath Raj. So there is, I think there is one FSI part is there, right? That a fluid structure interaction. How that is done? And the second question, What about the dimension you chosen? And the third question, that machine dependence and everything. So I am not more keen about to know about FSI. So fluid structure interaction, how that is done using ANSYS. Okay.
So this analysis is not being done using the FSI first. The reason is being that the pipe is at the bottom of it and the dimension of the pipe with respect to the water which is above it. FSI is basically the fluid and structural interaction. The effect of the structure is being transformed to the fluid and the fluid's transaction is being given back to that structure and then it is being iterated for a long and then the final deformed shape is being done. But the effect of this is water column is when compared to the diameter of the pipe, right? So it is very high when compared to because the diameter of the pipe will be in meters and the height of this will be very high, that you can be able to see that. So that inertial force, right, sir, that which is making the damping, which is more than that deformations which are caused, because it's a vibration analysis. In the vibration, because I'm not going to static analysis, it's the vibration analysis only. So whatever I did is the vibration analysis, the fluid structure interaction effect is very small when that another parameter, the water column, is very high when compared to the diameter of the pipe. That is the first one. The second one is about the meshing. Meshing, first we have done the size of the meshing we have taken and the correct exact number of meshing. How did we do it? We have reduced the meshing and we got the frequency. And then we have done the asymptotic analysis. I hope you know that exact value will be reaching at the asymptote value. And from that asymptotic, 95% and more, whatever be the value we are getting it, that meshing is more than sufficient for us to do that one. That is one. From that only we have taken the number of elements as well as the meshing size. So third one. Oh, that's
Sir, Muthukumar sir.
Yes. Thank you for a nice presentation. And it's very interesting work. And because now this is one of the important transportation of crude oils and very interesting work. Thank you for presentation. Next, shall we ask the next speaker to talk, give the lecture? Yeah. Now I invite Dr. T. Ramesh from PIG College of Technology. The topic of the session is that one lecture is development of durable geopolymer power block for coastal application using quarry dust as fine aggressive substrate. Yeah. Please start the presentation.
Good afternoon, present here. I thank the Department of Shipping Technology for providing me this opportunity. My presentation topic is development of durable geopolymer paver blocks for coastal applications using quarry dust as fine aggregate substitute. See, we have to know that quarry dust is a byproduct obtained by the sand manufacturers, and this is nothing but by the process of breaking the stones blocks. So in that, very significant thing is the amount of byproduct produced during the manufacturing of sand is equally as that of the volume produced by the sand. If you have, for example, if you produce 50 m³ of coarse aggregate, you will have the minimum 25 m³ of slurry dust. The biggest problem is disposal of this slurry dust. I can also challenge any of the manufacturing suppliers of sand will not provide you the sand in dry state. The reason being they use or mix this waste byproduct into the sand. So the sand only when it is in a wet state, the quarry dust powder, which is only in wet state, it will be stable. If it is in dry state, it's like a flyer. It cannot be stable there. So they adulterant this sand quarry dust into the sand and produce it. So you can see any concretes what we are producing nowadays are subject to more cracking. shrinkage cracking, thermal cracking, all are because of this adulterant mixed into it. They also don't want to mix it, but the problem is disposal problem. In the yard, they cannot keep it for a long period of time. So it is also causing air pollution. So they try to mix it with the original product and bring down the value of the MSAT. This is one of the problem in the industry. See, next problem. The concrete. The concrete is the second consumed material in the world. So if you see this concrete is as well as it is consumed, it is also being a threat to the atmosphere. It is the major pollution of the CO2 emission. So here the CO2 emission has to be reduced. So what we are thinking, we have to produce to cement concrete without cement. So the alternative for a sustainable concrete structure is a geopolymer. So in geopolymer concrete, we don't use cement, with a concrete being produced without cement. So the geopolymer constituents, it includes the alkali contents, activators, aggregates, phases. So this is the roadmap of our project. In this project, we are classifying the dusts, and the dusts which are classified is categorized based on the source from where we are receiving the quarry dust, and they are subject to the concrete productions, and we do the workability, mechanical properties test, durability, and explore what is the embedded energy for consuming it. And also we prepare the life cycle analysis for that. But for a want of the results which has to be presented to my project work, which is standard project work. So we restricted only for the mechanical behavior, to for the category of application of paver blocks. So in this conference, my area of presentation will be only restricted to the mechanical properties of the geopolymer with respect to paver block applications. So there are applications of concrete is in the structural, non-structural applications. I have taken for this conference only non-structural applications. So what is the optimal quantity of the replacement of the geopolymer with quarry dust? So this is the methodology: the collection of raw materials, material testings, characterization of quarry dusting, as FTR, mixed design, casting of specimens, curing specimens under ambient temperature. This conducted as per IS 568 2021 for paver blocks, the microstructure analysis, then results and discussion. So we conducted first the microstructure analysis for the various sources of the quarry dust obtained. From this microstructure analysis, we can get 3 element formations of the microstructures. We conducted XRD pattern. In this XRD pattern, we are able to the mineral formations of the crystal system of monoclinic and anorthic. So this crystal structure will increase the chemical reactivity of these compounds. So the chemical reactivity is once enhanced, the surface reactivity is, specific surface area is important for our chemical reactivity. The specific surface area is, once you take a cube of size A is, you calculate the volume is same, but the surface area is 6A. If you divide the same cube into several equal halves, means, so for example, 2 equal halves, the surface area is increasing, volume remains same. So in that case, if you have a crystal structure more aligned to have high specific surface area, the chemical reactivity will be high. So thereby, we also confound with the FT analysis, the chemical formed, and it is stable. So why we done this test means the stability of the mix is important. The concrete mix, what we are getting, it has to be stable. If it is unstable for a long period of time, then I cannot produce in the paver blocks or any applications. It's not good. So the dimensional stability is important. For getting that dimensional stability, the bonds and the crystal structures are important. So with respect to these geopolymer paver blocks, we need low slumps. So the slumps with the 10% replacement has got OD of 25 mm slump. So if you have higher slump, the material will be not stable. So dimensional stability is important as far as concerned with the paver block application. So we have selected concrete with the replacement of corridors by 10% with slump value of 25 mm. These are material mixed proportions. We replace element from the control specimens. The shape of the specimen selected is Oxford shape of high group paver blocks. Method of castings, mixing of GPC, placing in molds, stacking up of molds, demolding, curing under ambient temperature. The test that is conducted as per IS 15658 is dimensional check. The dimensional check, we place the 6 paver blocks in along the length direction and vertical as well as horizontal direction and measure along with what is the measurement. It should not be greater than plus or minus 3 mm, and that gives the dimensional stability. And also the aspect ratio should not be more than 4. We measured the aspect ratio less than 3. So water absorption test, we find that 20% is less, 10% is lesser. We don't know what's we couldn't identify what's reason, but various other strength parameters were high. So we see that there will be some particle packing effect in the 10% corridors, which has led to the lower water absorption. Whereas the strength results the compression test carried on the geopolymer paver blocks for 7th day and 8th days. It also showed the 20% replacement was high. 28th day compressive strength. The split tensile strength. So the ability of the concrete to resist against the tensile force, we conduct split tensile strength. The experimental setup includes the 2 bars laid on top of the center of the paver block, and we apply compression load. The applied compression load is getting into a dispersion into tensile pull into the concrete. So you get the tensile resistance by equation using this equation. The 7-day split strength and the 28-day split strength are higher for 20% replacement. Similarly, the flexor test on geopolymer paver blocks. Flexor strength is the resistance against bending. So we conducted a 2-point loading system. Single point loading system. In single point system, we calculated the flexor strength. The flexor strength was high for the 20% replacement, both at the 7th day as well as at the 28th day. So in microstructural analysis, we can see that in geopolymer paver blocks and without any quarry dust, there were void structural formations, dense structures, dense areas, various. When we add this quarry dust, next slide. So when you increase, the density of the structure is increasing. So by the addition of this quarry dust into the geopolymer blocks, the densification of the concrete structure is happening. So that is the responsible for increase in the bond strength. And we also conduct the FTR test. In FTR test results, so there is a formation of the covalent bonds in the structures what we obtain. So thereby the dimensional bonding is also high in the case of the replacement of quarry dust with 20%. My references.
Thank you, Dr. Ramesh. And now it is open for discussion.
So regarding the durability of the concrete, have you done any tests?
Sir, durability of concrete, we have done chloride conductivity index test, sir, and chloride conductivity test and oxygen permeability index test. So chloride conductivity test is to study the concrete's ability to resist the transfer of the chloride ions. So chloride ion is one of the aggressive chemical in the coastal region. So if you are able to produce a concrete which will be resisting the chloride penetration for more period of time or higher, then the concrete could be highly durable. Another one is the oxygen permeability index. For a corrosion to occur means there is a need of two things. One is the anodic process, cathodic process. So the presence of oxygen is responsible for the cathodic process to occur. So if you make a concurrent denser, thereby the oxygen penetration, diffused oxygen penetration will be less. So the presence of the cathodic process to occur can be retarded. So thereby the corrosion resistance can be enhanced. So we have done to that. In addition to that, we also conducted the electrochemical tests for these concretes, but the results are being not yet present here.
Just the usage of your terminology, the geopolymer. Are you calling it geopolymer because you are adding the quarry dust to the standard the concrete?
Concrete contains constituents like an activator to be added. Actually, the sodium hydroxide, sodium silicate alkali activators will be added. So these alkali activators will be responsible for the chemical reactions in addition to the compounds present in the fly ash, quarry dust, the black crystal structure.
Okay, so you are adding fly ash and everything along with the quarry dust. Okay.
And fly ash is one. I said
Aggregate. Okay.
like that.
So you talked about 20% replacement. What do you replace? You replace cement or you replace aggregate or sand? Aggregate. Oh, no cement at all. Okay, so the polymer is doing the purpose. Okay. Okay. Thank you.
Thank you.
Thank you, Dr. Ramesh. Next topic is corrosion studies of 5083 aluminum alloy and 6082 repair weld joints. And Dr. Tajuddin, Mr. Tajuddin will be presenting. Yeah. You can start the presentation.
Yeah, good evening. My topic of presentation is corrosion studies of 5083 and 6082 aluminum alloy repair welded joint. Myself, Tajuddin. I am research scholar, Department of Ship Technology. My co-authors are Dr. Sadish Babu sir and Dr. Madhiragan sir. These are the contents of my presentation. In the metal industry, the volume of repair and maintenance is far more than that of manufacturing. When any type of defects are occurred in the vicinity of the weldment, that has to be removed and to extend the service life of that component. Repair welding is one of the important maintenance and repair process. This method exposes the rest of that area to extra additional thermal cycles that will be responsible for microstructural changes. And due to this microstructural changes, the property of the material will also be changed. So in the shipbuilding industry, the repair welding process is used extensively to improve the service life of the component. Aluminum and its alloys are recognized as most useful materials for offshore and marine constructions. Aluminum alloys are one of the lightest and they are easy to extrude and fabricate. They have more important properties like high strength, excellent corrosion resistance, high strength to weight ratio, lightweight, and high thermal conductivity, etc. Among the aluminum alloys, 5000 and 6000 series are extensively used in marine industries. And coming to 5000 series, it is heat treatable alloys. And magnesium is the main alloying element. And they have high strength and toughness, excellent corrosion resistance, good weldability and durability. And they have typical ultimate tensile strength of 317 megapascal and yield strength of 288 megapascal. The most commonly used alloys in shipbuilding are among these 5000 series, it is 5083. They are easy to formable and used in weight sensitive vessels for hulls, hull stiffness, decks, and superstructures. Other aluminum alloys for marine applications in 5000 series are 5086, 5454, and 5456. Then coming to 6000 series, 6000 series is heat treatable alloys and have magnesium and silicon as the main alloying elements. They have excellent corrosion resistance, good extrudability, then moderate strength, good weldability, etc. They have ultimate tensile strength of 310 megapascal and yield strength of 276 megapascal. They are used in the application of deck panels, railings, walkways, stairways, and marine frames within the ship structure. So these materials are used in shipbuilding industries. Coming to the repair welding operations, repair welding is the process of removing the any defective part in the weldment and redepositing that part to same with the using the same welding parameters. This method usually comprises of due to this method there will be some additional heat cycles, and due to these heat cycles there will be microstructural changes. This figure shows the schematic diagram of a welded joint. Here, suppose if there is any defect present in the second pass, that region has to be removed. And for removing that region, the first two passes has to be removed and redepositing that area. That is repair welding process. This study aims to investigate the repair welding of welded joints of 5083 and 6082 by analyzing the corrosion properties. Here the repair welding on aluminum alloy plates has been performed, and the corrosion behavior of the repair welded aluminum alloy plates has been investigated. These are the methodology. I have selected the material like 5083 and 6082. MIG welding technique is selected. MIG welding process is selected with this weld process specification, and filler material is 5356 with the diameter 1.2 mm. And these are the composition of 5083 and 6082 alloys. This is the composition of 5356 filler wire. These are the plates of 5083 and 6082. This is after the edge preparation, and this is the figure after the MIG welding process. And this sample is termed as welded sample. And if I remove the first two passes and then redeposit on reweld on that area, then it is termed as first repaired sample. And if I do the same process on the first repaired sample, it is termed as second repaired, and similarly third repaired samples. And okay, the samples from the well bead, and well bead means from the top pass and from the root pass, and the heat affected zone in the 5083 side and from the 6082 type side has been prepared by using wire cut method, and the corrosion testing has been carried out. These are the samples prepared for corrosion testing. Here for corrosion testing, electrochemical impedance spectroscopic technique is used. ES is a non-destructive sensitive testing used to evaluate corrosion behavior by measuring the impedance of material electrolyte interface over a range of frequencies. Here the experimental setup consists of an reference electrode, a counter electrode, and a workpiece serving as the working electrode, all immersed in an electrolyte. The test is conducted using a potential stat coupled with a frequency response analyzer. And here silver chloride is used as reference electrode, platinum as counter electrode, and sample acted as working electrode. The specimen immersed in suitable electrolytes such as 3.5% of NaCl, sodium chloride solution, for simulating the seawater. Then resulting data is presented in body plots and Tuffle curve, which provide the insights into corrosion mechanisms, and the corrosion rate can also be determined. Coming to the results of my corrosion testing, this is the Tuffle plot for the base metal. From the Tuffle plot, we get the corrosion rates. Tuffle plots for 5083 and 6082. From that corrosion testing, I got the corrosion rate as for 5083 as 0.1636 mils per year, and for 6082 it is 0.2037 mils per year. And from the well bead in the top pass, this is the Tuffle plot for asphalt specimen of the well bead top pass of the for sample 1 and 2. This is the first repaired sample for 1 and 2, and this is Tuffle plot for repair weld 2 samples for the top pass, well bead top pass, and similarly this is the Tuffle plot for repair weld 3 samples. And the results are obtained here like this. Here we can see that all the results are almost similar. That is 0.3 to 2.35 range. Okay, this is because this is the comparison. This is the average value of that two samples. This is the comparison plot, and this is because the same material is redeposited again and again on each repair. That's why there is no significant difference in corrosion rate here. But coming to the root pass, this is the asphalt specimen for sample 1 and 2. This is the tuffle plot for repair world 1 specimen. This is the tuffle plot for repair world 2, and similarly this is a tuffle plot for repair world 3 specimen. And after this corrosion testing, I got the result like this, and we can see that the corrosion rate here is increasing gradually by each repair. On each repair, the corrosion rate is increasing gradually, because this is because on each repair, the root pass is experiencing extra thermal cycles. And this is the comparison rate. And coming to the heat affected zone of 5083, this is the tuffle plot for asphalt specimen, repair world 1 specimen, 2 and 3 for heat affected zone of 5083 side. And here also we can see that the corrosion rate is increasing, that is 0.26 to 0.41. We can see that the corrosion rate is increasing here also. This is the comparison rate. So we can see that the corrosion rate is increasing. And in the 6082 side, that is heat affected zones of 6082 side, this is the tuffle plot for asphalt specimen, repair world 1, 2 and 3. Here also we can see that the corrosion rate is here also the corrosion rate is increasing. From all these experiments, I can come to a conclusion that the well-bead region exhibited higher corrosion rates compared to the heat affected zone and the base metal, indicating that the weld metal remains the most electrochemically active zone in the welded assembly. And the corrosion rate in the top pass of the well bead remains constant, almost constant. Value is almost constant on all across all the repair cycles. This is because I told you earlier that the same material is redeposited again and again on that area. That's why there is no significant difference. And in the root pass and in the heat affected zones, there will be the corrosion rate is increasing here. Okay, increasing by on each repair. Multiple repair cycle lead to progressive degradation in corrosion performance, especially in heat affected zone and the root pass. Therefore, minimizing the number of repair operations and optimizing the heat input during the repair welding are essential for ensuring long-term durability and service performance of aluminum alloy structures used in marine environments. These are the references. Thank you.
Thank you for presentation. And I have one doubt. You mentioned that 5 series aluminum alloy is heat treatable. But 5 series is not heat treatable.
It is not heat treatable, non-heat treatable.
Non-heat treatable. Okay.
Yes,
Okay,
yes,
fine. So what is the filler you used to weld the 5 series and 6 series?
5356.
So
5356 filler wire. Electrode ER 5356 with a diameter 1.2 mm.
okay, you also done the mechanical property study. You have studied the mechanical properties also.
Yeah, I have selected that material by using a chart, a standard.
Okay, fine. But you also studied the mechanical properties, strength aspects. Am I right? Strength, you studied the tensile properties or not?
Tensile properties, no, sir. That chemical composition.
No, but anyhow, if the corrosion study is your focus, but you also should do the mechanical properties, tensile property, hardness distribution, because strength should be good. Then only you can see the corrosion. Okay. So basic study. Any weld you do hardness distribution, you do the macro structure, you do the microstructure, and you do the tensile property. And if need, bend test. These are all the basic tests you should do before conducting, before going for other properties like corrosion. Okay, that is point number 1. Second point is, did you do any post-weld heat treatment? Any post-weld heat treatment you made?
Sir, MIG welding technique is used here, sir.
No, post-weld heat treatment. After welding, did you do any heat treatment?
No,
Or
no,
gas
no.
ventilation?
No, I didn't do any possible.
Okay, think about that. Okay, think about that, and if need, you should do post-welding treatment after the welding, and that will change the properties. So that also you should take into account. And in the presentation mentioned AA 5083 aluminum alloy. I see many places I saw that AA 5053 alloy. So AA is aluminum alloy. So while using terminology, you should be very careful. So that's all from my side, and congratulations for good work and having good potential, and yeah, all the best.
Thank you, sir.
Question from audience?
Is there any international standard for measuring corrosion rate?
Sir, there are so many methods for measuring corrosion
No, is
rate.
there a standard? Okay. Now you mentioned corrosion rates and you gave 4 significant digits in your answer.
Yes, sir.
Is that reasonable? And do you have an estimate of the error? Suppose I measure the length of a pencil and I tell you it is 10.0053 and I'm using my geometry box scale. It doesn't make sense. So do you have an estimate of the error in your corrosion rate? If that error is going to be large, we cannot find out which among this has got the lowest corrosion rate. So we need an error estimate.
Sir, it is expressed in mils per year. 1 mils per year means that is 0.001.
But why so many significant digits? Is that justified?
No, sir.
And what is the least count for your measurement? Okay. Thank you.
Thank you.
Yeah, thank you.
So yeah, thank you. And the next speaker is Charles Paul, Mr. Charles Paul, and the topic is selection of cutting machines and method of arriving shrinkage allowance in hull block fabrication. Yeah, the speaker, Mr. Charles Paul, is here. Mr. Charles Paul. Yeah. Yeah, please go ahead.
Good afternoon. The topic for is the topic for my presentation is selection of cutting machine and method of arriving shrinkage allowance in ship hull block fabrication. I am Charles Paul KJ and my co-author is Dr. Sadish Bowser. The contents are the introduction, the factors affecting the accuracy in the block construction, objective, methodology used for analysis, results and conclusion, and references. So this is the top left side is a block division of a bulk carrier built in Cochin shipyard, and the right figure is a exploded viewership. So you can see a lot of blocks like side shell blocks, double bottom blocks, accommodation blocks, etc. So here the challenge is accuracy related to hull block is challenge faced by many yards, especially with thin plates. Even with the best process control and best equipment, almost all yards are struggling to attain the required standards of construction, resulting in rework, increased labor, etc. And many yards are continuously working for innovative solutions to find out how they can improve the accuracy. See, this is a block erection progressing in Cochin shipyard. You can the top left side is a construction progressing in Cochin shipyard, and the right side is a bird's eye view of a erected blocks in a dock. From the top, it's look very fine. But if you look the 3D analysis of the block, you can see the variations. You can see the variations. Okay, you can see the variations. So this is a challenge faced by almost all yards. So let's see what are the different factors affecting the block accuracy. So the first one is the design related issues such as improper shrinkage, improper temporary stiffenings provided in the blocks, equipment use. And my area of interest is errors in cutting machine and how to mitigate this error. This is all my paper is all about how to mitigate the errors in cutting machines and how to improve the accuracy in the block construction. And another factors affecting are process related and environmental factors and handling of the blocks. These are some of the errors encountered in the construction. You can see the gap which is being generated in between two blocks. So in the bulkhead there is no gap, but you can see in the deck there is gaps are there. So if the gaps are there, we can see the rectification method. So if the gap is more than 1.5 times the T, we need to go for a paneling. If it is less than 1 T, we have to do a buttering and then do the rectification process. So these are all increasing the time of construction. Now the next one is a misalignment in the longitudinal. So you can see some misalignments are there. So there also a rectification methods has to be followed as per the act. So if the difference between the two longitudinal is we need to release to a length of 50 times and then we have to rectify this. So all these are increasing the time of construction. So you can see another two defects. One is the undulations in the deck. These are the undulations in the deck after the construction. And these are the misalignments in the block. Now you can see a classical example. Here the block is having what you call the deformation along with the shortages in the blocks. So these are the shortages encountered while fabrication, and these are the errors or the deformations occurred while during the fabrication. Now, the objective of the process is to process control methods to evaluate the accuracy of the plates cut from the plasma is the objective. What is about the CSL is using a two plasma cutting machines. So the study is being conducted on these two plasma machines. An analysis is being carried out to find out the accuracies of these machines and thereby formulate a system to enhance the block fabrication accuracy. So the methodology used for analysis are X bar and R chart, process sigma, normal distribution curve, and ANOVA studies. And this is the X bar chart of a plasma machine. So you can see the X bar chart consists of 5 things. There will be a center line. X bar line is there. There is a upper control limit and lower control limits are there. Then there is a lower specification limits and upper specification limits are there. Lower specification limits and upper specification limits are about the engineering standards. If it is beyond the lower and above then it is not meeting the engineering standard. And if it is within the control limits, then the equipment is as per the process control, is within the process control. So generally X bar and X bar chart will come with a R chart also. That is R chart is nothing but the range chart. So X bar charts are drawn using the statistical table with the values, and we can see that in this chart almost 4 points are beyond the lower specification limit. That is, it is not meeting the specification as been mentioned. Then what we have to do is that if it is beyond the specification limit, we have to revise the center line so that everything has fall within the upper control limit and lower control limit. Then these activities are being done in both plasma machines. So you can see in plasma machine 2, there is only one is going out, and one is going on, and almost all others are within the limits. So this is the revised control chart for plasma machines. So based on this, a process sigma of the machines are being calculated. X-axis nothing, deviation in mm per meter. X-axis, this one. No. X-axis is number of the points. Y-axis is the deviation in mm per meter. Mm per meter. This is visual, sir. It is mm per meter, sir. Per meter. This is here it is 1 mm, 1 mm per meter. 1 mm per meter, sir. 1 mm. Yeah, that one digit is 0.5 mm per meter here. So similarly, revised plasma, revised chart has been drawn for plasma machine 2 also. So based on this, the process sigma has been calculated. So the process sigma for plasma 1 is only 2.54 and the plasma machine 2 is only is 3.36. And the plasma machine is generating a scrap of 1,48,000 in a ppm, and plasma 2 is generating a scrap of only 31,250. So this is the normal distribution curve. So from the normal distribution, you can see that the spread rate of plasma 1 is very high compared to the plasma 2. So that if the spread rate is lower, that means if the spread rate if the spread is lower, that means more accurate. And if the spread is higher, then the process is less accurate. And another study which is conducted is ANOVA study on plasma machine 2. So in plasma machine 2, plasma machine 1, there are 2 nozzles are being used. That is for 400 amps nozzle and a 200 amp nozzle. So here you can see within the samples, there is no variation. That is in between breadth and diagonals, within the samples, deviation is less because p-value is less than 0.05 and F statistics is less than F critical. So it is variance are less within the group, but if it is between the columns, it is less than 0.05. So it is not within the statistical limits. And the interactions also, you can see it is more than the 0.05. So nozzle 400 and nozzle 200 there is no much statistical differences there. If you take the case of plasma 2, everything is within the statistical limit. So the results is, these are the results. Plasma machine 2 is having higher accuracy. So the results are cut the critical part like block, deck, shell, etc. in plasma number 2, and less critical part like brackets, etc. in plasma number 1.
Thank you for the presentation. And it's here you discussed. I have one question. But machine to machine, this may vary, and the gas flow rate, the parameter also controls this. It's very, very challenging, and I hope you consider those aspects also in your study.
Sir, actually, these are all similar machines. Plasma machines are both of CNC make. Only thing is that only variation is happening on the nozzle. One machine's nozzle is having higher capacity, and another one is having lesser capacity nozzle.
Okay, so gas flow rate also will change. Gas flow rate, everything will get changed. And yeah, so yeah, this is very interesting. But I request you to look into some advanced methods, because this is a commonly used method. You can think about machine learning as because PhD means some the advancement is expected. So you can also think about machine learning as an excellent tool to use in this type of area, because already many such applications they successfully implemented machine learning technique. Think about that, and thank you, Mr. Charles, for presentation. And yeah, any question from the audience? Any question from audience?
Actually, your statement of the problem is that you have difficulty in assembling blocks.
Yeah, correct.
Between cutting of plates and assembling of blocks, there are so many operations which could have a much more serious effect on assembly of blocks. Okay, so you are doing a fundamental study. So we will focus only on the fundamental study. Okay. Now, we are talking about millimeters per meter, and we are talking about 0.36 versus 0.25. How many samples have you measured in to come?
27, sir. 27.
Whether that is enough, what will be the error in my or uncertainty in my value? That may be high. So this it may be it's 0.36 plus minus 0.2. I'm just telling you a number. It may be 0.25 plus minus 0.2. In which case I cannot distinguish about between which is better. So I think we need to be more careful about this because you will tell some result and based on that they may change the nozzle or do something which is both expensive, maybe unwarranted. So you have to be very careful about your conclusions.
So conclusions are we are not changing the nozzle. Only thing is that critical part like cell and hub that should be cut in plasma machine too. And another critical uncritical activities like brackets etc. can be cut in plasma number 1.
Okay. Yeah. Yeah. But even that, unless your results are correct, I won't take any action based on your results. So you have to give convincing proof that your results and analysis are correct. And you have got so many significant digits. So immediately I look at everything with caution. Okay.
Conclude. Thank you. Thank you, Charles. We'll conclude today's this session.
So, one and all, thank you today. This session, 5 papers were presented and yeah, diversified field. So, I congratulate all the authors for giving a wonderful presentation and the feedbacks are valuable. I request the authors to note down the feedback and incorporate the changes. Thank you, one and all. Should I brief about each paper? Should I brief about each paper? No need, no?
No need, no need.
No need. Okay. I once again I thank the organizer and Professor Madhyagan for giving me this opportunity. And I wish all the best. Thank you. Thank you, and all.
Thank you.
Thank you.
Thank you.
Shall I leave the meeting? Yeah.
Yes, sir. Yes, sir.
Thank you.
Thank you. We will give the certificates. Deepak sir is not here. Yeah, I invite the assistant teacher to give the certificates. Dr. G. Venkatraman, please come. So, sir's topic was a numerical study on effect of inertial force on subsea pipe in pipeline. Thank you. Next, Dr. T. Ramesh from PhD College. Topic: development of durable geopolymer pave blocks for coastal applications using quarry dust as fine aggregate substitute. Next, Tajuddin, PhD scholar of our department, Ship Technology. Corrosion studies of 5083 and 6082 aluminum alloy repair welding joint. And yeah, thank you. And last is Charles Paul, research called Ship Technology. Selection of cutting machines and method of arriving shrinkage elements in hull block fabrication. We have a working tea. Those who are yet to take tea, please take it outside. We don't have a tea break right now. We are lacking by 45 minutes delay. So we'll start the next session immediately. Now the next session or the last session is about AI and digitalization. And there are only 2 papers. 3 papers. After that, we'll have validatory function, best paper award. So those who are The last session for our conference is AI and digitalization. We have 3 speakers. So I invite Hasina teacher to chair the session.
Good evening, all. Let's start the session with the first paper presented by Anilekha Thambi.
Good afternoon. Uh, Good afternoon to all. Today I am here to present the top. Sorry. Good afternoon to all. Today I am here to present a paper on the topic Weather Resilient AI Technique for Maritime Object Detection and Safety. So basically, we know that maritime safety relies on environmental awareness by collision avoidance, vessel detection, identification, environmental monitoring. So why there is a need for robust monitoring of the system? Why? Because one is safety imperative, that is with inadequate inability to detect the object or false alarm can make the maritime more crucial by creating accidents. Next is technological gap. That is with the existing system, only detect objects in clear weather, not in adverse weathers conditions. So their research purpose is to develop a weather-aware object detection framework, leveraging the AI technology and formal verification for enhancing detection stability in real-world scenario. So here my aim for the proposed system is to improve the accuracy by 10 to 12% over the existing system, especially in adverse weather condition. So just quickly, we can understand what is AIS is then nothing but automatic identification system, which is considered to be the existing system for object detection, is nothing but a transponder which is used for transmitting and receiving vessel information from ship to ship and ship to shore. So the main primary function is real-time vessel tracking, identification, collision avoidance and risk management, maritime traffic management, and search and rescue operation. So the main limitation for AIS is non-corporate target detection. So AIS fails to detect small object, buoys, floating debris, or a vessel without transponders, which is a critical gap in maritime awareness. Then signal vulnerability, loss of signal, corruption, data spoofing can lead to a crucial situation for navigational safety. Accuracy in congested water. The existing system fails to detect object in adverse weather condition with a drop of accuracy from 10 to 17%. And human error, like for a poor lookout procedure can increases the marine accidents. So from this, the gap is like AIS alone cannot ensure maritime safety. Now moving to the recent trend or recent technology, that is AI. So we have deep learning in marine environment as an alternative for tracking vessels. Here also there is research gap. One is weather adaptability. Like the existing model is with respect to clear weather, but the same data set if we are using for an adverse weather condition, the performance is dropped from 10 to 22%. Again, formal verification. Normally the testing which is done is static testing. So it is not reliable that the model will produce whatever the model predict is accurate. Environmental factors affecting the adverse weather is one, severe weather impact. The object become low contrast, invisible in adverse weather condition, making the detection difficult. Next is data scarcity and bias. In public maritime data set which is available are with respect to clear weather conditions or with respect to harbors. So we lack data set with respect to adverse weather condition. Then even though next is small object detail, that is with bad weather, we are visibility of the object reduces, resulting in capturing a target with weather noise. Next. Okay, this table shows the accuracy degradation. So YOLO variant and another model, that is detection term transformer, is the model which could show as an example where the accuracy rate is under clear weather it is 80 to 85% and say 86%. When the same data set is used for under adverse weather condition, the percentage drops down to 10 to 17%. For example, I could say the first image is the original image where you can see a multiple objects detected. It will be the data set used for training it. So when I give my the remaining images are different adverse weather states. So under rainy season, under rainy weather, here you see there is some object detected which is unable to capture here. So this is the accuracy it is impacted. And the table shows the existing method versus proposed approach. So when we see the table, the overall we could analyze the accuracy with the existing system. Each model is very good at on an average we can have 70 to 80% under clear weather, but the performance is decreased when it is in adverse weather. So the proposed approach is overcome the limitations and gap, proposing for an accuracy of 90%, 90 or more than 90 in clear weather, as well as 80% in adverse weather condition. So this is the proposed framework where we have a detection module using YOLO for feature extraction. Then we have a synthetic data augmentation for creating a real world data set with respect to the weather effects such as rain, fog, haze. Then in my proposal, I have introduced unsupervised learning for trajectory path prediction and clustering so that it will be helpful for dynamic operations for maritime safety. Next is formal verification. Formal verification is nothing but the reliability, to analyze the reliability. For here, the one method of formal verification is abstraction, refinement, and reachability analysis to analyze the whether model is giving the correct output, predicting the correct output. Next is collision avoidance integration. A detected object is integrated into a real-time collision avoidance module to facilitate timely navigational choices and reduces threats in the adverse weather. So my research goal is to enhance the existing system with a YOLO model with a deep learning technology along with verification and validation of AIS. Next slide. So this is the proposed performance metrics with respect to existing system. So when we have with respect to the existing system, my proposed approach or my proposed system is aiming for a better improvement In terms of accuracy, it is 10 to 12%. And for clear weather, and in adverse weather for 8 to 10%. Now, next is conclusion. So the conclusion is, with the proposed weather sensitive object detection, the limitations of AI-based system is overcome. Technology integration with the YOLO 11, unsupervised learning, formal verification, the accuracy and predictability of the system is increased, so that are increased under poor weather conditions. Then the gap between the cooperative AIS and a visual data detection are successful, so creating an unified maritime awareness framework. So the key outcome, I could say, is developing a solution for dynamic, safer navigation and monitoring across global variable water. From the point of operational impact, with this proposed system, we are having, like, the proposed system, there is an enhanced safety mechanism which reduces the collision risk, making then autonomous navigation, enabling reliable autonomous vessel operation in adverse weather condition, search and rescue improving, which improves the detection of distressed vessels and floating debris in poor visibility, and regulation compliance. Formally verified system meets the critical safety maritime standards and guidance. References.
The floor is open for questions.
Hi, my name is Dilip Prabhu. I'm the head of external affairs at Indian Register of Shipping. Just now I was seeing through your presentation. Can you take the slide number 6, please? 6. Sorry. So you have said maritime factor in maritime accidents. What is the difference between maritime accidents and marine accidents?
There is no difference, both are same.
Thank you.
Both are same. Yes. Impact variance.
Your slide before your conclusions. He has been to sea multiple times, lived at sea. I've been to sea many times. And I've seen AIS systems in operation.
Okay.
Your last but one slide. Before conclusions, you had one slide with some numbers, statistics before this.
Yeah.
This one. So it's hard for me to believe your numbers in the first column.
Improvement.
It's hard for me to believe number in your first column. Yeah, second column. The numbers.
Okay.
Existing AIS based system. Detection accuracy.
Yeah, it's an integrated AIS system. Like initially we were having an AIS system alone.
Okay.
Later what happened? There is integrated AI system with radars, with EOIR, with other fusion of with sensors and all. Like existing system includes both AIS and AIS integrated systems. So with respect to that only, the numbers is being taken from the reference.
So you don't have anything for AIS alone?
No, alone I don't have.
I'm guessing that's 99 or 100%. Yeah. Huh? No?
99 and 100% is
Yeah,
not.
I go to sea in a ship. I look around. Every object I look around is showing up on my AI screen also. Okay, that's a limited sample. Agreed.
Okay.
But I've been to sea and I've seen this. So when you say 70%, what are we saying that I can find only 70% of the AIS equipped vessels which are around me?
Yes.
Within what range?
40 knots.
Over the top over the
Over the sea.
over the sea?
Yes.
No, over the sea, I don't think it's expected to function.
Approximately.
Is AI is expected to?
It,
Oh, no, there's a particular term for it. It's not over the sea. What's the term? It's beyond the horizon, over the horizon.
Okay.
I'm talking only about vessels within the horizon, where I can see it standing on the deck. If I can see it while standing on the deck, it will show up in my AI system.
Yes, it will show.
And that rate will be 99 or 100%.
That rate.
If it's over the horizon, radar will pick it up. AIS may not pick it up. AIS is direct communication between two vessels, correct?
It is direct communication.
There is no satellite or anything involved.
It can be involved.
No, is it? How does AIS function?
AIS is a direct communication between vessel to vessel, vessel to shore.
Yeah.
It can be from satellite.
Okay.
Yes.
Okay. Now, when you say proposed system, do you mean targets for proposed system? Or you've done some calculation and you think that the proposed system is going to meet this?
I have done first part like YOLO.
Yeah.
I have taken that target detection or a model prediction being done at initial stage.
Yeah.
So while doing, I have compared YOLO 5, YOLO 8, and partially doing YOLO 7, sorry, 11. So with that, there is a change, like from 80, it is being to 82%. Then now it is like nearing to 90%. That is YOLO 11.
Okay, 1 minute. This question is, when you write proposed system, this is what you're hoping to achieve. You can write like that in the beginning of your research work.
Oh.
Other thing you can do is, I've done some analysis and this is what I'm expecting to achieve. So that's not very clear to me as what those numbers represent. Okay?
Yeah.
Yeah.
Thank you.
Thank you.
Next presenter is Aryan Raj and Anjali. The topic is proposed algorithm for hull health index optimization across the vessel's life cycle.
A warm good evening all. We are here to present on our paper, Proposed Algorithm for Hull Health Index, HHI, Optimization across the vessel's life cycle. The contents of the day are background, problem statement, HHI formulation, validation, results, etc. Coming on to the background, the hull is always exposed to different types of structural failures during its life cycle. And our domain is the outer hull. And on our findings, we have found few gaps in the present assessment methods, which are assessment that are done during inspection and surveys are periodic and static, and there are chances of human judgment errors. And we find that the critical areas of degradation are not well defined, and hence we can't numerically quantify the hull. So what we are doing is we are proposing a data-driven evaluation procedure to quantify the hull. The problem statement. The problem statement, the major 4 problems we are quantifying, we are discussing here is about first one, as I mentioned, the absence of standardized numerical metric to quantify the hull structure. And the second one is the existing structural health monitoring systems that are there in civil structures or electrical are they lack what is their issues they lack predictive degradation modeling, and the data we want for the HHI is fragmented over its life cycle. There are constraints in localizing and quantifying in-service degradation progressions. HHI formulation. The proposed HHI equation by us is based on the literature analysis from different papers which we went through, that the hull index hull index formulations are given for civil structures as well as for electrical systems. Based on that, we have derived this formula of HHI, and in this, the WI indicates the AI-driven weights that are found out using machine learning systems like XGBoost, and the XI is the measured degradation indicators. The X reference I is the reference healthy baseline values, and the XI are degradation indicators that are obtained from sensor data that are present in the ship systems itself. And these degradation indicators include parameters like corrosion rate, thickness loss, etc. And based on the HHI index value, we are categorizing the hull into different categories like good, moderate, poor, critical, etc. Coming on to the methodology, first step is the data collection. The data collection is done by pre-docking surveys, sensors, inspection logs, etc. And the data we get is the input to our hull model, the AI model. The second step is the indicator extraction. The sensors collect data for different values like corrosion, fatigue, fouling. They are the machine learning tools are deriving these values, and then we get the weight term, that is the WI, and the HHI computation is being done using the formulation, and AI-based analysis also being done, and then visualization, maintenance, and planning, plotting into graphs, reanalyzing and feeding back to the model for more prediction. Proposed system architecture. This is the algorithm we developed for the hull health index. It goes like this: data collection. It is going to pre-processing stage where the data is cleaned and normalized, and it is from that there are the indicators, derived indicators are being computed using the XGBoost and Light GBM, etc. And it is being modeled using regression analysis, and then it is going to a check stage where it is divided into where it is given a score, and this score is indicating the hull health condition, if it is healthy, if it is coming under the healthy zone, neutral zone, or degraded zone, etc. And then the output value is inputted to the pre-processing stage for more accurate analysis and prediction of the missing values. Here on, I invite my co-author, Aryan Raj, to continue.
Thank you, Anjali. Now, coming to the implementation part, the implementation would include the placement of the sensors over the surface of the hull at various locations. And these sensors would include the strain gauges, accelerometers, etc. Along with that, the device would collect and sync with the system for predicting the it will predict the HHI. Then the data will be uploaded on a periodic basis to the shore model. There will be a lightweight model which would be implemented on the ship, And the exact model will be on the shore, which would on a regular on the whenever the docking is done, along with the dock survey inputs, it would be uploaded over the ML model, and then the HHI will be displayed on the dashboards of class societies and surveyors. Now coming to the challenges and limitations, the challenges will include that we cannot generalize the weighted indicators over here, because each ship will have each set of different values, and also the from vessel to vessel the set of values will differ, due to which no calibration can be done. At the same time, the limited and heterogeneous data will will make the machine learning model to have some adequate amount of time for learning, and also baseline pre-processing might require for accuracy. The limitation of the real-time data, like we might have noisy data by the sensors and all, and those data can lead to inaccurate results, which can be done by implementation of PINN models or CNN models for having better values. Now coming to the validation has been performed on a steel plate geometry as mentioned with the dimensions, and the results, due to the unavailability of sensor and survey data on any open source, we tried to formulate the data on the basis of for corrosion, we have taken the Tafler-Butler electrochemical laws for calculating the data, and for survey data we have added a noise factor, and for marine conditions the noise factor is based from 0 to 0.1. The random function in Python has been used for generating the random values and getting the values for sensor data. Then the model has been run, and RMSE and Pearson correlation factors are calculated. Then heat maps are generated for the same, and 3 locations have been chosen as mentioned over here, with varying environmental conditions like temperature, concentration of chlorine, oxygen, etc. And unified HHI for corrosion for this particular plate has been calculated. Now these are the results. The first one shows the thickness of the remaining thickness of the heat map for 0.5 and 0.5 location. We can see that this has been taken as a hotspot of corrosion with maximum concentration of the maximum concentration and maximum factors which would affect the corrosion. And for the second one, shows the thickness loss map. This is the results of the model versus synthetically generated data. We can see that both data are almost close to each other, showing that the assumptions which we have made are quite accurate as per this. And then coming to the results, the first one, the blue line, shows for the location which has been considered as a mild spot of corrosion. The second one with a bit of corrosion, and the third one has the maximum affecting corrosion factors, due to which there has been a high increase at the location of the hotspot location, that is 0.5 and 0.5 as mentioned. Now conclusion. The conclusion is development of a HHI framework using machine learning based learning and weighting modules, and continuous integration with multiple parameter degradations for a consistent and objective health evaluation. Future scope. The future scope of this includes the inference of HHI and getting a standardized threshold for the using classification society rules. We can have a standardized threshold for classifying the hull. Now what we have mentioned over here in the previous slides as 0.85 and all are proposed values, but if we can integrate it classification society rules and all, then we can have a standardized threshold for that. Also we can integrate it on digital twins, and real-time onboard SHMs can be established on ships. The environmental and operational factors can also be included in future for further accuracy, and fleet level learning can be done for multiple vessels for having a larger database and having more accurate values. And yeah, alignment with classification societies as discussed above. These are the references. Thank you.
Hi, I'm already introduced myself. What is the fancy with this number 0.5, 0.5, 0.3, 0.7? I cannot make out what exactly you are trying to convey there. Is this some plates or something? Or
So
what
it has been mentioned that plate geometry has been described with 1 into 1 meters as mentioned before. Yes. Yes.
0.3, 0.7, 0.5,
Sir,
0.6.
I
Is the
mentioned
length
here
and breadth
that-
of the plates or it is something? What is the denomination that is shown there?
Sir, this is the location. The thickness is 0.5 mm, sir, and 1:1 is the geometry which we have taken for a steel plate. And this 0.5 and 0.5 are the coordinates over that particular plate. 3 random coordinates have been chosen, sir.
Basically, locations what you
Yes, a location of 3 random locations where the corrosion might occur.
What is the validation you have done? Any validation you have done of your formula? Have you tried it somewhere?
So may I know the validation for the formulas? So
You
the
have come up with the formulas.
Yes, sir.
Any further work you have done?
So she is going to explain.
Don't mind anybody answering it. Anybody can answer this. Because my question is, you have come up with a formula. I think that is a part of your research work.
Yeah.
So now how you justify that? Because I am a class society surveyor and you have written down there it will be used in survey regimes and all this. Tomorrow I don't want to go to jail. So when you have come up with the formula, what accuracy or what confidence should I have from that particular formula? How much confidence you are giving me if I want to use this in my daily life without going to jail?
Sir, if we analyze this formula, it's like 1 minus of something. Like we have proposed the hull categories as good, moderate, and poor based on some values 85, 70 to 85. So this 1 minus indicating that we are bringing whatever value we have got into this range, into 0 to 100 range. So that is why 1 minus term is coming, and xi by x reference is normalizing so that different parameters will be having different dimensions. So that error might need not occur. So that's why dimensionalizing is done. There is a constant value and varying factor. W is the constant value and xi and x reference is the varying value. So like we have integrated into this formula, and the validation we checked on a plate is coming quite accurate. So we need to further. And we can improvise this formula further.
It's okay. It is part of this. Go on improving. Yes. And the health categories, that is your proposal. That if I can be good, 70 to 85.
Yeah, that we have.
That is your own this thing.
Yes,
I may not
that
use
also we can change if at all.
yes.
If we get real data and all.
Well, as a class, I may not do the same thing as what I may different things.
Yes.
Anyway, it is, I think the formula, from the formula, you can use my own this thing.
Yes.
What I want to get. So, practically, have you tried any I am saying any vessels further you have done? Any you could do. I'm not asking you have done, but have you tried?
So we have done a literature analysis for many papers for structural health monitoring. Those structural health monitoring for especially civil structures and electrical structures use somewhat similar analysis, sir, for the HHI formulation. So we have tried to take the same structure and we have tried to check what are all the factors which are going to affect the health of a ship. Like this same formulas have same model of formulas have been already been applied for electrical structures as well as for civil structures. So this formula, now we are trying to vary the factors which are going to affect the health of a ship. And then we are trying to give a weight as per the AI models. This AI model is going to predict like a ship might be affected by corrosion, fatigue, and many other factors. Now the AI model will try to learn from this and will try to understand that which should be preferred more, which is going to contribute more towards that. For example, we can have a 90% HHI, but out of that 90%, maybe corrosion is the one which is like it might be corroded too much and fatigue and all might be contributing less. But using this XG boost and all, we can have a predicted analysis on what number or what weightage has been given to each of the factors so that we can know that everything is matching as per the required values. So that has been the base of this formula, sir.
You know what is the approximate fatigue life of a ship? Have you ever thought of it? What would be the approximate? A ship is designed for what fatigue life?
I'm not sure about it, so I'll just look into it and I'll.
It's 25 years. I'm just trying to see whether we have gone through that.
Yes.
No big deal. I'm just trying to see. No, that is there. That's what I was asking. That's it. They have come up with that equation.
No, sir. We have come up with an equation on the basis of
that's what they have done.
analysis of many papers, sir.
That's what they have written.
Yes, ma'am. This we have, yes, sir. Yes, sir. So as of now, for a preliminary basis, we have considered only few, but this can always be when it is implemented to a large structure like ship, then the either like as of now we have considered only corrosion, vibration, strain and all. But by having a detailed analysis of that, we can have all the factors, and then XREF can always be taken as a. Yes, sir. This. So this is to show that the data which we have considered is quite is not any inaccurate data which sir, the x-axis shows the along the length of the shift, length of the plate, and the y-axis shows the thickness, sir, the loss of thickness. So the model data is the data which we have generated from the formulation, that Butler law that has been generated from that. But we don't have any sensor data as of now, since there's no open source data for that. We have taken the sensor data as the data which we have calculated using this physical law. And in order to compare it with the ultrasonic data, which we don't have as of now, we tried to add a noise factor to it, sir. Like it is, if the data is coming to be as some t, then we have added t into the noise factor. And this noise factor, we have used the random function in Python to generate a random values between 0 to 0.1. We took the 0 to 0.1 from a paper in which marine environmental conditions have been considered as 0 to 0.1. Sir. That has been the reference for this.
Yeah, very good student paper. You can continue develop this as, don't leave it. You presented in iCANOE and not the end. You should take it forward. Okay.
I hope it is being developed to such a set that we can sit in our office and do this. Once I'll be using this formula, I'll be the happiest person. Wishing you all the best. As Satish said, keep the work, don't drop it, because we are looking forward. Because now it is the age of digital twins and all, so this you can add up. So it will ease our life, because in between dry docking surveys and all, this can help predict the condition of the vessel.
Yes.
Well, good luck.
Thank you, sir.
Yeah, due to shortage of time, we are limiting the questions. So we'll go to the last presentation. Thank you, Aryan and Anjali. Minto from CSL, please come. Topic is edge-driven virtual PLC systems, redefining digitalization in modern shipping. So with this presentation of Minto, our iCANOE paper, technical paper sessions will be over. Then we will have validatory function, which includes the best paper award and feedback session. You can start the presentation.
Hello. Good afternoon all. Myself Minto. I'm from Cochin Shipyard. I'm currently looking after for the control system and operation technology part. Okay. My topic defined based on edge-driven virtual PLC systems. We'll just the content that introduction, comparison, and objectives of scopes and methodology, anticipated outcomes, and proof of concept and cybersecurity frameworks and conclusions. Based on the topic that virtual PLC, you all know about the PLC, that program logic controllers, what is the main control part of a normal vessel or a ports of the control system, of the on the logics controls or the normal ships controls. Normal ship controls and everything. The PLC is a heart of the system for all the systems. When the part we are coming for a digitalization in the normal PLC and with a normal traditional PLC, we have so many limitations. From the limitation, we are starting that topic called virtual PLCs. That virtual PLC is an edge-driven PLC based on softwares, core softwares, which compared to the traditional PLC, it is entirely different and it is a independent of the hardwares. What we are compared to traditional PLC, that OEM make hardwares will be there, OEM make dependent systems will be there, and everything will be OEM defined. In the case of virtual PLCs, the definition is going to change. As you can see the block diagrams in the regular PLC, it having the consisting of CPUs and memory. It is an OEM defined hardware code systems, which we can't do any modification and any further alteration or further updations we are going to do. Matlab, we have to face that much integration support from the OEM sides. All the hardwares are limited to the OEM definitions. In this picture, the virtual PLCs are coming to the picture. What the virtual PLC can install in the edge-driven systems, comparatively, like simply we can tell Raspberry Pi or industrial servers, single board computers, anything we can use as a virtual PLC in the same standard of a regular PLC with all the updated facilitation and integration with the newest technologies. Just we go with a comparison statement. I'm just explaining the PLC side. Normally a PLC, program logic controllers, having that input and output stage, and it having a processing capacity and a processing memories and data allocation paths. What for the controllers are used. Okay, this is a basic hardware structure of a PLC and regular PLC and that virtual PLC. We will just go for a comparison statement, what the basics of traditional PLC, that regular PLC and a virtual PLC is supposed to be gone for. In the regular traditional PLC, that hardware refresh cycle will be 15 to 20 years of time, because it is a OEM defined control systems items. What they are commonly used is OEM defined fully. If for example, the Siemens, Beckhoff, so many OEMs are there, they will manufacturing a PLC model or something like that in the market. It will exist for any years of 10 or 15 years for the commercial benefits or the obsolescence of their technology. And they are limited to the updation also because of their product quantity they have to maintain. In the case of virtual PLC, the